Hey everyone, welcome back to the MindMajix YouTube channel. If you want to master Kubernetes and pass the Certified Kubernetes Administrator exam, you are in the right place. In this CKA course, we will walk you from the basics to exam-ready concepts. Today, almost every modern application runs on containers, and Kubernetes is the technology that makes it all possible. It's a leading container platform used to deploy, scale, and manage applications efficiently. In this course, we will cover everything the CKA requires: cluster architecture, installation and configuration, pods and services, networking, scheduling, login monitoring, and troubleshooting. According to LinkedIn and Naukri, there are thousands of open positions for Kubernetes administrators, cloud engineers, and DevOps engineers in India. On average, professionals with Kubernetes and CKA certification earn between 8 to 25 lakh rupees per annum, depending on experience and skills. And if you want to learn Kubernetes course with certification, then check out our course, where we will cover latest industry curriculum, hands-on projects, labs, mock interviews, and more. Before moving ahead, I want you guys to like, share, and subscribe to our channel so you never miss any tutorials and courses from us. Now, let's get started with our Kubernetes course.
Alright, so today's topic is Kubernetes architecture. Alright, so what I've done here is I've divided this slide into two parts. One is left hand side is just a pure vanilla diagram, and eventually once we understand the pure vanilla diagram, we will move ahead with the right hand side, right, where we will onboard the components which are responsible for each master node and worker node, right, what they are going to do. So we will do like that. Alright, so as I said, Kubernetes is basically a multi-node cluster. Right, multi-node cluster means we need multiple machines. Right, now who will manage these machines? So if you see the architecture, we have a master node. Right? Master node is basically who is going to manage all the other nodes. Right? We are not going to manage the nodes. Master node is going to manage all other nodes. So that means for you and me, we have to be always there at where? Which node? Always at a master node. Right, or something like, I would say, master node is a centralized node which will do all the operations across Kubernetes other nodes. All right, so this architecture used to be called as a master slave architecture, right? But eventually in this modern era we realize that we cannot say slave to anyone, right? Not even to human beings, it's a crime. Even to say to machines also, it's a crime, right? So slave has been treated as a very inappropriate word in many countries including India. So what we have done, we changed the architecture name from master slave to master and worker. So this architecture we say master worker architecture. Alright. So master node is a centralized node. Master node is basically connected with all the other nodes, right? All other worker nodes. In the cluster, there has to be only one master node only at a time. Right? You may have, for backup purpose, you may have multiple master node. In the event of failure of the main master node, you have multiple other master node which will be working as a standby. Standby in the sense they will only participate when something goes wrong with this guy. Otherwise they will be in the as a secondary master node. This guy will be the primary master node, and this guy will send packets to the other secondary primary node so that they will be in the sync. Okay, so this guy every 5 minutes it sends packet, whatever changes or updates this guy is doing, it sends packets to the other master node, right? But they will stand as a standby only. They are as a secondary node. So the only one node we need in the cluster at a time, right? So master node won't be multiple, right? So just remember that, right? Or to just correlate to some story so that you should not forget it, right? It is always good to have one project manager rather than multiple project manager at the same time, right? Let's say if we have a small development team and one project manager comes in the morning and he takes meeting into the meeting room, and he review the meeting status from each and everyone, and whatever the priority or whatever the plan to deliver to customer in that particular specific sprint, right? Because we will talk about sprint, right? All agility and all that thing. So he will just take the status and he will be in sync with other guys. Okay, this is what we are supposed to do, and everybody is good at it, right? We are not going to miss any milestones, and if there are any issues or anything, they will discuss in that meeting, right? Imagine, right? Now the team is synced. They will go back to their seat and they'll start work up based on the priority, based on the discussions. Imagine if another project manager comes in the afternoon, right? He also calls everyone for into a meeting room, and then he also start reviewing the status from each and everyone, and he comes to know, okay, who said to do all these things, right? This is not needed, right? And he will change some priorities. He said, no, 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 these are the priorities, you should focus only on these things, right? So people will get something else, right? They will again go back and they will start working based on this project manager instructions, right? Imagine some another project manager comes in the evening, he also calls out for a meeting and everybody goes into the meeting and then they also review the status of the project, and then the evening manager will change the priorities again. He said, no, I just had a meeting with a customer and customer wants to have, in next 2 weeks we have to deliver these things, and he will change the priorities, right? Do you think the team will be able to deliver something? Imagine the situation next morning when the first project manager comes in, right? What he will get? Nothing, right? Everybody is off track, right? So this way we cannot deliver the project. So it has to be governed by one project manager only. Multiple people will lead to a confusion only all the time. Same way here also, if you have multiple master node, one master node is saying something, other master node is saying something, third master node has its own action of plan, right? And we everybody will be confused what to do. Listen to this guy, that guy, or this guy, right? Nobody knows. So we should always have a one master node only, right? To streamline and to have a smoothen process across the cluster, we should have one master node only, right? Head of family is the only one guy, right? And we always follow from him. All right. So same way, this is the head of the family, master node, right? For you and me, we need not to be right. Go to this worker node and say, "Hey, what's going on? Tell me the status." Or go to this knock knock, open the door, tell me what you are doing. Knock knock, open the door. We can't do that job, right? So we will always be at master node. And if you see here, master node is connected with each and every worker node. That is, worker nodes are connected to each other? No. That means what's going on this worker node 1, this guy doesn't know what's happening on 2 or 3. This guy doesn't know. Right? Or what is happening on the middle node, this guy doesn't know. Either worker 1 what they are doing, or worker node 3 what this guy is doing, they are not aware. Right? And so that means everybody is reporting to master node only. And whatever master node wants to do, it is connected to this node, it is connected to this node, it is connected to this node, and they will get synced. How? That I'll tell you. All right. Now, why we say master node? Master node is a management node, right? It's going to manage all other nodes. That is where we say manage node, or I would say control node. This is the guy who is controlling the operations across the cluster, right? Management node or a control node, right? Remember that. Worker node, actual work will be done by the worker node, right? Master node will say, okay, I want to start few containers here. So this guy has to do the work. What work he has to do? He has to pull the image, start the container, and go back and update the status back to the master that, hey, you have assigned me the task and I'm able to start the container and application is up and running, right? So that is how this guy will delegate the work to these guys. Work will be done by the worker node, right? And then this guy will update the status and they will be in sync. How they will be in sync and what are the other things, how they communicate, that I will tell you, right? Just understand a very simplistic way flow, right? Once you understand this flow in a very simple manner, then I'll tell you who is doing what, right? Who is doing what is very simple. Everybody has a dedicated role, they will do accordingly. All right. Now the question comes, how many worker nodes you can connect to one master node? What is the size of the cluster? So up to 5,000 nodes you can connect in a single master node. That means in a single cluster, I can have up to 5,000 nodes. When I say 5,000 node means there will be one master node still, right? Always remember only one master node. Otherwise, right, take the story of project manager, right? Multiple project manager will always lead to confusion, right? So 5,000 nodes. So that means this would be my master node and 499, right? 4,999 will be my worker nodes, and only one master will be managing. So up to 5,000 nodes we can connect to Kubernetes cluster. It is pretty huge cluster, right? And that's the reason Kubernetes is the most favorite out of the world's technology. It is the most favorite technology which is being used across all the platforms, not only for development, testing, or a product based company. Every business we are using it. Gaming industry, shopping industry, even go to meeting, right? Even gaming industry is boomed up so much, right? I'll give you a few stories, right? Pokemon and all that thing little later, right? So Google is running few parallel clusters every day because one cluster itself is so heavy. So Google is running few parallel clusters to do a proper load balancing and to handle the world's traffic, right? It's a global platform. Google is a global application, right? Whole world is using. All right, so there are so many things, and the technology has been proven in last 2 3 years, mostly in the era of COVID. Right, everybody was locked at home, and we were locked down in the home, and we were still working. We were connected through the technologies. Right, we were be able to deliver the work. We were able to do the communication. We were able to coordinate and communicate all our work channels, day-to-day activities, everything in a synchronized with the rest of the world. Right, being locked down at a home. All right. So the power of technology is already proven multiple times, right? And the whole world has tested this time, and we boomed up, right? Because of the right technology in place, right technology in hand. All right. Now let's move from the right hand side and see how each guy is going to play a role, so that we can understand the other semantics of Kubernetes cluster, other nuances of the Kubernetes cluster. Let's move to the right hand side. So this is my master node, and all these are worker node. As I said, they are connected to work. Master node is connected to each and every worker node, and there is no connection, intermittent connection between worker nodes. There is no connection. They are directly connected to work master nodes. All right. Now, master node has four core components. Remember, right? Always four core components. People may ask in the interview, what do you mean by master node? Tell them master node has essentially four core components, right? Now these four boxes lead to these four core components. Let me give you the information about these four core components. If you have etcd, right? Etcd, what do you mean by etcd? Yesterday I was saying about the inbuilt database of Kubernetes. So etcd is the inbuilt database of Kubernetes. All right, this is the database. This database is an encrypted database. All information, the secrets, right? Yesterday I told you the secret, password, login credentials like username, password, token, database connection string, front end to connect to back end. We use encrypted tokens. Everything, those information, those sensitive information, we cannot put it on flat files, right? So this will be stored inside this database of Kubernetes. So etcd is Kubernetes inbuilt database. Do you need to create it? No. When you set up the cluster, this guy will be automatically created by Kubernetes engine, and it will be turned on because you are going to use it. All right. So when I set up the cluster, I will also create it, and I'll tell you how Kubernetes is going to create it, how this guy will be started, and how the inform will be stored in this. All right. So there are various APIs and all that thing which are inbuilt on top of it, but we will talk about it. Right. Don't worry about it. It's very, very simple. Right. So it is etcd is Kubernetes database, which is one of the core part of Kubernetes. Now, what this guy will store? All across cluster information, right? What is the IP address of this master node? How many pods are running, right? What is the IP address of this worker node? What is the IP address of this worker node? What applications are running, right? What pods? Pod means container, right? Whether single or multiple container here, multiple containers are running on each worker node. So all the information will be stored here. So this guy will store the cluster-wide information of the cluster. Right, all the information of the Kubernetes cluster will be stored in this database. So how it will create the records? One record will be created for worker node 1, and all the information will be captured. Another record will be created for worker node 2, all the information will be captured. Another record will be created for worker node 3, all the information will be captured. Like that, like that, like that. This database is having all the details. Right, as I said, master node is a centralized or a controlling node. It has all the details available with him. All right. Now the other guy we call API server, right? This guy is going to serve, right? So we have a server component. This guy is going to serve the day-to-day activities, right? So we have API server, or I would say the API server is the main core component of the master node, and rest all three components, etcd, scheduler, and control manager, are the sub component who will support this guy while serving the day-to-day activities. Alright, so API server is the main guy who will be doing all the operations, right? And the supported components who will help this guy to do a job diligently, all the other guys will be helping him, right? So as I said, the database. So this guy will get to know all the information. If this guy wants to talk to worker node 1, it will say, hey, tell me the IP address of worker node 1. If this guy wants to talk to worker node 3, hey, tell me the what's going on in worker node 3. So likewise, every detail he will get from this database itself. No need to go and say, knock, knock, open the door, tell me what's going on, right? No need. Or go here and say, knock, knock, right? Open the door and say, what's going on, tell me, right? I want to do survey of each and every activity. No, not possible. He cannot go to each and everything. He will be always sitting here as a big boss only. right? He has delegated the role to the people and get the status and get the work done. That's it, right? So this guy is our main guy who will be doing everything, and these are the supported components, right? Now let me talk about scheduler, right? Scheduler, as the name itself indicates, scheduler means to schedule something. If I want to schedule some pods on this node, I'll talk to scheduler. Hey scheduler, can I accommodate few more pods on the worker node 1, 2 or 3? Right? Who will give me the information? This guy will tell me the information. Right? So this is the scheduler. Now what else the scheduler does? Scheduler maintains the inventory of all the worker nodes. Then only the schedule will be possible. Otherwise it won't be possible, isn't it? So this guy maintains an inventory in a file, right? This maintains all the details of the worker node along with the present status or along with the current status, what's going on. So if this API server wants to deploy a few additional pod, this schedule will say, oh, we cannot go to worker node 1, it is already busy. Right? Last time we scheduled some pod, so it is already busy, right? Serving the request above 80%, right? 80% means up to 80%. So this guy is already busy, we cannot go. So who will take he will look at the metrics. Oh, worker node 2 is also busy, worker node 3 is available. So this guy will do plan, and so it will go and tell API server, hey API server, worker node 3 is available for the next scheduling. So the next scheduling, this guy will say, okay, let me deploy some new pods on the worker node 3 because that guy is available. So this guy maintains the metrics of all the worker nodes along with the current status, and this guy will always update the API server. Whenever new deployment will come, this guy will tell him where to go. So that way there is no congestion. Alright, there is a clear cut path where the pod will be go, and that way this guy maintains the status, so it will not be overloaded. Otherwise this guy say, hey baba, enough, I'm already overloaded, why are you sending me new pods? I will die otherwise, I have no resources to manage. Then this guy will also say the same thing, right? And there will be chaos. So we have given a dedicated responsibility to the scheduler. The scheduler will maintain what? The inventory of all the worker nodes. That is one. Another thing is it will also maintain the current status of each and every worker node. So the status information will be available at the scheduler itself. I need not to go and check and ding dong, open the door, tell me the status. Ding dong, go to worker node, open the door, tell me the status. Ding dong, open the door, go to worker node 3, tell me the status. I can't do that job. There are 5,000 nodes, right? That means my deployment schedule, it will be never be scheduled, right? I will be always hunting for the right information across the 5,000 nodes, imagine. So this guy will always be ready with the information which I need. What is the information I need? How many nodes are there and what is the status? All right, and how? Well, very simple, it maintains the metrics. Right, it maintains the metrics. That's it. It will look at the table and tell me, okay, where this go. The scheduler will help me where the pods will go. So master node controls, right, the scheduling of the pods and all the thing deployments through this scheduler. All right. Now let's talk about the one more guy, controller manager. So Kubernetes has hired one manager, right? Why manager we need it here, controller manager? Because there are many controllers. Yesterday I was talking about few controllers, right? There is a node controller, there is a token controller and replication controller, which we spoke yesterday, right? Which will create the cloning, which will create the replicas. Exactly the same instance can be created as a multiple instances on multiple nodes, so that we can do the load balancing. Few requests will be served by worker 1, few requests will be served by worker node 2, few requests will be served by worker node 3, like that we do. So many controllers are there, he will do the job. Now what do you mean by controller? Controllers does a specific task only. One controller cannot perform all the tasks, no. So we have, for each type of task we have a multiple categories of controllers, right? So replication control will only help me to create replicas. Token control will only help me to store the tokens, and as and when it is needed, it will provide the information, right? It will be in the database, etcd database. API server will get the information from the database, right? As I said, this etcd database, we cannot access this database because of Kubernetes, because of the security, right? Kubernetes maintains a very high security level at itself. It doesn't trust anyone in this world. So etc database, nobody can steal the info from this database. Though you are the admin, I am the owner of the cluster, no, we can't do that. Only API server, because this guy has to serve, right? We are not going to serve anything, this guy has to do the serve. So this guy will get the information. So it can see the information only in the database. Nobody else can see the information inside this database, only API server. Even the schedule control manager, they cannot see, only this guy. All right. Now, controller manager. So there are many controllers, right? Application controller, token controller, node controller, deployment controller, right? Many controllers are there. So API server, whenever it wants to perform a specific task, it will talk to the specific controller, right? Then there are many controllers. So who will manage them? So API server has hired one manager that, okay, I have hired one manager and let the manager manage my other controllers. Right? What is the job of manager in simple words? Manager is the guy who is going to manage the project. We say project manager. All right. The guy who is going to manage something, we say manager. Right? So manager here in Kubernetes, manager is going to manage all the controllers. So whenever Kubernetes wants to do a specific task, it will just talk to manager and get the work done. Manager in turn will assign the task to a particular controller. Right? Kubernetes API server will not be busy and talking to each and every controller. No, it doesn't have a time. So it has hired one manager. Right? So it is something like the CEO of the company. Right? The CEO of the company, whenever he wants to track the status of a project, the CEO cannot go and talk to each and every developer. Right? If the CEO will go and talk to each and every developer, right, will he get the exact status of the project? Right? Never. How? Let's say, let's get into a situation in the same scenario. Let's talk. So let's say there is a development team and the CEO wants to have the status of that project, right? He is the owner of many projects, but let's say he wants to check the status of our project, right? So he will come to Shivani and say, tell me the status of project. Shivani will say, okay, I'm doing this thing, but I'm not sure I will be able to deliver because I have so much dependencies, right? I have so much dependency on Subbu, Prashant, and various other folks. Until and unless they will deliver me, I won't be able to test my work because my work is dependent on their work. So CEO is confused, right? Then when CEO will go to another team guy, okay, can you tell me the status of project? He say, yeah, I am doing this thing. My estimation is 2 weeks, but I'm still getting some error, right? I'm getting some issues. I need to get some clarification from the customer. So I've scheduled some meeting. Let's see, right? The CEO will again get confused. So now everybody is giving different story of their only or their work because they know only their work. The big picture that they have no idea. Yeah, they know only about their work, and that is how they every day they discuss in the stand-up meeting also that this is the task I'm working on, this is the task I've completed, this is my showstopper. If you provide the information, I will work on this task. Otherwise, I'll change the priority and work on something else. That is what we do every day on the stand-up meetings. All right. So the CEO will be confused. So it is always good to talk to the manager. Manager has the inside outside story in his mind. He works with the customer as well as the internal teams and the individuals, right, who's managing the team, right? He's working with each and everyone. So it is always good idea to talk to the manager to get the status rather than go and check each and every work developer, right? We'll always be confused. So manager knows, okay, what are the priorities being set, what we are going to deliver, what is the plan, what is the agreement with the customer. He already has a meeting with day-to-day updates with the customer, and he's in sync with both the teams, internal, external, both. Internal means that his own development team, external means customer. All right. So API server will talk to the manager and let the manager manage all other controllers. The job of controllers is they will do specific task. Replication will create only replicas. Token will manage only the tokens. Right? Node control will manage the information across the nodes. That deployment is responsible to deploy the application, whether it is deployed, not deployed, all the state information, everything, each and every stage, it will keep on updating the information to API server through these controllers. All right, so we need not to worry about it. There is a manager allocated already in the Kubernetes cluster who will delegate and get the job done. We are not responsible, right? We will be talking to API server what's going on, right? Where my pods are scheduled, right? All that we will check here. So for you and me, if I tell in a layman's term, right, what is the front end where we will be checking all the day-to-day activities of Kubernetes? Only API server, right? We have no access to etc database. We cannot say, controller manager, who told you to do this? Don't do that. Can you please do me a favor? Please do this job, right? We cannot tell anything to controller manager. He will say, hey, boss, who are you? Go to hell. All right. So this guy will listen only to API server. Same way, scheduler also. I cannot say, oh, don't trouble worker node 3. He's my dear friend. Please don't trouble him. No, only trouble these two guys. They are not my friend. They are bad guys, right? This is good guy and he's my real friend, right? Don't trouble him. So we cannot tell to do a partiality and don't give any work to this guy. Let him relax all the time. and let do all the hard work will be done by the other guys. We cannot do that, right? Human beings might be thinking in those lines. We do all the favoritism and all that thing, but the machines, it cannot do that. All right. So etcd internal database Kubernetes, it will be accessed only by the API server, right? At what time at what point we can get the information? We will get information through API server only. How? That I'll tell you. All these things are very simple. Don't worry about it. Right? Scheduler will maintain the inventory of all the worker nodes and the current state, what's going on at the worker node in terms of managing the metrics, right? So it will maintain the matrix. What is the CPU utilization here? Okay, already 70%. What is the CPU utilization here? 40%. That means it can accommodate few more load till it reaches to 80%, because threshold is 80% by default. If you want, we can change the rule, but that is 80% is default. Worker node 3, right? Only 10%. So what is right decision? The next deployment or the next pod should go where? On worker node 2 or 3 only, right? Not to 1. Right? So that is how we'll get everything from the schedule itself. Controller manager, whenever I want to do specific task, I'll talk to the controller manager. Let the controller manager assign the task to the controllers and get the work done. All right. So these are the essentially 4 core components of master node. Master node, since I said it's the managing node, it will manage all other nodes. It manage all the day-to-day operation. So we also say control node, and all these objects, the core components, we say control plane. Right? In aeroplane, the pilot, he has a front panel, control panel, right? Control panel, all the options, right? His navigation bar, his handle, or various temperature of the engine, the frequency of the engine, right? What is the airflow? What is the inside temperature? Everything he can see, right? What is the fuel? How much fuel has been loaded? That everything he can track on the front panel itself. He not to go and open the door and say, okay, let me go and check the temperature of my tire, right? So he will be, every information is there in the front panel. Same way for master node, all information will be provided by these 4 core components, right? Not too many, but only 4 core components. They are essentially needed. If any one component is not working, right, Kubernetes won't be able to do the job in its a proper way, right? To do a job in a streamlined manner, these 4 components should always be healthy. And who will check the status whether they are healthy or not? Remember, yesterday I told you service discovery. This guy, right? So when you set up the cluster, the service discovery will be created. This discovery will maintain the health check. Every 20 minutes, it will go and check whether etcd is healthy or not, whether API server is healthy or not, whether scheduler is healthy or not, whether control manager is healthy or not. Only these 4 components health will be checked by the service discovery. Only the master node component, not the worker node. Remember that. Worker node component, this discovery will not be done, only for master node, because master node is my controller node. It will control all the operations. So the health check of master node components are essentially needed all the time. They should be healthy. Right? Worker node, fine. If one worker node is not working, that's fine. I can use other worker node. But if master node is not working, then nobody is working. Right? So master node is essentially always be healthy, and for that we already provision one service who will do the health check and tell us whether it is healthy or not. All right. So master node, now master and worker node, right? So family introduction. How do you give the family introduction? Do I need to tell master node means etcd, API server, scheduler, controller, manager? Do I need to tell this thing everything? Right? No need. We can just say master node is nothing but a control plane node, right? It has all. It is just like a control panel. API server is the main guy who will be operating all the operations with the help of the other 3 components. So other 3 components are the sub component. Main guy is API server. All right. Now, master node, we say control plane node only. Don't say master means etcd, API server, schedule control manager. It is something like when somebody visit to the neighbor. Let's say somebody comes to my family. My friend has come to my family, right? And the neighbor is also there outside. So how do I introduce? Right? I cannot say, okay, he is the father. His name is so and so X, and he has a son, Mr. Y, and the Mr. Y has his wife Z, and the Z has the 2 kids she's managing. Then the whole, this is not the introduction. The flow of introduction should be, I will just give the family name. That's it. All right. So we always say control plane node. That's it. Right? Don't give the details of each and every one. That's not the right way of introducing people. Just give the family name. That's enough. All right. So this is the master node or the control plane node. right? Control plane node you will see when I more talk in the cluster. When I set up the cluster, that time you will see master node also called control plane node. But I'm just telling you that I will be calling by other name of master node is control plane node, because it is going to control all the operations, right? Instead of saying managing, right? So we say controlling the all the activities, day-to-day activities. Alright, both are same, no difference, right? When I say master node or a manager node or a control node, that means I'm referring to master node only. Alright, now let's talk about the worker node. Worker node components are very less. If you see here, there are only two components, kubelet and kubeproxy, right? Pods are the common thing which will be always running on these machines. But the essential components, if you see here, kubelet and kubeproxy, and they are available on all the worker nodes. So that means master node has 4 core components. Worker node are going to have only 2 components. Right, so that way if you are talking about the numbers, the number goes like this: master node has 4 core components, worker node has 2 core components. Right, now what are these 2 core components? Kubelet and kubeproxy. Right, don't worry about these names and terminologies, we will get used to it. As I said, it is expected when we learn new tools, right? The new terminology, all that thing is expected to learn. Right, so kube means Kubernetes. The first 4 letters of Kubernetes we say kube. Alright, so kubelet and kubeproxy. Now let me give you the information. Kubelet, what is kubelet? Kubelet is the essential heart and soul core component of worker nodes. All worker nodes should have this kubelet. Right? What is the job of kubelet? Kubelet, in simple word, I would say it is an agent of the master node. Right? So master node, what it has done to talk to this guy, it will has put one agent on each and every worker node. So whenever I want to talk to this worker node, the API server will talk to this agent kubelet. Hey kubelet, what's going on? And this guy will give all the status back to the API server. So the communication between the master node and worker node happens through kubelet. Why? Because kubelet is the agent of master node. So master node has put one agent on all the worker node to streamline all the day-to-day communication. If I want to talk to him, right, it is very easy. It is something like I've given you the mobile phones to my team members. Whenever I want to reach anytime 24/7, right, I can reach to them through the mobile phone. Right, so that means we have streamlined the communication process between the manager and the teams. We can sync up, right, and rest of the world also. If anybody wants to reach out, they can call me on my number. Alright, same way, the API server master node has put one agent on the worker node, and through this agent, they will talk to each other. Right? So that means the kubelet is the head of family of worker nodes. Right? All these activities will be monitored and managed by kubelets. So what is going on this machine, right? This is a local component. What is going on this machine? Only this kubelet will know. Will this kubelet will be able to give me info about worker node 2 and worker node 3? No, because there is no connection. Are the worker nodes connected? No. Are the worker nodes connected? No. They are only one-way connection, right? Master and worker only, right? Between worker to worker, no connection. So this guy knows only about this machine only. It is a local component, right? It doesn't have anything. Let me use spotlight. Can be right? So this guy will talk to this guy only. This guy is no connection, so this guy doesn't have anything to worry about the other nodes. This guy has to worry only about this node. So whenever API server wants to talk to this guy will talk to the kubelet through this agent. And then what's going on here? This guy will, what is the job of this guy? To update the status, right, to API server. And to update the status, how? Just by saying yes and no, or in detail. In detail always, remember, not yes and no. It will not say, okay, I've given you 2 pods. Is it deployed? Yes. That is not the status. Give me the status. What is the status? Image has been pulled, container has been started. Okay, what is about the other container? Okay, image has been pulled, container has been started, both are in healthy state. Right? Everything this guy has to collect the status and send back to API server. That is the job of this kubelet. So to communicate between the worker node and master node, who is the guy? Kubelet. Alright, same story goes here. If this API server wants to talk to this worker node, whom it will talk? It will talk to the kubelet of worker node. This worker node. Every worker node has their own IP addresses, right? And the schedule will give me IP address of this guy and this guy and this guy, and it will never conflict. So through the IP address, I'll come here, and then who will give me the information? This agent kubelet. If API server wants to deploy some application, right? Whom it will tell? It will send the requirements and instructions to whom? Kubelet. And based on the instruction which it receives from the API server. I'm specifically saying API server, right? So don't worry about API server means master node only, but who is the guy? API server. So I will specifically say API server. Whenever I say API server, that means master node only. Don't get confused. There is no other API server, only one API server in full cluster. All right, so don't get confused. So API server is our main guy. So this guy, whenever he wants to assign any new pods or any container to be started, this guy will tell to whom? To kubelet. It will send the instructions to kubelet that okay, here is the image of my Nginx server version 1.19, right, or my SQL database, right, 5.67, right, or any other application. I will tell to this guy. This guy will do all the job, right, and then update the status each and every stage, right, each and every stage. Okay, it has finished one task, go and update the status. Okay, first task has been done, now I'm picking up the second task I've done it, third task I'm not able to do, I'm failing doing this task. What is the reason? It will go and update the status. Okay, I couldn't complete it, I couldn't succeed doing the third task. What is the status? This says failure. Then master will look at it, what is the reason of failure, and then it will initiate the action accordingly. All right, so kubelet is the main guy, right? Now kubeproxy. Kubeproxy is just a proxy, right? What do you mean by proxy? Proxy is something like firewall. Because these pods are running here, people will start very soon. People will start accessing the application, right? So the traffic will come where? On worker node, right? If this guy is already busy serving the request, my request where it will go? It will go to this node, right? And who is the where my application are running? Here they are running, right? The replicas, few pod is running here. The same replica is created and running on this machine, so I can access maybe from this or this based on the traffic. My request if come goes here, I will be able to access my application from this node, or if there is too much traffic and it is already busy serving you, my request may come here, right? How the routing will happen, that I will tell you. That is again a very simple process, don't worry about it, right? So now this guy cannot open the door all the time, say hey I'm here, access me, hey I'm available, why don't you access me? It's not like that, right? As I said, Kubernetes maintains a very high security level at itself, right? So because of the security, what we have done, we have installed one firewall here. What is the job of firewall? To filter the traffic, right? So this guy is my gatekeeper. All the requests will come here at the kubeproxy, and let the kubeproxy will decide if the request is valid, then the request will be passed and it will be served. If the request is not valid, it will reject it upfront, right? It will reject it here. So this guy firewall will validate the request. If my pods are running on port 80 and somebody wants to access on port 5000, right? Will this guy will allow to access the pod? No way. Only port 80 where my application is running, not the 5000 or any other pod. It will reject it. All right. So this is the gatekeeper. Or in simple word, if I want to give you a story, when I'm constructing a house, let's say this is the highway road. All right. This is the highway. Many vehicles are passing day in, day out. Right. Now, this is my house I have constructed. If there is no boundary, right? If I don't have put any boundary, then anybody can come and park the car here in front of my gate, right? Imagine if big bus or big lorry will come and park in front of my gate. How would I move out? How my family members will go out, right? And who will take care of these guys? These are unknown people, so there is no security, right? So what we do whenever we construct a house, what we do first, we construct a wall and we put a gate all the time. If I'm a big shot, I'll hire some security guards, and 24/7, the security guards will monitor who is coming in or going out. Otherwise, I will take care of my own self by locking the door. Right? When night, when all my family members are going to sleep, I will ensure that this door is locked so that nobody can enter just like that. No intruders, nobody. Right? So Kubernetes also have a gate, right, which will only get open when the request is valid. So this job is given to whom? To kubeproxy. So when anybody will try to access my application, it will be first validated, verified here, and then only it will be, my request will be served, right? So that means this guy does two things. One thing is verification, validation, and second thing is, right, it will also, right, it will basically help me to route the traffic. It will do internal load balancing. So let's say the traffic is coming, it has validated the request and it will sending the request to this pod. So this pod will be, how much request it will serve? Only till this pod reaches to 80%, it can send request to this pod. When it reaches to 80%, right, it has to maintain one matrix, and as soon as it reaches 80%, it will update the status in the matrix. Okay, this guy is already at the 80%. It will start sending requests to the other pod, right? Not to this guy. Hey, Baba, enough, right? I'm already serving the request, right? 80%, right? Don't send me traffic, otherwise I will die, right? If nobody is there, nobody listens to him. 85, 90, 95, 96, 97, 98, 99, 100 and blow off. This guy will die. Same thing, this guy also 95, 96, 97, 98, 99. Still requests are coming 100 and blow off. Right? We don't want to get into that situation. Remember, yesterday I said once you give the application to Kubernetes, Kubernetes is a committed tool. What commitment it gives? It says your application will always stay in healthy state. How? We have a process in place. We have a right resources in place who will manage my traffic. So this guy will also do the validation verification, plus it will also do the internal load balancing between this only on this node. There are multiple pods. So one worker node can have many pods, right? And each pod is going to have an IP address. Kubernetes assigns IP address to each and every pod, so they will be always unique. IP address, duplicate IP address is not possible at all in technology. It's just like my mobile number. My mobile number means it's mine only, right? Your mobile will be different, right? It cannot be same. So same way, this guy will maintain the list of IP address, which pod. So it will keep track. Okay, it's already 80%. Before 80%, you need not to worry, because this guy is capable to handle the traffic. As soon as it reaches 80%, this guy will start routing traffic to this pod. Or there are 3 pods, then pod maybe the third pod, or maybe 4 pod, maybe 4 pod. So by default, right, we can have 10 pods by default, right, with 1 CPU, 1 GB RAM, which I will be using a free instance of EC2, 1 CPU, 1 GB RAM, right. 10 pods is the ideal count in terms of the number. If you want up to 10 pods, this guy can run 10 pods, this guy can run 10 pods, this guy can run 10 pods with 1 CPU, 1 GB RAM. If more, based on the CPU and utilization, we have to upgrade the nodes. We have to upgrade the nodes, that is one choice, or add additional nodes, because we have a capacity to up to 5,000 nodes can be connected. All right, so very simple. Kubelet is the agent and kubeproxy is the firewall, which will do internal load balancing also. Right, in my PDF I've given all the details, so don't worry about it. Here I'm giving you all the verbal thing, but in my PDF it's all handwritten, that what is kubelet, what is kubeproxy and all that thing, so don't worry about it. I'll be sending you the PDF today. All right, so same thing goes here, right? So whenever API server wants to talk to this worker node, it will talk to this kubelet and say, hey, what's going on, right? And then this guy will go and update the status back to API server. All right, so these 4 core components, essentially they do a great job, and these 2 core components of worker node, they also are going to do a great job. Any confusion, guys? Any confusion so far? Don't worry, when I create a cluster, we'll again arrive at the same slide and I'll do one-to-one mapping with etcd server, with API server, with scheduler, control manager, and what is my control plane node. That is all about, we will see in the cluster lively. Kubernetes, right? Let me tell you this thing also. Kubernetes is a lively application, right? What do you mean by lively? When I say lively application, it is something you can see everything transparently, right? It is something, for an example, if you want to see a live match, football match or a cricket match, right, to get the live experience, where you should be? You should be in the stadium, right? So Kubernetes Live, you are watching a match by sitting in the stadium, and you know what is the expression of the batsman, how far the bowler is running, what is the placement of the other opposite team, right? When the batsman is hitting the ball for 4 or 6 or might be some runs, right? What is the expression he's carrying? Sorry, what is the expression? I can see him lively, right? How far the bowler is running and what action he is doing, what action he's throwing the ball, and how hard this batsman is hitting the ball, and who is running behind the ball, right? How they are talking to each other, right? Who is shouting, right? We can see each and every nook and corner lively from my bare eyes. All right, so we can see the whole periphery lively, because I'm watching each and everything. Nothing is hidden. So Kubernetes also, it will not hide you anything. Everything is going to be very, very transparent, right? And mark my words, whatever I am saying, I will show you each and everything once we go inside the cluster. All right, it is not like it's a commentary. Somebody is watching the match and somebody is telling me the story. Oh, Sachin Tendulkar is playing the ball and now he has hit the 4 run. Now the score will turn from 96 to 100. Right? So first 100 already reached in 1 hour. Right? But I don't know what action, what was the expression Sachin Tendulkar hit, how far the bowler, who was the bowler, what action was done, what is the chemistry between the opposite team, who is running behind the ball, right? I don't know. Commentator, whatever he's saying, I'm assuming, start dreaming the thing. Oh, this might Sachin Tendulkar must be happy. Oh, now he's reaching already crossed 50. Right? So no commentary. Right? We are going to see a live match all the time. Right? And not somebody is telling me commentary and then I'm getting to hear and imagining so many things. No. Okay, so whatever I said, each guy will do a job diligently and we are going to see it and how the Kubernetes works in day-to-day operations. All right, and we are going to see all these things in detail. Right, so let's move ahead. All right, so what I've done is I've rotated this diagram. All right, this diagram I've rotated into 90 degrees. So instead of having these horizontal pods, let me turn into 90 degrees. So this will become vertical and these guys will also become vertical. So let's go and see it. If we see here, this is black and white, not that colorful, right? You have boxes in various colors, green, blue, orange, right? And light blue, all these colors, right? So now these are black and white. So same thing, right? Master node, when I say master means 4 core components: etcd, API server, scheduler, and controller manager, right? Worker node means kubelet and kubeproxy, kubelet and kubeproxy, kubelet and kubeproxy. Is master node components are available on worker node? Can you see the master node component? Any of these components available on the worker node? Is no, right? None of these components, etcd, API server, scheduler is not available here. Is the worker node components are available on master node?
No.
Worker node components, kubelet, kubeproxy, so they are different. Always remember. Alright, master node components are different than worker node components. They are not same because their functionality is different. Master node will do different job, worker node will do different job, right? But if I look at the slide, there is still some common things between master and worker node. What is that common thing? Looking at my slide.
Docker and Kubernetes.
Exactly. All right, you catch it right, right? So Docker and Kubernetes has to be there, whether it's going to be my master node or worker node. Docker and Kubernetes has to be installed on each and every worker node. Right? You must be wondering, no pod is going to come on master node. Why we need Docker here? Because Docker will help me to create containers. Why we need it here? Right? We need on master node, right? Because in some situation, if this guy is stuck, worker node is stuck at creation of container itself, then how this guy will know? Right? How this guy will know what Docker process it failed? Right? So to get the details, I should have a Docker engine. Then only I can able to understand. Right? So we need to have this thing. Now, is it always true that okay, no pod will be running on master node and always running on on the worker node only? The pods will be running only on the worker node and never be on master node. Is it the always the thing? No. By default, master node will not run any pod. But during the emergency situation, let's say I don't have any worker node available and I don't want to do investment by adding one more machine or purchase a new machine and add into my cluster. I don't want to do investment. So during the emergency situation, even I can allow some pods to come on the master node, right? There is a lock. We have to open that lock, right? Then once the door is open, once the main gate is open, we can onboard the pod. But during emergency, right? What are the use cases that I will talk in detail little later? I don't want to confuse you or don't want to overload you with too much information. But it is possible to onboard the pod even on master node also. We have to open the log, which we say shielding. All right, so that is also possible, but in the event. So we need Docker here also for many reasons. All right, so Docker and Kubernetes are the common thing between this worker and master node. All right, now what is, as I said, right? So this structure you should always remember, right? For you and me, the entry gate is what? Can I go and enter into worker node 1? Oh, this is very close to my home. Let me go and enter from the back door entry. Can I go to the worker node 2 directly? Or can I go to worker node 3 directly? This is my favorite guy. This is my dear friend. I should go and meet him. Can I do that in Kubernetes? No way. You should always be treated as a guest, as a master node only. Right? You cannot go and say, hey, knock, knock. Why are you running this pod? I don't need it. Delete it. Right? I don't need it anymore. Delete it, please. You say, who are you? So They are connected to master node, so master node can only control, we cannot control them. So that means for you and me, we should always be at master node only. We cannot control, so there's no point going there with the worker nodes. We always stay with master node. Or let me tell you the story so that you should not forget it. So let's say in our office, this is the main entry gate. That all security guards and everything is there. We have to go with our badge ID, right? If you don't go with the badge ID, security guys, they don't know. Might be I might be working 5 years, but still they will, because of the policy, they have to verify my ID. It is not like, okay, let him, oh, we already know Prashant is your friend, let him go, let him go. No, it's not like that. Sometimes the faces are same, right? You will find other person in other city, then you say, no, he's different, right? So we whenever you go to office, we have a main entry gate and everybody has to enter. Whether I'm coming by a car, I have to enter from here, or I'm coming on my two-wheeler, I have to come from here, or I'm taking a Uber or some other service, I have to come here. Or if I'm coming by walking also, I have to come through this gate only. There's no back entry. We can enter into Kubernetes cluster. No way, right? Or in simple words, let's say we three of us, let's say Shivani is sitting in this tower. There are three towers, tower A, tower B, tower C. Shivani is sitting in tower A, I'm sitting in tower B, and Subbu is sitting in tower C, right? So we cannot enter from this tower or this tower, this tower. No, we have to come from the main gate and park our car here. Let me use spot, right? And park here, and then I will walk down. Shivani will walk down and go to his tower A. I will go to my respective tower B, and Subbu will go to his respective tower C, right? But the entry gate is here only. We cannot enter from the back door, right? So entry gate, we have to come here, get verified. There is a beep machine, everything. We have to exhibit the card. If the beep sound says, right, if the beep sound comes, then only the security guard will allow me. If beep sound doesn't come, then they will stop me here itself. And they say, who are you? Then I say, I'm a visitor, I want to meet Mr. Subbu or Shivani, right? Then they will give a call to your extension, and then they say there's a visitor, and then you have to come and meet me here. You cannot take me to this tower, or this tower. No way, right? So master node is our main guy. And who is master node? I cannot talk to etcd, scheduler, control manager, API server. So for you and me, the front end is what? Only API server is our front end. All right. Kubernetes is a highly secured application. So because of the so much security, I cannot go and start saying and say, hey, my dear friend, how are you? Right? I don't want to talk to those guys. They are not my friends. You are my dear friends. Right? I cannot come here, or you cannot go there, or none of them can go in any of the worker nodes. Not allowed. All right. So we'll always be here. Right. So let's focus on the master node. Right. So let's focus on the master. So we have turned this diagram. So for you and me to enter into the Kubernetes, there are multiple ways to enter. Right. To enter into the master node, because we cannot enter from worker 1, worker 2, worker. This is the same diagram, just rotated into 90 degrees. Right. Kubelet and kubeproxy is the two components of worker node. Kubelet and kubeproxy of the common component of worker node. Kubelet, kubeproxy, common component of worker node, and four components: etcd, API server, scheduler, and control manager are the core components of master node. So nothing has changed. It's same. So for you and me to enter into the cluster, we will enter, right, through many ways. One is through command line. CLI is command line interface, right? CLI, command line interface, or through the APIs. There are many APIs, Postman APIs, right? Get, put, delete, right? All that we can do, right? Through APIs also we can access, or API even we can access through URL, can be exposed through API, and through the URL we can access, right? Or nowadays we have a dashboards, right? Just open the Kubernetes dashboard and you will see each node, right? And there are certain indicators. Green means all worker nodes are fine. Pod also green means all the pods on this worker node is working fine. This worker node is fine, and this is some yellow, that means few pods are not working fine. Some warning they are sending, and we need to look at it, right? So that means we can have dashboard and we can visualize the whole cluster on a single dashboard with few indicators. We need not to check all the time log files. So what we are looking at, we are looking at indicators. Green means everything is fine. No need to go and check the logs again and again. We will go mad otherwise. So just look at the indicator. Okay, green means everything is fine, right? If somebody says yellow, that means only that node I have to go and look at the particular warning. Only that node, not all 5,000 nodes all the time. I'll go mad otherwise, right? So we will have a dashboard also nowadays, right? So all these monitoring tools, and they come with a high-end dashboards, right? So we can create dashboards, right? So we have this thing. right? Or if somebody's from Power BI, right? Power BI, basically any application we can expose over the dashboard using Power BI, which is very, for data analytics and for data management, we use Power BI, if you have heard of it, right? If you don't heard it, don't worry about it, right? So as I said, this is the main thing. So you have to be here, right? Once you are here, then you can see, okay, this is connected to this worker node, this worker node, this worker node. You can see from API server. You cannot directly go here and say, hey, what's going on? You cannot go. No hi, hello, nothing. All right, so you should be here only. Now, as I said, if you see etcd, though it's an inbuilt database and it stores all the cluster-wide information into this database. Each worker node record has been created and all information is captured in this database. So this is the powerhouse, right? Imagine if database, this etcd, though it's silent, we are not going to touch or access this database on daily basis, right? So it's a silent component. If this database is not working, something goes wrong with this database, will my cluster will work as is? No way, right? Because nobody is the information provider. This guy is providing me information. If the information provider itself is not available, right? Who will tell me what is IP address of worker 1? What is IP address of worker 2? What is IP address of this pod which are running on this worker node 3? Who will tell me? Only this guy. So if this guy is not working, let's say this database might corrupt anytime, right? Just a tool, right? Or application. If it's corrupted, right? Nobody is going to provide me information and I will be like nowhere, right? So this has to be there. So to protect the database, what we do, normally in database we do active passive arrangement, right? So there's one active database and we make the replica of the database, right, as a passive, and this database every 5 minutes it will send packet to this guy and send packet to this guy and they will be in sync, right? Every 5 minutes, whatever action, new change or new update or new pod is created, right, it will send packets every 5 minutes. That's the cron job which is running inbuilt, right? Kubernetes runs a cron job. Cron job is nothing but a scheduled job which runs every 5 minutes, and every 5 minutes it will send packet to this guy and this guy, right? And they will be in sync. In the event of failure of etcd, that's etcd is crashed today, right? So when it is crashed, one of the passive etc database will be promoted, but at a time only one. So in this rectangular box, if we see, I've onboarded only one etcd. These two boxes are outside this rectangular box, right? These two are outside this rectangular box. So only one at a time is needed, not all the databases we need at the same time. So for high availability, if one of the component is not working Kubernetes, for high availability, we have to make this kind of arrangement primary, secondary. Correct? Normally we do like that. Banking, right? All banking application, we cannot rely on the primary database. Primary database is corrupted, then what will you do? Alright, my money will be flushed out? No, no way. I can still get it from the parallel database which are running as my standby or a secondary database. Alright, so Kubernetes also use this technique for high availability. We can provision this thing. Alright, so this is right. Kubernetes component master node, worker node, and our front end is always API server only. We cannot talk to this guy or this guy or this guy. No way. Only API server can talk to this guy or to this guy or to this guy. All right. It will tell to this guy and get work done. Tell to this guy and get the work done. So this is the API server who is the main guy. All right. These are the helping components who are helping him. But to secure, right, we have to do proper planning. I'll not take much time. Today, I don't think we will be installing the cluster, but that's fine because architecture itself took some time. That's fine. If you understand the architecture, then rest of things are very, very easy. Okay, so let's focus only on master. This is the only piece we will be dealing in Kubernetes cluster, right? Behind the scene, through the API server, we will be seeing the worker node. Through API server, I can see this node, this node, this node, or any other node through API server. So our main focus will be master. So let's talk about master node and then the installation of cluster, which we'll do tomorrow. So I have just one slide. Let me give 5 more minutes or a couple of minutes so that I can finish it, right? We already hit a timeline, but that's fine. All right. So master node, so responsible for managing Kubernetes cluster. Who is the main guy? The master node is responsible to manage all the operations across the cluster. So this is the main guy who will be managing all the activities in Kubernetes cluster, right? It is also called as an entry point for all administrative tasks. Any activities you want to do, it is the entry point, right? And administrative task, I've written administrative task. What do you mean by administrative task? Let's say this is the node I want to upgrade the OS version. or this is the version I want to apply a patch, or this is the version I want to attach a disk. These are all administrative activities, right? My disk is full and I want to attach some additional disk. So these are administrative activity. Can I just take out this node offline and then do all this upgrade and then again join back? No way. You have to do through master node only. This is the main controller, right? Who is controlling this worker node? These guys. So we have to do through. You cannot directly take this node out and attach a hard disk and then come back. No, not allowed in Kubernetes. Why? Because my application is running. Kubernetes is not worried about the machine resources. It is worried about my application which is running on this node. So it has to do a lot of planning. Before you switch off this machine or take out this machine, what goes wrong with my application? Right? There might be some people who are accessing this application. I cannot all of a sudden they can go offline and I can switch off the machine and go home. No. Right? For all administrative activities, we have to do through master node only. How we will do that, I'll teach you. There are so many use cases which we perform, and I've already planned in my training, and we will go through it very soon. So don't worry about it. But all administrative activity also will do through master node only. Remember that. Right? Don't think that is not related to Kubernetes. I just want to attach a disk. How does is going to make a difference? No, it's going to make a lot of difference. All right, can be more than one master node in the cluster. Yes, right, we can have, because this is also machine, right? This is also node. This can go anytime, right? Any node can crash at any point of time. Might be hardware failure, OS itself is crashed, right? Or Kubernetes has some hardware failure or something other issues, right? So for any event of failure, we can have multiple master node also, but remember active passive arrangement only. Only one at a time will be managing the team. Development team cannot be managed by multiple managers. One is coming morning, afternoon, evening, then it will be chaos. And the team won't be efficient enough to deliver anything. They will always be in confusion mode. All right, so we always have, can be more than one master node, yes, but only one will be the leader, right? Leader means the guy who's going to lead, right? That means there will be only one leader, right? We cannot have multiple leaders. Only guy who will be leading the cluster, which is my master node, and has to be one. In the event of failure, I can make some arrangement like this: master and slave, right? Or active passive, right? So passive will be promoted to active if any failure occurs, right? If you know Docker, right? This is very clear in Docker, right? The basics, in the basics itself, you have to learn all these things, right? But no worries, right? This is just an information. Just remember, only one of them will be the leader who will be leading the cluster, not multiple master nodes, not allowed. But for high availability, yes, I can have multiple master nodes, and every 5 minutes I'll send the packet and be in sync that, okay, this is what I have done, and they will be also updated. In the event of failure, this guy will resume back, right? The switching takes less than few minutes, right? But that's fine. But we should have only one. It uses etcd. So this is a silent component, but don't ignore this guy. This is the powerhouse of Kubernetes, heart and soul of Kubernetes. Don't ignore it. All right, powerhouse always have to be there. Tomorrow we'll begin with installation, right? So I'll talk more about in installation, right? All installation which you have heard so far in the market: KubeADM, Minikube, GKE, Google, EKS, Elastic AWS, and AKS, Microsoft Azure Kubernetes Service. Everything we'll talk tomorrow. And then we'll set up the cluster, right? We'll set up the cluster in 6 steps. Only 6 steps are needed, and we'll set up the cluster. Don't worry, I'll send you this PDF file today. Right? Go through it, and tomorrow we'll set up the cluster fresh in the morning. So it will take 40 minutes for me, because I'll be giving a lot of information. Installation will take 10 minutes, but a lot of information I have to give. All right, so today we will set up the cluster. All right, so for Kubernetes installation, I'll first take you through the theoretical step and little information which I wanted to give, and then we will jump on to the cluster setup. All right, so and the cluster setup we do on AWS. All right, so let's get started. All right, so Kubernetes installation. So there are numerous ways to install Kubernetes, right? So you can install Kubernetes in a many ways. And nowadays we already know that there are many vendors in the market who offers Kubernetes solutions, right? AWS has its own EKS, which we call Elastic Kubernetes Services. Microsoft has its own, which we call AKS, which is Azure Kubernetes Services. Likewise, many vendors are there in the market already, all right? So let me talk about it. So there are a few popular ways, like let me begin with KubeADM. KubeADM is basically, it's a bare metal installation. That means we are not going to take any services from any vendor or any third party. We will be bringing all the installations, all the components, whatever we have seen for master node, right? All that etcd, API server, scheduler and controller manager, 4 core components of master node, and same way the worker node component, kubelet and kubeproxy and everything, right? So we'll be doing everything on uh, bare metal by ourselves. So we'll be bringing everything, right, one by one, right? And the exam point of view, certification point of view, there won't be any exams, there won't be any questions in the exams from the third party. Right? They won't ask you any question related to AWS or Microsoft or Google or Oracle or IBM or any other cloud vendor. There won't be any question. It would be purely on inbuilt, which is KubeADM. So KubeADM is nowadays, it's also called as a universal installer. So if you know the KubeADM, you can put Kubernetes in anywhere. Maybe it's a physical data center, or maybe your cloud solution, or anywhere. So it is also called as a universal without dependency on any third party. Right. So here also we will begin with KubeADM, because in the exams KubeADM will be only the central focus. They will not ask you anything outside KubeADM. They will not ask you anything from Google Kubernetes or Elastic Kubernetes or Azure Kubernetes. There won't be any question. Alright, so it will be purely KubeADM. What is KubeADM? We will talk, and I will install through KubeADM only. Right, so we'll talk more in detail. There are other installations which are also available, which we call Minikube. Minikube is basically what happens at home. We don't have big setup. We don't have the home lab setup at our home, right? We don't have the huge machines and all that thing. What we have at home is maybe the personal computer, my personal laptop, or the home computer which we use our desktop or for our home use, right? So that is what we have at home. We don't have huge labs and all that thing. So what Kubernetes says that still we can use our personal laptop or our home computer and we can install Kubernetes. So what happens is basically what you do, you create a virtualized environment on a single node, which may be your laptop or maybe your home computer. That is single node. Single node means only one machine. All right, it's just a single node, means just one machine. So what you do, you bring all the master node core components, which are the essentially four components: etcd, API server, scheduler, and controller manager, and even the worker node component. Both put together, you will be having all the components on the same machine. So you will create a virtualized environment on a single machine, right? But this would be very, very limited feature, because here you cannot do scalability and all that thing, right? Upgrades, scalability, right? So creating multiple replicas and all that thing for load balancing, with a very limited functionality you can still do it, right? But with a very, very limited functionality. Because why? Because you have just single node, so scalability and all that things are not possible. But still you can you can get away with few basic things in Kubernetes, right? So you can create a virtualized environment by having all the components on the same machine, and then you can start your Kubernetes to practice the basic things, not the advanced things. All right, so which we call as a mini cube. Mini means just a single node installation. All right, then we have GKE, right? So GKE, let me GKE. So GKE is basically, we already know the Kubernetes is evolved and developed by whom? It's Google's baby, right? So Google engineers, they literally sat down and they wrote feature by feature, and holistically they release under all the features under the name of Kubernetes. All right. So Google also offers Kubernetes. So Google gives basically Kubernetes engine. So we call Google Kubernetes engine. GKE is the short form, right? But we say Google Kubernetes engine, that is GKE. So if you have a Google account and if you are on Google Cloud or Google infrastructure, you can still go ahead and you can set up the Kubernetes environment full-fledged as a production. All right. Same way, similarly, there are other vendors in the market which we called AWS, right? So AWS, initially when Kubernetes was launched on AWS cloud, they named it, right? Every vendor want to sell their capabilities by different brand name. So they came with, initially they used to call COPS cluster. K means Kubernetes, Ops means operations. So they used to call it a Kubernetes operations. But what happens? They did a patent registration on Elastic, and they renamed it. The COPS cluster is nowadays called as EKS. EKS means Elastic Kubernetes Services. Right? If you see, this is service. Service means there is no PaaS component, platform as a service, but it is a software as a service. So what happens is they they automated the whole installation process by scripting. Right? They created a set of scripts, and when you want to start a Kubernetes in AWS, right? What you do, you just trigger those scripts, right? Those scripts are written in sequential manner, one after another, one after another. The script will get executed, and in the background, it will start setting up the Kubernetes cluster for you. right? And it will spin up as a software as a service. You need not to do anything, right? But AWS will charge for everything, whatever they do. They will provide three machines, three nodes, so they will charge for it. If you go for 4 or 5, they will charge for it, right? They will even charge for Kubernetes as a service. They will charge because you are using AWS service. Yes, everything will be chargeable, right? But it will create a Kubernetes environment, right? So GKE Kubernetes is only the installation. I'm not saying that the whole architecture they will change. No, nobody can change the architecture. It is only the way of installation, because they are the different environment. Even the ways will be different. But ultimately, once you install Kubernetes, it all same, because nobody has capability to change the architecture. So whatever we have been discussing since last 2 days, it will remain as is. Nobody can change it. All right, so don't get confused. It's only the way of installation. That is why I've written here that there are numerous ways to install Kubernetes. So it is only the different ways how to install Kubernetes. But once you install Kubernetes, whether it's AKS, Google, or Microsoft, nobody can change the architecture. So it will remain same, right? Even kubeadm, right? So it will remain same, right? I will not talk about Minikube. Minikube is not for us, right? It is for very basic level. So we cannot create a production environment on Minikube. So I will not give more weightage to Minikube. All right. Same way, we have Microsoft also, which is doing really good in the market, right? They are AWS and Microsoft, they are competitor to each other, right? So Microsoft also launched Kubernetes as a service. Same way, they scripted the whole installation process and they are selling so that they can make the money. And these vendors, they are very clever. How to make money, they already know, right? So basically, what they do, big corporates, they don't want to get into hassles and have a separate team to do the installation and all that thing, right? So what they do, they just go with the ready-made services, and they have no problem to, right, to pay to these guys, because they will be charging with various customers, clients, and they'll get the money. And for them, it's just a peanuts to give few money to these guys. So that's fine with them, right? So same way, Azure also offers a Kubernetes as a service, which we call Azure Kubernetes Service, right? In short, we say AKS, right? So AKS, EKS, and GKE, these are only the ways, different ways to install Kubernetes on different vendor-based cloud solution, right? So Google has its own cloud, AWS has its own cloud, and Microsoft has its own cloud. So do others also, right? We have Oracle, right? We call Orca and all that thing, right? Oracle is also there, and nowadays IBM has acquired Red Hat, right? Red Hat has been acquired by IBM. So even we have OpenShift and all that thing, right? But it is only to have little changes here and there. It is only the way of installation, right? So we'll be using the ready-made service and we can spin up the whole cluster. That in the background, it will create automatically the machines, 3 machines, EC2 instances on AWS, and it will do all the installation of master node component, right? All the 4 core component, right, etcd, API server, scheduler and controller manager, kubelet, kublockchain, so many other dependent services, right? So it will bring automatically. All right, so we will not talk about any third party here. We'll focus on kubeadm, that is the universal installer of Kubernetes. And even from the certification point of view, right, you should know kubeadm in depth. All right, so we'll use the default Kubernetes engine, which is offered to us as a kubeadm. Just remember, the kubeadm is the installer. All right, so whenever you get across that, okay, where did you install Kubernetes? On AWS. Okay, how did you install? It would be EKS, right? You cannot say kubeadm. But since it's a universal, you can still go ahead and you can put it on AWS. That is how I would be doing it, right? I would be using kubeadm and to put it on AWS, right? So we'll be using the AWS cloud because we need machines, right? So AWS gives some free tier machines, 1 CPU, 1 GB free tier machines, which I can use for 1 year. That is the advantage of AWS. All right, so that is why we'll go with AWS. All right, any questions so far? Any confusion between all these installers?
No, sir. It's clear.
Okay, okay, thank you. All right, so let's get to kubeadm installation. All right, so let's get started. All right, so Kubernetes installation, right? So in this slide, there are 6 steps, right? I read these steps from the bottom, right? As I put the sequential number also to remove the confusion, right? So just follow the sequence, right? So the step one means you need 3 machines, right? And you can name the machine. So first will be my master node, then I can say worker 1, worker 2, like that we can name it. So essentially, we need 3 machines minimum. right? We need 3 machines minimum. We can start with our environment. As and when we onboard more application, we can bring 1 more machine or 2 more machines, like that. Like we can do scalability later, right? It would be just an add-on to the existing cluster. We can add on these machines later, right? So I'll show you how to add and all that thing. But essentially we need 3 machines. So Kubernetes cannot be installed on one node, otherwise it will be mini node, and we cannot do scalability and other things, load balancing and all that thing. So we need to have 3 machines. So let me go to AWS and create these 3 machines, then I will name it, right? Out of which one will be my master node, other will be my worker node. So worker node 1 and worker node 2, we can create it. So let's go to AWS. All right, so this is the URL. You can go here and bring it, or what you can do, all right, and then sign up, right? Sign up for free. It will not ask you anything, but for validation and verification, you need a credit card, right? Because what happens is these hackers are very crazy people. What they do, if you offer anything free, what they will do, they start using the free services for their own intentions. Intentions means bad intentions. I'm talking about bad intention means they will use for hacking purpose. So when AWS launched, it was offering everything free, right? And these hacker people, they are crazy people. They start using AWS, right, infrastructure, and trying to hack the various customers across the world. All nuances they used to create, right? And AWS was getting the bad name in the market, so they started a practice that only the authenticated users should use AWS, not the hackers, right? As a hidden and crazy people, and they can do whatever they want to do. They have to stop it. So they stopped it by introducing a verification validation process. So basically, what they do, how they will verify, right? Because we are in different geographical locations and everybody wants to use it. So how to offer the solution, right? So universally to all the people. So what they have introduced, that okay, you give us your email ID and your credit card number, right? So they will do some transaction on your credit card just to verify that you are holding this credit card and you are an authorized person, right? But the transaction would be very, very minimal, right? In India, they take just 2 rupees, right? And immediately they deduct 2 rupees, and after verification, they will reclaim you. They will reload the 2 rupees, whatever they have deducted, back to your credit card. So that means they are not taking any money, but for just verification, they have taken just 2 rupees, right? With just the peanuts, right? Less than the peanuts. All right. Same way, if you are in US or Europe, they will take 1 USD, right? $1, or in euro, they'll take 1 euro, and they will reclaim you. It will be reclaimed back to your credit card, right? So there won't be any loss to you, right? So they will ensure, but it's just for validation, verification, right? And your email IDs and everything, because they will send activation link to your email ID, right? So no fake here, no faking, all right? So don't, no fake accounts or no fake credentials not allowed, right? Because they'll do verification, right, by sending the activation link, and that is a good practice also, right? But we can trust these guys. Don't be scared that okay, I have to expose my credit card, right? We can trust these are the world leaders, right? So we can trust these guys. Microsoft, Google, AWS, these guys are the world leaders. So don't be scared, right? So we can do that, right? If you have virtual credit card, that also can be used, right? So if you are using Paytm and you've created a virtual credit card there, you can still go ahead and you can use it, right? You just need the existing account and it should be authenticated. That's it, right? So anything is possible, right? But they will not take you any money, right? Just go and create your free account, right? This account is very valid for 1 year, right? As a free of service. After 1 year, they will start charging you, so that you can stay with AWS for 1 year, and if you like the AWS service, you can continue the account. Normally, people what they do, they create another account after 1 year, right? So they will get again 1 year free. So that is the practice people use. So when you create it here, you can just see it here, sign in for the console, right? And they'll ask you your role and what you are interested and all that thing, right? So whatever you are, application architect, business analyst, or whatever, IT administrator, executive, software developer, whatever, you can just give it here. All right, anything is fine. I'm interested in what, right? So let's say DevOps, right, which is very popular, and then it will take you to create your account, right? So it will automatically try to log in me because my name is already here, right? But when you sign in, you have to do it. There are, right, it will automatically guide you. Next. Key in your information, your first name, last name, mobile number, email ID. The OTP will be sent to your mobile number. Email ID will need it for sending the activation link, right? And at one point they'll ask you your credit card also, right? And once you are here, right? Then you can do everything, right? You can check at they will create your account ID. This will be your AWS account ID, and this would be unique. Nobody has this ID, only you. So you can always refer if you need any support or any help or anything. You can just stick to your ID, right? And then your account, organization, service queue, billing, and dashboard, right? So let me show you that also, so that you should not be scared while using the AWS. All right, so you see, it's not even $1, and I've been rigorously using it day in day out. Right, so that is how they will charge you. Right, so in India it is less than 100 rupees in short. Right, so not even more, not even 50 rupees, not even 0.5. Right, so it would be very very less. Right, so they will just take, because I use few high-end machines, that is why they are charging. Otherwise it's free, right? So for us also, we will just go that. Once you have your account and everything is in place, all right, just come here. You can just go, there are many things, credit, payments, and make payment and all that thing. Everything will be here, right? You can browse this thing in the left hand scroll bar is for you. You can just navigate and see all the preference. It's very easy, right? So I will not waste time over here. Once you are here, click on this AWS and click on this 9 dots, right? 3 into 3 row. Click on this here and click on the EC2 instance. EC2 we call Elastic Cloud Compute. Right? So in short, we say EC2. There are two C, right? Elastic Cloud Compute. So cloud compute, two C. So in short, we say EC2. Right? These are virtual servers in the cloud. Right? So just click here. It will open the dashboard. If you see, this is EC2 dashboard, and all resources in the central pane, you will see all the resources here. So currently, if you see, I'm not running any instances. Instance in AWS is nothing but the node or machines, right? Virtual machines, right? So it is, I'm currently running nothing, right? So you have to just click it here, right? And then don't get confused. First time when you start using, you will be using this top bar only. This top bar, just remember, right? So this option, connect instance state actions and launch instance. So the first top bar we will be using it, and the inform will be displayed over here automatically, right? So currently nothing is there, right? It says no matching instances are found, right? So what we do, just use this orange button to launch, right? Because I want to launch few instances so that I can use for my Kubernetes cluster setup. All right, so just click on the launch instance. Right, so when you come here, launch instance wizard, right, give any name, right, my server or anything, you can give name. So I need worker node, so I will say worker node, right? With reference to Kubernetes, I'm giving the names. You can give any names, right? So worker node, so I will say just worker, right? And then which OS you want to load, right? Right. So AWS also provides Amazon Linux, right? AWS is just doing the branding. There is no operating system which AWS gives. It's a Linux only, but they are the facilitator, so they are just using their own brand name as AWS, right? You can use Mac also, no problem, or Ubuntu. If you guys are aware of Ubuntu, anybody is aware of Ubuntu?
Yes, sir.
Okay. Okay. So Ubuntu is basically new flavor in the Linux family, right? And it is much more easier, much more heavyweight in terms of security, right? Over other previous Linux versions. So nowadays everybody is using Ubuntu. All right. If you are fine, yeah, please
Can
go
we
ahead.
do the practical on Red Hat? Like,
Red Hat,
if I will try. Hmm?
Red Hat, you need so many things, right? Red Hat will charge you left and right center. Because what happens is Red Hat, you cannot create your infrastructure and all that. It will automatically provision the infrastructure, right? And then it will take few services here and there, and it will start charging you. And I don't want to just charge for just our learning purpose.
So we can create our setup on VMware.
Yeah, you can create. If you have VMware, you can create it. No problem.
So on that, like on VMware, I can have the Red Hat. Like it's the same or it's a different? That's I want to
No,
ask.
no, it's just the same. Red Hat also use Kubernetes engine. They don't have their own engine for Kubernetes.
Okay. Okay, sir.
Okay.
Thank you.
Yeah, yeah, sure. So you see where we have Microsoft, even Red Hat, and few more, right? If you just little go ahead, SUSE Linux and all that thing, right? These are renowned players in the market. All right, but nowadays everybody is using Ubuntu, whether it's a Microsoft or it's a Linux or anything. We are using Ubuntu. Ubuntu is the enterprise favorite Linux operating system because of the security layer. Right? They have very tight security layer, right? And it's very easy because it will guide you automatically, right? Hardening and everything is an inbuilt capability. So we'll use Ubuntu. If you know, well and good. If you don't know, don't worry about it, right? It's all same, right? I will be teaching you on the fly, on the go. Right, so few Linux command here only. In REGL we use OS, and here we'll use Kubernetes and all that. Few commands difference, but the functionality will remain same. All right, now which Ubuntu? So when you select it here, it will come here, right? So wherever you select, it will change. So if you go to Red Hat Linux, which is recently came in the market, right? So basically underneath layer is Linux only, but they have their own flavor, right? They do their own branding. So the commands and everything, they will have the different commands for getting the same functionality. So let's stick to our Ubuntu as a standard corporate favorite. Right here, Ubuntu, they come up with 22.04 is the version which is the latest. But when you just click here, because you have a drop down button, you click here, you have so many versions. Right? This LTS, don't get confused with LTS. LTS means long term support. Right, so the long-term support is very big name. They have shrink to the shorter name, which is LTS, long-term support. Right, so that means we can use anything. So I'll go with free tier. Right, these are all free. So let me use the previous version, which is much more stable. Let's not experiment with the new version. Let's go with the stable version. So this is the 20.04 LTS, long-term support, right? And it's free tier. Everything is written here, so you should, right, be not too much bothering that okay, AWS will charge me. I'm going to use this. AWS will charge me. So AWS straightway is telling it is free tier. They are not going to charge you. All right. The 64-bit architecture is by default, but if you want to change, you can change it. Right? Okay, they made it default. That's fine. All right. Then here the instance types. So here are the various configurations of the machine which we have. Right. If you see here, right, there are many things. So one CPU and 1 GB RAM. One CPU, 1 GB RAM be a free tier. Right, one CPU, 1 GB RAM, which is again free tier, absolutely free. And for Kubernetes, we can use for this thing. Right, and if you use any other operating system like Windows, SUSE, or Linux, they will charge you. Right, that is what I was saying when Shivani asked me the question. They'll start upfront charging you even for the free tier also. Right, if you see the price here per hour, it would be 0.0716. Right, though it's a few pennies, but still, right, why to give unnecessary? But it will be free tier if I go with Ubuntu. Right, so it's a free tier. Right, but if you want to use for high thing, you don't want 1 CPU, 1 GB RAM. Right, you can choose anyone. Right, so if you see one CPU with 2 GB RAM, right, two CPUs and 4 GB RAM, two CPU 8 GB RAM, like that, but we will stick with free tier only, which is one CPU 1 GB RAM. Right, and for worker node it is good enough. Right, worker node it's good enough, so we'll stick to it. Then key pair is basically the login thing. Right, in AWS we don't use username and password because how long password you can remember. Right, at the max 12 digit, 15 digit, or if you are a super smart, how long? 20 character password. Or if you are super smart, right, 30 characters, and after a few days you will forget the password. Right, and again you will be struggling with new password. Right, to keep a short password, long password, and then you will lost it. Right, so this is not safe. Right, so what AWS uses? AWS uses key pair. So basically there are two keys. One is public key. Public key always stay with your account. When you create your AWS account, it will stay your public key here with your account. Only you can see when you log in. So your public key will be stick to your AWS account. There's a private key also because it basically creates pair of a key. Pair means two. One is public, one is private. Private key is available with you on your wherever you want to keep it. You want to keep it on a mobile or on your laptop or your personal laptop, right? It will be downloaded on your laptop and it will be available only on your laptop. So it is very safe. Whenever I want, I will provide that key from my laptop or from my mobile and I can use it. Right? It's very safe because it is nowhere it is available, only with personally with me, and wherever I want to keep it on a very hidden folder, whatever path, it is up to me. Right, so that way it is very secure, safe and secure. So always go and create it. Here is the button of create. Once you create it, you can reuse by clicking it here. It will pop up here. So I've created one key here, SRE-EC2 key. Right, so I use this key for my login credential, but it's very straightforward. When you click it here, you just give the name of the key. You can give any name. You can put your name, let's say DevOps key. You can give DevOps key. right? Or anything, right? It's just a name. You can give any suitable name, right? You can give any name, it will take it, right? So this is the key, and these are the encryption techniques which it use. RSA we have been using traditionally. RSA is there. This is the new technique where we can do encryption of my private and public key both, right? With ED 25519. This is again an encryption format which we use. So we can use either of them. It's encryption inbuilt, right? So we don't care much about it. By default RSA, you can use RSA. And when this file, private key file will be created, there are two formats. One is the .ppk file, right? Normally, if you know the putty to log in, putty is the basically Linux console to log in with Linux machines. Remotely, you can log in with this utility, putty, right? So you can use the putty format, which is .ppk format if you are comfortable with putty, because for Linux, when we said, so by default, the putty is the console which comes into the mind to log into remotely to any Linux box, right? So we can use or .pam file, right? All these are binary format, right? Open SSH and all that thing, they use this format. So here also we can create into the same format, right? .pam or .ppk, it doesn't matter. It's just a file, right? So both are supported. So I keep always default, and it create, and then just hit the button create key, and it will be created, right? And then it will ask you, right? When it will be created, it will ask you, please download it now, right? Or never, right? Now or never. Never means it will give you only one time to download that key. Otherwise, you will never ever get that key, because AWS is not going to store that key anywhere. So you have to download it immediately. Once you create, you have to download it. Once you download, it will be available on your laptop. If you want, let me quickly create it. All right. So this will be created, and next time when you come, it will be listed over here like this. All right, it will be listed like this. So I will go with my own key, SRE key, right? Let me go with my previous key. I will not use the new key. And then network settings, right? Network settings, you can create new group. New security group means where you can enable the port numbers and all that. By the way, Kubernetes uses default port number, and default port number is 6443. Right? It's very easy to remember. 443 is HTTPS port number, so add 6. So 6443, right? So once you create it, you can start using, right, existing, right, and it will be again list. So all are drop down only, right? So don't use default. I created my own wizard, launch wizard, and I'm using this security group, right? You can use default or anything. It's just a create group, and then it will be available here. How to use it, I will tell you, right? How to use, I will tell you all that thing, don't worry about it, right? And then configuration, right? So by default, this free tier comes with memory, right? What is the storage memory? 8 GB memory is free, right? This is not encrypted, which is fine, right? And it is free tier, all right? Up to 30 GB I can take it, right? So up to 30 GB I can take it. So I'm good with 8 GB is good enough for my test environment, Kubernetes environment, right? And then, right, before you hit this button, this is the button to launch. With this configuration, whatever you provided, it will launch. Number of instances, right? So I've created worker node instances by the name worker here on the top already. How many instances I need? I will go with 2, because in my diagram it says 2 instances, isn't it? So how many worker nodes? 1 and 2, right? Then later we'll create master. Why I'm not creating master? Master needs slightly higher configurations, right? So that is the reason I'm not creating with the same configuration of worker 1 and worker 2, right? Master will create it separately, but it will be very fast, right? So how many instances? 2, worker 1 and worker 2, and just click on launch instance, right? I'm very slow, and don't worry, this session is also getting recorded. You will be provided. By the way, you are getting the recordings or not of the previous sessions?
Yes, sir, we are getting.
Okay, good. So you will get this recording also. All right. So once you say launch, it is created. There are 2 instances. I means instance, and some number, unique number ID will be generated by AWS. So don't worry about it. Just click on this and go inside. Right. We are back to dashboard again. Right. How we went there to create instance? By clicking this button. As I said, always stick to this top menu bar only. Don't go with too many options. Only the top menu bar. That's it. Right. That is your bibliography at this point of time, right? Don't focus too many things at the same time. This is the thing only here. And if you pull this guy slightly down, right? It's showing instances. Let me take this filter out. So there are two instances, worker, worker, because we give worker. So let me do the naming here. Let me say this is my worker one, right? And when you scroll your mouse here, it will automatically give you options, right? When you take away your mouse, the option will go. So it's just like a greeting option, right? So bring it here and say two. So worker one and worker two. So no confusion, right? And these are the instance ID which we just saw, right? When it created, it generates some ID. It's internal ID for AWS reference, right? And this is the name which I gave. So worker one, worker two, both are in running instance, right? And T2 micro, which was the family 1 CPU, 1 GB free tier, which we have chosen, right? And you see other things, right? What is the IP address, public IP address, right? Private IP address of this machine. If you want to see this machine, right? Unselect this and this, it will tell you here. And you can see the name also. This is related to worker one, right? And when you say here, this is related to worker two. Everything is available here, so don't get confused. All right, we will talk about it, right? And then port number and all that we will talk. Or if you are confused, go to EC2 dashboard. Here it will say now you are running two instances, right? And the security group which we created, or if you want to enable some port number, always use. So default, I'm not using default. This is my security group. I've created separately for Kubernetes and various other purposes which I do every day. So this is my security group, right? And then you have inbound and outbound rules. So you can see all the port numbers here. Let me drag a little bit up. All these are, right, drag and drop, pull up, pull down, all that options are available, right? So if you see here, these are all port numbers I'm using, right? Port range. So 2377, it's a Docker port number, and Kubernetes port number, as I said, is 6443, right? If you want to edit, just click on this edit button and add any port number, right? Add any port number, right? So I use for various purpose, so let it be, this is Kubernetes default port number. If you want to add new, just click on new, right? And just give the port range, right? Port number is here in this column, this, all right? So give, add and give the port number here, 6443, and open for all, right? So 0.0 means anybody can access, so open for all. If you want to whitelist, give the IP address, right? You can define your IP addresses also, right? With by this range, you can define, but I'm not whitelisting anything. And when you say this already exists, it will throw me an error, but that's fine. I'm just showing you. This says it's already exist, right? Already exist. So this is how we do all that thing. So always stick to EC2 dashboard and then click this button, right? So these are the thing, right? Click this button. So currently I have set up these two machines, worker one, worker two. Let me go and take master. So I will just go click it here again and say master, right? Any name, right? So I'm going to, I already have worker one, worker two. Let me have master node this time, right? Same thing I'll take Ubuntu here, which we chose last time, right? Which operating system, right? We'll not go with the latest, we'll go with the pretty straight, which is the 20.04, which is more stable, and it is free tier again, right? Not going to charge me anything, right? Here also free tier, but as I said, right, 1 CPU 1 GB, 1 CPU 1 GB is not enough for master. Master, the minimum requirement is 2 CPUs. Right? When you say 2 CPUs, this is the requirement, but it is not free tier. Right? This guy is not free. Only one node which we are going to use, nothing else in AWS, and this is not free. This is going to charge me 0.001 cent per hour. Right? That means in a month, if I take, right, it will come to 0.26, right? Because it's 0.001, right, which is very quick. In a month, it will be less than, in Indian rupees, less than 100 rupees, right? Which is bearable, right? So in a year, if I take, it will come to around 1000 rupees in a year, which is fine, because I'll be creating a production based cluster, right, by paying 1000 rupees per year or just a $10 per year, which is fine, right? In a month, it will be $0.5, or at the max, right, it will be $1 only, which is bearable only for this particular instance, because we are going to use slightly higher configuration, right, only for this, right? So this 2 CPU 1 GB is not free tier, which is be incurring some cost, but very little, just peanuts, right? So that's fine only for this thing. Otherwise, rest of thing, everything is free. Whatever I've created, right? So security, this login secret, this pin key pair, everything is free, right? So don't worry about it, right? So this is, just remember, master node should be 2 CPUs, and by default it is coming with 4 GB, which is fine. But and this is just a starting configuration. We are not using a very complex machine, right? 32 GB, 32 CPUs and 64 GB RAM. We are not using that. It's very, very simple. So don't worry about it. And then again, I'll log in with my same credentials, right? And then existing group. Everything is, I'm using the default thing, right? So I'll use this launch wizard. Here I have already added 6443. 6443 port number you have to open on all the EC2 instances. That is the Kubernetes condition.
Yeah, you haven't selected that, like the, what is that? Can you scroll up, please?
Mm-hmm.
Yeah. So you said the instant type, you haven't selected, right? Did you?
Yeah, I selected 2 CPU, 4 GB RAM.
Oh, okay.
I selected by clicking this button, right? By default, it gives free tier, 1 CPU, 1 GB.
Okay.
But for master
Okay.
node, we need 2 CPUs. So T2 medium is my category, remember.
Okay. Okay.
Which comes by default with 2 CPU, and it is selected already.
Okay. Okay.
All right. So just remember, only for master we need 2 CPUs. All right. And then same login pair and all that thing is fine. Existing group, I've chosen my group. You can create and then you can add port numbers later and all that you can do. Rest all is fine. How many master nodes I want? I want just one instance. So let me say launch this instance. Only one. Right. It is also created. It says successfully initiated the launch of instance. This is the number. Click here and go in. In means dashboard, EC2 dashboard, right? If you click on the EC2 dashboard, you could see all the instances here. So there are total, how many instances? There are total 3 instances, right? Total 3 instances. Which are the 3? Click here. You will see these are things: master, one worker, and another worker node. So worker 1, worker 2 are my worker nodes, and master node. Master node, you see T2 medium, which we have chosen. All right, and these two are T2 micro. All right, so this is how, and you will see all the info, public IP address and all that thing. We will be using it eventually, so don't worry about it. We'll be very soon, we'll be jumping onto it and we'll start using it. All right, so you can see it here, all here configuration, right? Ubuntu operating system and all that thing. It will basically give you some kind of summary, right? So let's log into this machine, right? Now from AWS, how to log in from my laptop, right? So we can use Putty, right? So to use Putty or anything, this is the button. As I said, always stick to the top menu bar only, right? Don't get confused. So now we click this launch wizard last time, and now you whatever you want, right? Here you have all the options. You want to do network security, you can just click here. Instance, whatever you want. You want to reboot this machine, you say reboot. You want to terminate. Terminate means remove it, delete it. You can say that, or if you want to just stop it, you can say stop. Right? Don't stop. It is always advisable to go with terminate. That if you stop, they will still, that this instance will be charged. They say you are holding my storage, right? Because storage is loaded, right? So it will charge for storage. So don't stop this machine, always terminate. And we can set up Kubernetes cluster in 10 minutes or 5 minutes, right? Today it will take time, but more normally it will not take much time, right? So we will try to do that. So let me go ahead and connect to these machines. So I'll say connect. So when you come here, just use SSH client, right? EC2 instance manager we don't use, we use SSH client, which is straightforward. And here are the steps, 4 steps to connect to this machine. How to connect? It says open your SSH client, right? Which SSH client and which machine I'm using? Master node. This is the name here. SSH client means anything, Putty or anything you can use, right? I don't use Putty. I use slightly different. Anybody heard of the name MobaXterm? Anybody familiar with MobaXterm?
Yes, sir.
Right, MobaXterm is basically GUI based. Putty is a very old-fashioned tool. MobaXterm gives you a lot of visualizations. All right, so I can use MobaXterm. Yeah, I think he's from Linux side.
See, I think she knows everything. I am like a poor kid here, I think. Okay.
You will get to learn many things, right? In our this Kubernetes.
I know only Linux. Okay. That's why I know these Git bash, Putty, Mova, Storm.
Yeah, that's more clear. But
yeah, and the guy who is comfortable with Linux, they use all these utilities, login utilities, because these are the basic for them.
Okay.
I'll send you this URL. Don't worry about it. MobaXterm. Let me first explain, then I'll send you this URL. All right, MobaXterm. So use this utility to connect. This is basically SSH client, right? MobaXterm is SSH client. You can connect any machine, Windows machine, Linux machine, any machine, right? It is very user friendly, and it comes with two versions. One is professional edition, slightly costly. It comes around $70, $69, right? And basically they will give you support. That is the only difference here, right? So they'll give you 12 months free updates and support and all that thing. So for corporate, they go with this tool, but for us, we go with home edition, which is absolutely free, right? So let's go here. Here, no support. Here, they give support. That's the only difference, right? And 12 machines, 12 sessions I can create, right? So at a time, in single window, I can have 12 parallel machines can be connected. So that is the GUI. That is the beauty of this guy. A lot of inbuilt macros and all that thing. So I like this tool. So just click here and download. When you come on the download page, you will see two options. One is MobaXterm Portable and Installer Edition. Frankly speaking, I use this utility and this utility, both are same. There is no difference between blue and green. You can go with any one. When you click it here, it will just download the utility. If you see it, start downloading. It's just a zip file. Unzip it and then do right. Then click, and 3 click it will get installed. And this is the symbol of MobaXterm, right? So this is how you can also create it, right? It's very simple. So let me share this link on the chat. So MobaXterm, this is the MobaXterm screen, right? Always click this button, middle button, right? You can use this option, right? You can create any server, tool, game, session, right? Split window, multiple windows, all that thing. I'll talk little later, not today, right? So just click here, right? And how many machine? This is for my master node, second window for my worker one, third window for my worker two. So parallelly we can do, and we have to install Docker on all the machines. So I will do parallel installations. So I'll go with this option, multi-execution. This option is available here on the top bar. If you see here, right? So you see this option is here, multi-execution, and just click all three windows. It will open it here parallelly. And when I type, the beauty of this tool, when I type, it will replicate on other windows. That means simultaneously I can do parallel installations, right? So when you say clear, it will clear the screen, right? So just go back to our thing and start installing Kubernetes. All right, so let me connect from here, master node, right? So use this option. Select the machine, which machine you want to connect, right? Don't select all of them together, right? One by one, and click on the connect button. When you click connect, or take the SSH client option, the third option, right? So open SSH client. So I have opened, this is my SSH client. I already opened it. First step is done. Locate your private key file, right? Wherever your private key, my private key file, it will tell that, okay, this machine configuration, you log in with SRE2, so locate your private key. As I told, private key will always stay with me only. Public key with my AWS account by default, but private key available with me. So locate your key. So locate, so what I have done, I put it one folder on desktop, and here one folder I created EC2 instance. And if you see here, LSSR, you see this key is here. So locate means go to the path, right? So navigate to the path. So CD and go to the path. This is the Linux command, CD and go to the folder path. So my desktop folder, under that EC2 key, I have stored it here, or I can just show it here. So under the desktop folder, this is my EC2 key, and here I have this key. There are so many keys I created, the DevOps key and all this. This is my key, which I use. So this will be available only with me on my laptop. Nobody else can take it. So that is the path I've given it here. And then what it says, just follow the steps. So step 2 is also done. Locate this key. I located this key. Then run this command if necessary to ensure a key is not publicly viewable. That means in Linux, though I am the owner of the file, but until unless I give the read permission, nobody can take this key. Even for myself also, whenever I want to use, that time I have to say read permission. How to give read permission Linux? By using chmod command. Chmod and 400 is the read command, and we give your file name. This is my file. So we give viewable means read permission. Don't get confused, right? So we have to give read permission. And this is the notepad symbol. If you click here, the command will be copied. So it will be very easy to wherever you want to paste. I want to paste it here, right? SRE key, SRE key. So copy will not paste. When you paste, it will not replicate. But when I type, it will be replicated on other windows. So you have to paste on all the windows. Now I paste. You see, Ubuntu gives you green tick. Green tick means this command is executed properly. Red tick, red cross means the command is having some issue. So this command is executed. I will get the confirmation also in Ubuntu. As I said, Ubuntu is very, very smart operating system of Linux. You will get to see all these graphics and all that thing. So I've executed this command. I've given the read permission, chmod, change mode, change mode to what? 400 is the Linux read permission, and then this is my file. So I've given read permission for this machine, and this machine. 3 is also done. Step 4, last step, connect to this instance by public DNS, and here is the public DNS name or example also they've given. I always take the example because I log in through command line. SHS is the command. This is my file which I've created, and Ubuntu machine. This is the public IP address or the DNS name which is here. This DNS name. So we can directly log in with this DNS name. This and this is same. So don't get confused. So this EC2 instance by default this come with a Ubuntu user, but this user is very normal. But let's log in. So always the fourth command always use copy command. Which is my master node? This is my master node. So I'll copy it here and press the enter key. It will get login. You see, I'm logged into this machine. Right, so these
So
four steps.
first one is the 3 screen you are showing in that SSH.
Yes. Yes.
All 3 are like master, worker, and worker. Is it?
Yes.
Okay.
Right, all these 3 screens are here.
Okay.
Right, if I want to exit from this thing and I want to see single screen, I can see the first screen, second worker node, third worker. Or if it's confusing you, let me rename this tab. So this is my master. If it's confusing, first screen I always keep master, that is my habit. But for you to avoid the confusion, let me name it. This is going to be my worker 1, and this is going to be my worker 2. So 3 screens are there. What did I do? I use this option, multi-execution option, middle option, this option, and I can open parallelly.
And you are actually, can you go back to the AWS EC2, please?
Yeah.
So in this, you are actually doing an instance of master only, right?
Yes, only master. So I've connected only master. If you see other machine, I have not yet connected.
Oh, okay. So you just, you just
Yes.
opened it and you haven't done anything.
Yes.
Okay, I got it.
Yes. Okay, so now I will go and connect to worker 1. Master I already connected, worker 1, same thing, click on connect, and these 4 steps. So these 2 steps we already did. Even 3 steps we already did. So what we want? We only want 4th step. This step I did repetitively, parallelly on other machines. If you see CS mode and all that thing done. So this is my worker 1. Same way, let me go back quickly and then select the worker 2 and connect. And this step 1, 2, 3 is already done. Only 4 step. I will copy this key and paste on the third window, right? And then I'm logging. All right. So now if you see, I've logged in to this machine with Ubuntu. This is the IP address of machine 172.19.188. This is different IP address 24.218, and this is different 17.196. So I've logged into all 3 machines, right? If you want to clear the screen, you can clear the screen, right? So we are logging with these 3 machines, right? Now this is normal user. For installation, we use root privileges. Right? We need admin privileges for installation in Linux. Right? For that is admin is what? Root. So I use one command sudo and then one space su. Su means substitute user, or you can say super user. Who super user? Root user. And put a minus sign, right? Space and minus sign. So sudo space su and minus. This sudo is basically root command in Linux. Whenever you want to log in with root, use sudo and substitute user. It will substitute, and minus means it will not ask me password. If you put minus and it will not ask you password, directly it will allow you to log in with the root user, which is the admin user. So when you type, I've typed it here on the 4 window, right? All the 3 windows also it is replicated. Just say enter key. You see the root, the earlier user was Ubuntu. Now I've logged in with the root user. It will switch. So I've logged in with the root users now, right? And this is the command I use. Don't worry, I will provide in my notepad file, right? So, but if you want, I can put it on the chat quickly.
You're not doing it parallelly, so it's okay.
Yeah. All right, and then clear the screen. So we are logging with the root on all the machines. Now to set up the cluster, I already have one file in your folder. Let me go back to your folder. I keep it. So I created one folder, Shubhu Sivani 11th April we started. This is your folder, this is your email ID, and let's begin with Kubernetes installation. All right, so let's begin with Kubernetes installation. Now the first step, right? Or let me go to the slide.
So far you have done like
Only
creating
step
this
one.
like
Yes.
okay, so created a master worker node. Okay. Now you are going to install Kubernetes. Okay.
Docker.
Docker.
Yeah. Step 2 is Docker. Docker needs to be on all the machines, and step 3 is Kubernetes. We need to install kubeadm. As I said, we'll not go with third party. We'll go with kubeadm by this installation.
Okay.
All right. So kubeadm. So you see, Docker and Kubernetes has to be there on all the machines, right? And that is what we saw yesterday, right? Docker and Kubernetes has to be there on all the machine, worker or master. Right, so I have to install these two components, Docker and Kubernetes, Docker and Kubernetes, Docker and Kubernetes. That is what the slide number step 2 for Docker, and then we will bring Kubernetes on top of it. So let's go with Docker installation. All the installation process I've created in Notepad file, right? For the ease of installation, I've set up one Notepad file, and I'm going to share this Notepad file today with you guys so that you can refer this thing. So first step is what? Install few dependent packages and Docker installation. Right, so we'll onboard Docker application now. Right, that is our step 2. Right, this step 2, Docker. How to do it? So in Linux, all commands we use apt. Right, some people say apt, some people say apt. Right? So don't get confused. Apt is the command which we use. Apt update. So it will update the packages, and then parallelly I can add one more command. Ampersand means parallelly I can add, or one by one. If you want to execute, you can execute one by one command also. But I want to execute parallel. Right. So for parallel execution, we use ampersand sign. Right. So this command will be executed first. What is the condition? This command will be executed first. If this is succeeded, then it will pick up the second command. Right. This is my second command. So apt is the Ubuntu command. What I want to do, update, and here I want to say apt. Apt will by default will come as a default, and then I want to do install. What I want to install, -s. -s means yes. Right, it will not ask me question yes, no, yes, no, yes. By default it will accept yes, 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 yes. So silent installation I'm giving yes, and it will install first package as apt transport https. Right, so we'll install this package apt transport https, because there are so many urls which we will be using with https url. So I will bring this package. These are the free dependent packages, they are free. So I will bring this package, and then CS certificates. In Kubernetes we need certificates. Without certificate, Kubernetes resource will not talk to each other. Even etcd, when API server wants to talk, we need certificate. Kubelet, when it wants to talk to master node, it needs certificate. So every resource in Kubernetes have to have certificate. So we'll be generating so many certificates also. To generate the certificates, I'm using free module. Using this module, I can create certificates for 90 days by default, right, which we call self-signed certificates. All right, we need not to purchase any certificate from DigiCert or from any vendor. Right, we can use self-signed certificate using this package. So I will download this package also, CS certificates, and I'll create self-signed certificates. Curl, we don't use browser in Linux, so we use curl utility. Curl utility where I can publish any URL or anything. The way we do copy paste of the URL on the browser, and the browser will take me to that URL. In Linux, we use curl. Right, curl is just like right, it is an option available as a browser. So we use curl and paste all the URL, give all the URLs to this curl utility. If you see, the shortcut is CURL. CURL means, is this font visible, guys, or let me enhance it?
It's visible.
Thank you. So curl means client URL. So we can use URL, and then software properties common. Software properties common, what it will do? It will automatically set the environment variables. I need not to go and manually set an variable for Docker and Kubernetes. For both, it will just set the environment variable directly. So common packages we have to install. So common properties, right? We have to install this package, software properties common. This will set the environment variables. And finally, I'll bring my Docker package. Docker package, the installer of Docker is docker.io. That is the name of Docker package in Ubuntu, docker.io. And -y, it will just do the installation without asking me yes, no, yes, no. Otherwise, it will ask me, should I take this default path, yes or no? Or if I want to change, then again I have to change. So by default, I'll say, okay, go with default parameters as yes, yes, yes. All right, so this is the command you have to select. Don't include this $sign. $sign is just a representation that this is the command. All right, so this command you have to select and say copy and paste on the windows. We already have the machine. I want to install Docker here, right click. So I'm doing Docker installation parallelly. All right, let it do. Let it take few minutes. And then I've given some comments. Comments are represented by hash. Right, dollar are represented by commands. So wherever you see $sign, that is the command. Hash is just the description for you yourself. So we are installing Docker, and then what I'm saying, after Docker installation, we can start Docker service by using the following command, right? So we have to enable the Docker engine, right? We have to start a Docker engine by starting the service. What is the name of the service? Docker service itself. So we have to enable it, and for that we are using systemctl command. All these are Linux commands, systemctl, right? Whenever you want to start services, inbuilt service or anything, we use systemctl. So I say systemctl enable this Docker service, right? So this is the command we have to use to start the Docker. So 98% installation is done. Still 2 more percent. I will wait for a while. So guys, please allow me for 10-15 minutes. Today we are setting the cluster and I'm very slow. So just bear with me, right? At least set up the cluster today and then we will continue tomorrow. I will be setting up the cluster tomorrow again, but all these stories I will not be telling you again and again, AWS login and all that thing. All right, so this is done. So let me restart here, restart the Docker engine here, restart Docker engine here. So we have fire this command. Let me clear the screen and verify whether Docker is installed. So here in the third step, what I'm doing, verification, right? I'm verifying whether my installation has gone really well or not. So I'll verify. How do you verify? By firing the Docker command. Right? If Docker is installed, then I can fire Docker command and -- version. If these guys give me an output of Docker installed version, that means my installation is done. So if I just see here, right click, and I see it is giving me the output. This is the command I pasted here, giving me the output. What is the output says? Docker version. That means the Docker is installed. What is the version? 20.10.21 has been installed with the build number, this version, and where it is installed on Ubuntu machine. Right, this is the version 20.04 version which we have taken, right? So Ubuntu. So my Docker is installed successfully here. I can verify. I could verify on my worker node also it is installed here. I could verify on worker node 2 also this is installed here. So Docker is installed successfully on all the 3 machines. That means I am done with my step 2. All right. Now let's go with Kubernetes installation. Right, Kubernetes installation. Let me go with step number 3. So don't worry, everything you have to follow in Notepad only. Don't go out of the Notepad, right? So I've put all the command. Now we can proceed with Kubernetes installation. Everything is here in the Notepad. So first step, first section we did Docker till here, and now we'll proceed with Kubernetes installation. All right, so proceed with Kubernetes installation. Now when you do Kubernetes installation, first we have to download the GPG key. Right, what is this GPG key? GPG key, right? Just hear me, guys. Right, just concentrate here. This otherwise, if you miss this step, then it will be a problem. GPG key. What is this GPG key? Right now, this Kubernetes we are installing free of cost. We are not paying single penny to anyone in this world. We are free of cost. We are going to do now in this internet space. Many crazy people are also there. Right? How would you verify that somebody has not induced unwanted files also? If somebody has induced unwanted file, and if you by default go and download those packages directly from the Google, right? As a free source available on Google, you will go and pull those packages and download it. But somebody has put some binary code inside it. Well, how will you ensure that this is a clean code and nobody has put anything inside it? How will you verify? Right? There's no way, right? And by blindly, if you go and download it, right, that means somebody's code is also get downloaded on your laptop. And these crazy people, once their code is available on the laptop, right, they can do anything. They will start writing some commands and they will start collecting the information from your laptop. And that is how the hacking is happening all over the world. Right? These hackers, what they do, all the free libraries and free software, they put their code, and anybody download their code is downloaded, and then they start hacking it. Right? So Google, to get into this trap of these intruders and hackers, Google has given us a safety. Right? What is the safety here? We should install the GPG key. GPG key is basically an encryption signature key. Right? When Google has packaged this installation file for Kubernetes, what they done? They put signature on all the Kubernetes file. Right? All the Kubernetes installation file, they put some signature, and this key will go and verify that signature automatically. Right? So this key, the vendor who creates the installer, that vendor has put some signature on all the files just for verification. That vendor also has to provide you the key because he used some technique to use the signature on the files, right, for the safety. So this key, what it will do, you have to first install the key, and who will provide? The vendor, because he has used that technique, right? So Kubernetes developed by whom? Google. So we'll go to the Google, and from there in Google apt is Linux, Ubuntu, Linux Ubuntu apt. Always remember apt wherever you see it is Ubuntu. And in the document they have given this key GPG. This key, what I do, This key I will download and add on my local machine. So I will use add command, and hyphen means by default it will get added in my local machine. Right? So we have to add this key. Once you add this key and when you pull the Kubernetes package, this key will verify all the files before even downloading on your machine. It will go to the repository, scan the files, and if all the files are clean, then only it will allow to download. If somebody has introduced some code or some binary files, right, or some any executable software, anything, right, it will just go and raise a red flag. That means it will start raising the warning that, okay, don't download this package, it has some malicious code. So for safety, right, nowadays this technique is used across all the software, whether it's a Red Hat, IBM, Google, Microsoft, everybody using GPG key. Whatever software they are providing this key also, so that we can verify the signature which is embossed in the files by the vendor. By the vendor means Microsoft, Google, or anybody else. All right, so we have to download this key. Now, so I will go and do this. So whenever you do this, it will just say okay. Okay means this file is copied on your local machine. Say okay and okay. So this file is copied. So you should get this message okay, okay, and okay. So this file is copied. Now it is safe, right? So I can go and pull. Now what I'll do, so set up the repo, right? From which repository, that also I need to tell, so that this key will just go and function on that path. This will go and scan from that path. So what I'm doing, I'm creating one file using the Linux cat command and end of file. This is just the command. Don't worry about this command. Don't juggle and don't take too much pain in your head also, right? Just read whatever I'm saying. So this is just the CAD command, and I'm redirecting, right? Redirecting few lines. What I'm sending the path. What I'm saying, go to etc/apt/sources.list. This is the folder name. In Linux, you can use dot, right? For the simplicity or ease, you can use dot, and this is the folder which I have set up, right? So it will go to etc/apt/sources.list. Inside that, it will have all the Kubernetes list of packages inside this folder. So this is the path I have to give. So I'm redirecting this path, that okay, go to this path, etc/apt. Etc is the default system folder of Linux, so don't worry, it will automatically find it, etc, right? So this path it will go automatically, and then in this path what it will do, and from which repository, right? This path from which repository. So here I'm giving the path https. So it will be apt is ubuntu.kubernetes.io is the URL. This is the URL for Kubernetes package. Inside that, it will go and choose this branch as a Kubernetes Xenial is my main branch, right? So in Git repository, if you know, we maintain the code in different branches, right? Main branch is basically the production branch, and development branch where we do the ongoing development, right? It is not moved, the code is not moved to production, so we start developing it, right? So we maintain different branches so that I can do testing on my development branch while building the code, right? Then we have test branch where the testing we can do, and then finally we move when testing is done and everything is sorted, all the issues are fixed, we move to production. So here I'm taking this branch, and then end of file handle. This I'm closing the file here. So Linux, I can open the file, redirect all these two lines. So I am creating one file and writing these two lines in that file, and then closing this command. So the cat command is basically to create the file on the fly, on the go with these two lines. So one is the repository and the branch, and then the path. All right, these two lines we can create it, right? So you have to just copy paste and create this file on all the three machines. So I'm creating it here. It's already here. Copy paste three lines and then copy paste three lines. So this file is already created, right? So we have created in this file. All right. So key, and then from which repository I will be pulling out this Kubernetes package. I'll pull out from this repository. This is the branch, and where is my Kubernetes package? In this folder. All right. So I'm safeguarding that. I'm not going to take from unknown sources. I'm going to pull the Kubernetes package from the known sources. Sorry. Right? Not unwanted, unauthenticated website, but a very known resource which I'm going to use, and very known website where I'm going to pull this package. So I'm giving in one file information. And this file I'm creating on the fly, on the go, right? By this command. So this is the just command etc, and then I write two files, right? Redirect, write this file, and write this URL, and then close the file, right? Just three lines, and then I can begin my Kubernetes installation. All right, same command, whatever we use for Docker, apt update first and apt install, same command we use for Kubernetes also, right? So this is just a comment for you that Kubernetes packages from below command, apt update, apt install, right? What is the package? Kube ADM, right? This is the package name and this is the version. and then kubelet, right? And then the third package kubectl. So there are 3 packages. Kubernetes is installed with the help of 3 packages, right? So this is the package and there is a space between. So this one package, there is a space, give the second package, space, give the third package. The way we did for Docker also, right? Space between the packages, right? So this was the package apt transport, right? HTTP space and then CSRT. So one space means this is one package, this is the second package, like that. We can put the space and bring multiple packages together. So this is what we have to do, right? So another 5 minutes I'll take and then we are good. So this package, we are now downloading the package. It will scan these packages. If any red flag, it will raise it here, right? So see the power of Kubernetes. Everything we are safeguarding, we will not get any malicious code and everything, right? So we practice. And nowadays it's a common practice, GPG key, right? So it has not raised any flag, right? So it has downloaded, scanned and downloaded here successfully, and here successfully, right? All 3 machines, no problem, right? So this is what step 2. Now step 2, we need to start the service, right? We need to start the Kubernetes engine, right? So same command we use systemctl and Kubernetes engine to we say daemon reload, we have to reload and then we start the service, right? Kubernetes engine, the name of Kubernetes engine or the Kubernetes service is kubelet. So don't get confused. Kubelet is basically worker node component and even Kubernetes service is also kubelet, right? I don't know why they are using the same name, right? But the Kubernetes service name is also kubelet. So don't get confused with that thing. So to start Kubernetes services, this is the service name we have to say. So systemctl restart the service, it will restart the service. So I'm using this command here, right? Already installation done, clean installation, no issues. So this is the command restart. We restarted the service and then clear from here, right? Now, so this is done, right? This is done. Now the step number 4, right? So let me go to step 4. So this step is done. Docker is installed on all machines. Kubernetes is installed on all machines. We started the Kubernetes engine also on all machines. Now we have to do initialization. Now wherever you fire this command, the initialization we do by one command, right? Now here you have to be bit cautious, right? Don't initialize on the worker node, right? It is only intended for master node only. If you initialize here, right, wherever you fire this command, that node by default become master node. So if you initialize by accidentally here, it will also become master node. It will also become master node. But we don't, how many master node we need? Only one. We don't need 2 or 3 master node. But in the high availability, if you want to create parallel master node, right, as a primary and secondary, you can do that. But here it is not needed. So we do initialization only this thing. Wherever you find this command, that machine by default will become your master node because it will start bringing the master node components. Right? Initialization means it will bring the component. So you will bring the component only on one machine, not all the machines. Right? So just remember that you have to do initialization here. And in my notepad file also I have written it here. Run this command, right, only on master node. Right? Don't run on all the nodes, only on master node. To initialize Kubernetes node, right, only on master node, run the below command. This is the initialization command. That basically it is the command is like initialization, right? Very big command. So what Kubernetes says that you give me only 4 letters, right? I will understand what you want to say, right? But otherwise you will make a typo error. So initialization we do through init command. Init means initialization only, right? So just go and do the initialization, right? Only on master node. So that means I don't need parallel machines. I can exit from here, right? And this is my master node. Let me rename the tab again. Last time I think we renamed it, right? But it doesn't saved it. It didn't saved it. So let me write worker 1. So left hand side window is always my master node. That is how I always have a habit. So no confusion for me. Alright, where I want to initialize only on master node. This is my master. Don't go to worker 1 or worker 2. Don't go there. Alright. So don't go to worker 1 or worker 2. Right. Always be on master node. Right. So let me go back to master node and here you have to follow this command. Right. And then we are good. Alright. So let's come here and do this thing. Now if you do here initialization, right, Kubernetes version, this is what we are doing. It does a pre-flight check, right? Pre-flight check. What do you mean by pre-flight check, guys? So let me ask you a question so that you can understand what pre-flight check is. So when you have onboarded any flight, right? I know that you must have traveled various corners of the world, and you must have traveled through to various flights also. So when you go right in any aeroplane, right, for your journey, for your onboard journey, right? Did you notice that when the pilot will be onboarded, when the pilot will come? Pilot will come before you onboarded on the flight, or pilot will come at the end, right? So a pilot can tell the crew member that, okay, you settle down with all the passengers, take them all the things and settle their luggage, and when all the passengers are onboarded, just call me, give me a call. I'm on the lounge, I'm sipping the coffee and I'm sitting in the lounge. When everybody is ready, call me, I will just come and fly the aeroplane. So did you notice when the pilot comes, it comes before passengers start onboarding, or it comes at the end when the passengers are already onboarded and settled down? Did you notice when the pilot comes?
No.
Any idea, any guess? Logically, when the pilot should come logically?
No, I think, yeah, I mean, actually, logically means he should come first and check everything.
Exactly, exactly. Pilot should not come at the end, right? He should not get, don't waste my time, I will relax in the lounge, I have nothing to do with these passengers, right? 300 passengers, you take care, half an hour. I don't want to just come and sit idle in the my chamber. I don't want to come, right? So right? So he has to come beforehand. He has to come because he has to check whether the pressure in all the tires, right? No tire is flat, right? That's the required pressure is available on the tire so that he can fly the aeroplane on the runway, right? And then he has to check whether the ample quantity of fuel is loaded or not, right? It should not be surprise for him that no fuel in the air, and then he look for the gas station. He will never ever find the gas station in the air. Right? He has to, before taking off the flight, he has to check whether the ample quantity of fuel is loaded or not, ample quantity of water is loaded or not, ample quantity of food is loaded or not, first aid is loaded or not, right? All the requirements, all the nuances which are needed for this travel to have a successful journey, right? All the things are in place or not, right? He has to ensure, he has to come always first. So Kubernetes also ensure the same thing. It does a pre-flight check. What is a pre-flight check? It check whether the Docker is in place or not, right? It will check whether Docker is there or not, because without Docker, Kubernetes is helpless. So these steps it is doing pre-flight check.
From where we are getting this version, Kubernetes version?
This Kubernetes version from the installer,
Okay.
right? We install the package, right? This package I mentioned it here, these versions.
Okay.
All right. If you want, tomorrow I'll show you, right? Kubernetes has its own website, kubernetes.io.
Yeah, these things I show already. I'm just confused on this. Like 1.21, it's the latest one that you are mentioning it, or if we are not mentioning it, still it will install.
Yeah, it will install. If you don't mention it will install, no problem. But I'm specifically, right, this version is most trusted and most stable version. So we are doing it. Later we'll upgrade and all that thing. So I have to be on one version back, so that upgrade and all that thing I'll show you going forward.
Okay. No
Because
problem.
I have to upgrade the cluster.
Thank you.
So don't worry about it, right? So this is all Kubernetes only. We are not going anything outside. It's Kubernetes only. All right, so it does pre-flight check. So this steps is nothing but a description. What step is doing? It is give you description here. Pre-flight check, pre-flight check, pre-flight check, and then it creates certificates. So where it is creating the certificate, inside this folder, this is the certificate folder, etc Kubernetes PKI. PKI is the common practice for keeping certificates. Almost all the tools. PKI means public key interface. Public interface means basically certificates and all that we keep. So Kubernetes is keeping this in here, right? And where it is keeping, if you see cert up till here, right? It's creating certificate. So as I said, Kubernetes has to create certificate for many resources. So it has created the folder in this location. We will verify that in short, don't worry. And then it creates certificate here, right? CS certificate and the respective key file. Nowadays, certificate also needs key file also. Earlier, we used to have only one certificate file .crt, right? But certificate can be stolen and they can be reinstalled. So anybody can steal the certificate and reinstall. So later what we introduce the key also to activate the certificate. If you don't have a key, the certificate is meaningless. All right, so these are the two files. So we are using CA certificate and the key for the certificate. Then for API server, remember my Kubernetes, right? Where is my slide? API server. So we are generating the certificate for this gentleman, API. API is our main guy. So certificate for API server. So first certificate we are generating for API server. And then we are using the DNS information, that what is the IP address of this machine. This is the IP address 188. This is my master node 172.31.19.1 So we are doing registration, DNS registration, that okay, this certificate is valid for only this machine, right? And this is used by Kubernetes. So Kubernetes create one default service. This is the service discovery which I was talking yesterday. This is the IP address of that service discovery, right? So this service discovery is this, which will verify whether all the resources are healthy or not. This will go and do discovery every 20 minutes and check whether all resources are healthy or not. So this will do this service discovery. Don't worry, I'll talk tomorrow also, because tomorrow again I have to set up the cluster and show you. Just give you a glance today, right? Don't worry. Then API server client, right? So if you are bringing more master node 1, master node 2, master node 3, we can call as API server. And who is the client? Kubelet, right? And we are creating certificate for it. So each and every Kubernetes has to have a certificate. Then kube proxy, which we call front proxy, we are creating certificate. And client means if I want to use some other high availability cluster, right, as a backup, then I can create even a proxy for client, also as a client proxy for my kube proxy also, right? So we are creating certificate for each and every resource. etcd, right? Etcd is my database, right? So we are creating certificate for etc database, right? So etc database, likewise we have to create all the certificates. So till here it is creating certificates. And then kube configs. Now we are creating the config file. So Kubernetes create one folder, etc Kubernetes, and keep all the config files here. Admin conf is our main Kubernetes config file. Remember that. Without this, my cluster, this is the main cluster configuration file admin.conf. And what is it? This is just a configuration file, kube config file. This is Kubernetes configuration file. Then we create one file for kubelet, right, to bring the kubelet. Then I create controller manager, right? This is my controller manager, kubelet, kubeproxy. This is my controller manager. Then I create for scheduler, right? So this for scheduler. So we have the config file for each and every component. So here kube config will create the configuration files, and then we start the. Then what we'll do? The kubelet will set the environment variable from the file. So we are setting environment variable directly from the file, and the file name is .env. Env is basically the extension of environment variable file .env. So all the variables, it will automatically pull from this file, read it and set it automatically, right? So that kubelet can connect to my master node, right? kubeadm. So all the kubelets, we are setting the environment variables to connect to master node. So this will be done from the file itself directly, right? And then all the configurations, right? So kubelet configuration, right? For worker nodes, we are reading from this file. So all my config will come from this YAML file. So all these are inbuilt, right? We can verify later also. And then finally, we started the service. Remember, what is the service name? As I said, kubelet, right? From using this command, right? Restart systemctl restart service. So what is the name of service? Kubelet. So here it is started the service, right? Starting the kubelet. Now this service will read all the files, certificate files, config file, and start creating it. So control plane, right? What is the control plane? Master node is basically my control plane node, right? It is my controlling node. We say control plane. So control plane node should have etcd, API server, scheduler, and controller manager. So you see now it is creating, reading the files from the manifest files from this folder and creating. Here it is creating. What it is creating? API server. What it is creating? Controller manager. What it is creating? Scheduler. What it is creating? etcd, right? etcd, it is creating etcd. So all the four components: API server, controller manager, scheduler, and etcd, right? So it is creating etcd, local etcd, that is local database, right? All four components of master node for control plane, right? So control plane means only master node components it is creating. And you see, creating 1, creating 2, creating 3, and creating 4. So that means these 4 core components are being created by this guy, right? And then it will do bootstrap, and then it will create one token. Now after that, what it will do? It will go and check, right? For kubelet and all that thing, it will go and check, and then it basically, this is a service, it will go, and this take around 4 minutes and 0 seconds. 4 minutes means one minute is needed for each component. So 4 components, so 4 minutes, like 4 minutes and 0 seconds. So it took some time to get created, right? It's already done. I'm just explaining you, right? Line by line, I'm explaining. It's already done. My Kubernetes cluster is up and running. It says successfully initialized, right? It's already created, but I'm just verifying, giving you some information, some background, what it has done. So I'm telling you. So it will check that all control plane components. That means these 4 components are my control plane component. You can see the titles: control plane, control plane, control plane, control plane. All the 4 control plane components are healthy. So it will just go and verify, right? It will also go and verify. It will restart and it will verify, right? It will boot up. So waiting for kubelet to boot up, this service will boot up all the control plane commands, right? As a pod, we will talk about all that thing. So it will just go and verify that all are healthy or not. So it is giving verifying that all the components are created and they are healthy, right? And this will do, I will 20 minutes in the background, right? So but here it is giving me the healthy status, all are created with healthy status, right? And then it will do token and all that thing. So master node will use this token for verification, right? All certificate it will verify through this token. All right, then RBAC and all that. And finally, you should get this message: Kubernetes control plane is initialized successfully. You should get this message, right? This means your Kubernetes installation has gone well. But the story is not yet over. You have to do some basic steps here. So it says that this message it gives only one time. So normally, as a good practice, what I do, we take this thing snapshot and save in our file, right? So I've created the snapshot here to start Kubernetes cluster. We basically what we do, we save these commands here, right? Because only one time, the moment I clear the screen, it will go off. So it is always good to capture the information and put it in a notepad file or check in into Git repository. The Kubernetes admin people, they have their own project in Git repository, check in there, right? So it says to start your cluster, you need to run the following command as a regular user. So you have to create make directory by the $home path under that .cube, right? Create one directory and then sudo, this is the copy command. What it will do, it will copy the input. It will take the input from where? From this file, admin conf, which I told you is the main file of Kubernetes, right? Kubernetes engine and Kubernetes configuration, or I would say the API server, right? This is the main file, which what I'm doing, I'm copying into this path. The directory you have to create first and copy this path into this path here. So we are copying. So copy command, and this is the main file. It need permission. So we use root user. Root user only can copy this file. This is the main file. It need permission. So we are copying this file into this. This is my source path. This is my destination, right? So copy command, source path, and the destination is this. So we are copying into this path under the name config. And then what I'm doing is that I'm giving the permission to this file. So I'm using who is the user. I will find out from this command id-u and id-. So in Linux we have two. Every user should be attached with the group. So this guy will just go and figure it out. Who is the user? id-u is the user. id-g means group. Who's the user and group of Linux who want access? So it will automatically find out that who is the user login. Basically it's a root user only. But if you have any other user, it will find out and it gives the permission to this directory. So you have to copy the file and it will make you the owner, ch owner. It will make you the owner of this file, right? You have to have this owner permission on this file, then only you can use it. So we have to do copy these 3 commands together in Linux and right click, it will be executed line by line. So that's the beauty of Linux, right? Bunch of command if I want to execute, copy all the command together and it will be executed line by line. So you see all 3 commands are executed first, second and third line by line. And then alternately says you can set environment variable, right? Export command we use in Linux to set the environment variable. What is the variable name? Kubeconfig. So it is always good practice to give the environment variable in capital letters, right? Always good practice to give capital letter, and I'm setting this path. So if you are not copying this file, you can set the path, right, as an environment variable, right? Alternatively. So if you do both also no problem, right? But if you are already using a root user, you can do through root variable. I'm doing both, right? And if you want to display whether it is set or not, let me go and use this variable name, right? Echo. If this path is set, it should display. So you see, why it is not displaying, because I missed one parameter, $sign. You see, this is already copied, right? So when I want to display this variable, $variable name, right, it will display the path. So this is copy. You can do this. Then it says you should now deploy the pod network. That means it is talking about the last step of my slide, right, of the installation. Let me go back to my installation slide. Right, we did initialization. Now it is talking about step number 5, pod network. That means I have laid down the network so that other machines I can talk, right? And Kubernetes doesn't trust anyone. If I have my own LAN network, also Kubernetes will not trust me, right? It's I cannot trust anybody in this world. Though you are owner or whatever, I cannot trust. So Kubernetes will bring its own networking here, right? How to bring this networking? Through this command. It says you should not deploy pod network, right? It's basically networking, but Kubernetes says pod network, right? So that pods can talk to each other wherever they are, whether on worker node 1, worker node 2, worker node 3, or any machine, they can talk. So we have to lay down this networking. So here, instead of network, what is the name? We say pod network. Pod network is Kubernetes network name. All right. How to do it? By kubectl. Apply kubectl is Kubernetes command line. Right. I'll talk more tomorrow. Don't today. Right. And then it says you can use this command, apply command -f, and bring this command. And you can choose any network from this. Kubernetes has many networks available. Right. Cisco, AWS, Juniper. Right. Many networks are there. Right. Flannel, VivNet. Right. Caligo. Caligo is the default. So we use. So I already have this command also. So if you just come little down, you see pod network, right? How to deploy this network? Here is the file. Same command I'm using. Whatever command this guy is saying, use this command kubectl apply -f and give your YAML file. What says give your .yaml pod network YAML file. So I have my pod YAML file command here already. So same command, and I'm going to bring my YAML file from here. Caligo network. I'll talk this Caligo network and all these things tomorrow. Not needed, right? Just a network through the file. Everything we are bringing through file. We are not configuring anything. Even the environment variables you saw, it is by default through the file. So this also, it will bring everything. So if you see it is created. Each and every line will create the network by default. So through one single file, we create the entire network, right? And if you see here, it creates flex network, which is basically networking. IPAM block, IP address block, right? IPAM is basically IP address block. It will create the block. And then affinity is basically to protect the IP addresses. We harden so that nobody can steal. And then IP address will be handled by the IP address handles, IPAM handle, IP address manager. IPAM means IP, right? Address manager, right? IPAM, IP address manager. So it will handle IP config. BGPs are networking protocols. It will bring the protocols. It will bring the IP pools. Pool of IP address will also automatically assigned by this networking, right? How, that we will see tomorrow, not today, right? So cluster information, network policies, it will bring, right? Network set, it will bring all related to network, right? Policies, network set, everything it will bring automatically from this file. And you see created everywhere. So that means my network has been created. Kubernetes has created the networking. And finally, we are on the final step, and we are good for the day. What is the final step? It says once you do this, right? Once you deploy the pod network, right? Then you may join, sorry. Then it says then you may join any number of worker nodes. How to join? By using this command, right? So this command, and we can join. So let me see how many nodes are there. So kubectl is the command line. I'll talk more about this tomorrow. Get nodes to see how many nodes are there. Only one node. All right. So I have copied that thing and paste it here. Only 2 minutes, guys. We are almost done. And let me copy on the other worker node 2 also. All right. Now if I go and check, or let me clear the screen. Let me go and check. What was the command? kubectl get nodes. I'll talk about these commands tomorrow. So they are coming. They're not yet ready, but they are on the way, right? So this is my control plane node, master node. And if you see the IP address, this is my IP address. This node is my master node, right? And the other node, 24218. 24218 is my worker node, which has no role. Worker node doesn't have any role, right? So no roles, right? And then this node 17.196. 17.196 is this guy. So this guy doesn't have, and they are not yet ready, but they are on the way. So if you after a while, if you check, they are in ready state. Ready. Here they were not ready, but now they are ready. So all three are ready, and my cluster is ready, right? 3-node cluster is done. All right, guys. So I'll share this file with you and all the commands. Normally, what I do, whatever we have done today, right? In Linux, there's one beautiful command, history command, right? I can take out, right? All the command which we did. So I take out and I can send you on the notepad file. So this is your folder. Every day you will be finding one command line file also from me, right? So this is the file, and I can just copy paste these commands here. Right, every day you will get these commands, and they are in sequential order. First command, second command, third command, fourth. They are in numbering also, so no confusion. All right. So I'll share you everything tomorrow. Again, I'll set up the cluster. Normally I do every day. I don't keep the cluster because unnecessary it will charge otherwise for master node, one node, right? So Kubernetes commands, this is what you will see, the file everyday commands and the date. So today's date, right? So I think Subbu, you should not be confused. In your country it must be 12, but you can get aligned with us. All right, so likewise, date-wise, I will send. So today is 13, 14, 15, likewise. So no confusion. Later point of time, it will be in sequential order, date-wise, right? So you will see this file, you will see this file, installation file, and everything, right? And tomorrow again, I will do the installation, right? Fresh file. Tomorrow it will not take much time, right? Today because of I was very slow and all that thing, but tomorrow it will be very, very fast, right? Within 10 minutes, right? We can set up, and after that, 5 minutes it will take to set up the cluster. So this is what we did, right? Our 3-node cluster is ready with 1 master node and 2 worker nodes, worker 1, worker 2. Make sense to you guys?
Yes, sir.
Okay. So before we wrap up for the day, any questions, anything? Because I've been talking for more than 1 hour and 40 minutes now.
I will try, sir, first to deploy these all things. Then
Sure.
tomorrow, maybe.
Yes. Okay, right. Just remember you have to open port 6443 on all the nodes. I think I've written on my notes, but just remember that, right? Or let me put it here. Default Kubernetes port, which is 6443 on all the machines. All right. So just remember this thing. Then follow the steps, right? I have verified this file. We set up the cluster from this file only, right? You can also try. All right. And if any issues tomorrow, anyhow, I will be doing the installation again. You can also touch base with me, or you can share your screen and then I can guide. And then we'll start our hands-on session from tomorrow onwards. Anyhow, we already started today to set up the cluster and all that. But to make your life a little more easy, right, we'll do the installation for a couple of days every day till you verify the file and you are comfortable with it. So let me set up the cluster, and this time it would be slightly faster, not the time it would take the way we did it yesterday. All right, because a lot of explanation and all that thing, so time went away, but today we'll do it straight away. Okay, let me first create 3 instances. Currently no instances are running, so let me set up the instances. So launch wizard, as I said, always use the top part. Give the instance name here. Let's say, let me create worker instances. Worker node operating system is Ubuntu. Select 20.04. Okay, instances free tier, 1 CPU, 1 GB RAM, which is T2 micro, which is fine enough, good enough. Okay, let it be default. Key pair, I have my own key pair SRE, SRE EC2. This is basically our public key and private key, okay? No credentials. Secret group, I don't want to create everyday new group. Let me use the existing one, which I already created. So this is my launch wizard 1 group. And then all default, which is fine. And number of instances, I need 2. Okay, and then launch it. So 2 instances created. So let me change the name here. This is going to be worker 1. This is going to be my worker node 2. And save. Yes.
So what happened to the one which we created yesterday? Was it
I terminated.
Oh, okay. No, I thought the life of the instance is only just 124 hours. Is it? It's not like
No,
that,
no,
right?
no, no. 1 year you can run
Oh, okay.
non-stop.
But you okay? You did terminated through me. Great. Okay.
Yes, yes. Because I told you, right? Master node is slightly expensive, right? Few cents.
Yes.
Yeah, yeah.
Very
So
good.
if I'm not using, then why should I unnecessarily hold them? All right. So this is the master node I'm taking up now. This time, operating system is Ubuntu 20.04. Why this guy's taking time? Instance here, master node, we need slightly higher. All right. So let me go T2 micro, small T2 medium, because we need minimum 2 CPUs. 1 CPU, 1 CPU, 2 CPU begins from here. Right. So let me pick this instance for master node. Minimum 2 CPUs are needed. 4 GB is the default RAM, which is fine. And then login, again same SRE key, SRE EC2, and security group. I will select my default one, which I created as my launch wizard. One is my default, not this one. And then rest all are same. Number of instances, I need only one. So let me go and launch it. Okay, so my 3 machines are ready. Master, worker 1 and worker 2 are ready. All right. This is getting initialized in the background, right? But that's fine. Let me go to our slide. So first step is done. Let me go and begin with the installation. Right before that, I need to connect, but that's fine. Let me open my file. So what I did, I created version 1 out of this file. All right. And here I will show you that I can execute the commands little more faster together. Okay. Master node worker 1, worker 2, start, and open 3 windows, one for master, one for worker 1, one for worker 2. So 3 windows, and then click this button multi-execution so that we can open it. Let me clear the screen, navigate to this my file, private key file, which is here, and give chmod 400 permission, that is read permission to this file. So I have given, right? So these commands I am using directly without copying from there, but what I'm doing, let me show you here. So master node is also ready now. Connect, and then SSH client, these 4 steps. So I did this one, I already did. I launched MobaXterm, which is my SSH client. Location, I did CD just now to SRE file, this file, which I just did CD, locate the file. So step 2 is to locate the file. I've already located my file where it is. I already found it. And then give this read permission, that also I've executed. So these 3 steps straight away is done. Now this is the thing which I want, and then I'll pick other one also. So this is what I copied. Copy the worker 1, only last one, because all the repeated steps are already taken care. And then the third one also, which is worker node 2, connect. Copy the last command and paste it here. And then simultaneously I can connect with all the 3 boxes, Linux boxes per se. Linux means Ubuntu. Okay. So I have connected. Now we need to connect to root user, right? For that, sudo command we have to use. Sudo space su and put minus sign, so it will not ask me any password. So you see, I switched the user from default Ubuntu to root user. All right, on all the machine, root user, root user, root user. Right. So we are good for installation. Right, and we are connected to the machine. This is right 172.31.94.85. This is 94.74, and this is 92.230. That means different IP address means we have connected to these machines. All right. Now let's go and start the installation. So first is always go and install Docker. So this is the command for my Docker. Let's go and do that. So Docker, Docker, and Docker. So I'm doing installation on all the 3 machines. I'm following this step, right? Docker, Docker, Docker. So step 2. And then to start the Docker service and then verify. So I'm clubbing these 2 commands together. And Linux, when you club the command together, but it will be executed separately, one after another, not together, right? So that's fine. So my Docker is installed here. Docker is installed here. Docker is installed here. So we can verify, right? So Docker is installed here on this machine. Docker is also successfully got installed on this machine. Docker is also got successfully installed on this machine as well. Alright, so all 3 Docker is installed. So step 2 is done. Alright, so this step is done. This step, Docker is done. Right, now kubeadm. Alright, so let's go to kubeadm. So notepad. This I already verified, right? I clubbed this command here, right? So it's already here. Now proceed with Kubernetes installation. Right, so Kubernetes, this is GPG key command, and then the file I have to create. In this file, I have to mention the path, the repository path from where I am going to download this Kubernetes package and which folder, right? From where my package is located, it is located under this path, etc apt sources list.d. Under that Kubernetes.list, and this is the branch. So I'll execute these 2 commands together again, right? Instead of separate, but it will be executed separately on the line. So if you see here, OK for GPG key, right? And then it has copied this command. So together I have executed here also OK GPG key and then cat command. So this together. So that way we can speed up few installations.
Sir, I have a question here.
Sure, please go ahead.
Sir, when you are running this command, the cat command, like if we want to use alternate method, so first we will create etc apt source.list d and then file, and inside of that file we will put that entry which is you mentioned
Yes.
deb https, like that it will work.
Yes.
Okay, thank you, sir.
Okay, so let's begin Kubernetes installation. All right, and then after installation we have to start services, Kubernetes services. So I'll do this command and clear command. Clear command will clear the screen. All right, so let's wait for a while. This is done. This is done. This is done. All right. Now I have to come out of this, guys. So only master node we have to do initialization. Only master node. So left hand side is always my master node. That is how I always have an habit, and do the initialization only on master node. So for that, initialization is kubeadm init command. Right. Now remember here I'm using kubeadm command, right? Not kubectl, right? Why? I'll discuss in a minute, right? I've created one slide already for you guys so that you should not be confused, but I'll show you little later. All right, so initialization will create everything, script, certificate, everything, right? In one go, it will create all the thing, but it will take some time, right? Around 4 minutes it will take. So currently we are on the flight check modes, right? So flight check. Then it is generating the certificates, search. Then kubeconfig is creating the file, and then it is starting the control plane command. That means it has created kube API server, controller manager, scheduler, and etc. And my thing is ready, right? And to start this thing, let's quickly do the steps, right? Execute this command fast, right? And then what it says, this is done. You should deploy the pod network. So I can go and bring the pod network from this guy. This is my pod network, right? This is the pod network. So go and bring this command straight. And then I can check kubectl get nodes. So my control plane is coming up, right? So we have to give some breathing time, right? Not yet ready means in the background, it is starting checking the health and all that things. So eventually it will be there, but I'm firing back to back. And this token is really important, right? So yesterday we normally we copy these lines, but these lines are always same, only the token will be different, right? Because it generates randomly. So it is not the yesterday's token, it will be different. Even the IP address of my EC2 instance is changed, so the token will also be different. So always copy, make, and habit. I already have a section here. So I'll remove the yesterday's token and copy today's token. All right, so and save this file. All right, and now if you go a little up, right, so we have some rest discovery. Yeah, here. So if you see here, right, once the API server and everything is created, what it does, the API server is sign DNS and all that thing, and then you see this Kubernetes is create. This is name of the service. What is this? Kubernetes default Kubernetes service. SVC means service. So it will create the service discovery by the name Kubernetes. Alright. So this Kubernetes service has been created, which is local for master node only. True, because it will check the health of the master node component. Which are the master node component? The control plane component, which are this. Let me go back to my slide. So this service discovery got created only for master node to check the health of etcd, API server, scheduler, and control manager, because this is my control node. This is going to control all the operations. Master node also going to control the worker node. So this guy has to be healthy by default. If this guy is not healthy, we cannot expect anything from Kubernetes, right? And that is the reason, right, we are doing this way. All right, so what we are doing, this service discovery is created. What is the name? Kubernetes. And what is the IP address? This is the IP address, right? This is the internal IP address, this is the local, this is the external IP. So for outside, we always create public IP on the top of private IP. Why? Because we never expose private IP directly. Private IP is the actual IP. We never expose directly, because otherwise people will use that IP address for hacking. So we always create public IP addresses, right? So now this is the thing. Just how to show you. So if I just fire one command here, let me first check the status. So this is in ready state. As I said, we need to give some breathing time to this guy, right? So it is ready, up and running, right? And then if I say kubectl get service. So in Kubernetes, kubectl is the main command, right? All day-to-day operation we will be doing through the Kubernetes command line, and Kubernetes command line is kubectl. All right. So this is a kubectl. It is the default command line. Who is going to use this command line? Right, API server, because API server is going to perform all the activities, all day-to-day operations. This guy will perform. These are the helping component who will help this guy. API server is the main guy, is the main pilot, right, of Kubernetes, as I said, right? And Kubernetes, the Greek word, it's the Greek word. If you go and look at the dictionary meaning of Kubernetes, you will see it's a pilot who will do some day-to-day operations. So who is our pilot here? API server, right? And these are just the helping components. All right, it will take help of these guys to do the operation, but this is the main guy. All right, now kubectl and get commands. So in Kubernetes, only this term will change, but this will remain same. Kubectl get nodes, get pods, get services, right? I want to see service, right? So you see, this is the service which I was talking, which is created here somewhere in the top, which I was mentioning here. Kubernetes default service, right? Kubernetes default service, which is, what is the name of service? Kubernetes. What is the IP address? This is the IP 10.96.0.1, right? And sorry. So if you see here, this is the service 10. Right, 96.0.1. This is the service. So this is the header. Right, when you fire the command, this is the output of the header. Name of the service is Kubernetes type, right? We will talk about the type. There are various types of Kubernetes services. Cluster IP is the default service of Kubernetes, so it will always have a type default here, but there are various other types also, which I'll talk today. Don't worry about it. This is the IP address which has been assigned, right? It is coming from here, 10.96.0.1. This is here. All right, this Kubernetes service, right? So everything is okay, and this service discovery is always created, right? So to do the health check. All right. Now I have not yet created my worker nodes, right? Worker nodes are not part of the cluster, because when I say kubectl get nodes, only one node I could see. So let me bring other nodes also, right? Let it bring. So now if I go to master node and check the status, kubectl get nodes, that I could see all the 3 nodes are up and running, right? These are my 2 worker nodes, and the last one is my master node, which we call control plane, right? Control plane is our master node. Why we say control plane? It's going to control. And what are the components? etcd, API server, scheduler, and controller manager are all components of the master node, and master node is also ready. All right. Now, one thing, if you notice here, kubectl nodes, and then so one thing, if you notice here, when this master node was ready, right, approximately age means time, right, when it was ready, since last 10 minutes, and during that same time this service was also created, right? Same time, if you see 10 minutes here, 10 minutes here, so that means master node creates this service. All right, master node creates this service. So here all the commands we will be using, let me use the slide. So what I'm saying here is, so what is the command we are using here? We are using this command. So command, what is the command I'm using? kubectl get. All right, and then you can substitute anything. You can say nodes, you can say services, you can say pods, right? Pod or pods, right? Doesn't matter. Singular, plural doesn't matter. So you can say service or services, that's fine, right? So that means I'm using this command. This is the universal command. Only the type will change. Whenever I want to see the nodes, I will say kubectl get me the nodes, kubectl get me the services, kubectl get me the pods, right? So we will be using all these commands with the kubectl get command. So commands are very, very simple. Don't get confused, right? And little further deployment, replica sets, and all that thing eventually will come, right? So all that thing. Now this command will only get me the status, whether it is running or not running, right? To see the details we use, right, another command, right? Again, all commands in Kubernetes will begin with kubectl. That is the, because this is the default command line, right? Now kubectl, whenever you want to see the detail of anything, let's say I want to see the detail of the service, because get command will just show you the name and that's it, right? So what it shows, name, type, right, IP address, and the age and all that thing, right? And this service is internal, no external, so it is always, right, none, because it is always internal only, no external, right? And this is the IP address, cluster IP address, the service IP address. This is the default service, so you will see the name here also, port number 443. All right, this is the service, but I want to see the details. So whenever you want to see the details, we use a describe command, right? And again same, what I want to describe, pod, what I want to describe, service, what I want to describe, node, right? Whatever I want to describe, right? So again it will be like the describe command. So right, so describe command and get command are the 2 command which are very often we will be using it, right? Almost frequently we'll be using this command back to back. Get command to see the status. If I want to see the details, I'll use describe command. Describe command will give me the slightly detailed, right? Slightly detailed things it will give me. So we have to use. So here I can use to see the detail of this service, Kubernetes service. What I can use, kubectl. Instead of get, what did I say? I said we can use describe command for the details, right? So I want to see the details. So describe, spelling is correct. Yeah, describe. What I want to describe, the type is service. Now here is one service which is fine, but if you have multiple services, eventually we'll be dealing with few other more services. So the name is important. Always use the name, because when I create the pod, I should have the name of the pod, right? So there would be many pod, hundreds of pod. Which pod? Which pod you want to see the detail? So always give the name, right? So this is the name of the service. What is the command? kubectl describe what I want to describe, service. If you want to describe pod, change it here pod and then give the name. All right. So, but this time I want to describe the service. This service, this is the name of the service, and when you describe, it will give you the details. All right. So let me just go through it right for you so that you can understand. Let me explain for you. All right. What is the name? The name is Kubernetes, which is fine. I could see this is the name of the service, right? This is the namespace. Namespace is default, which is fine. By default, we are using the default namespace. There are other namespaces also. I will talk little later. I have a full chapter on namespace, so don't worry. That time I'll talk only about namespace, and it's a very interesting concept, right? So when the time will arise and when we reach to that point, that time I'll explain in detail. So we are in the default namespace, which is fine. Label. So if you see here, it has already done the label on this service, Kubernetes service. What is the labeling it has done? It says this is whose component. This component is for API server, right? Where is the API server? A master node component, right? API server, right? What is the API server? The main pilot. This is the main guy, right? He can take help of the database. Okay, tell me this information, that information, this record for this node or this node or this node, all information he can fetch it from database. Or if you want to push some pod, he will say, hey, scheduler, give me the inventory, which node is free. So it will look at the metrics. Okay, this node is busy, this node is busy, this is available, it will update. Okay, let's take the worker node 3, right? So accordingly, this guy will go and push the pod to that node and they will be load balanced. So scheduler is helping him. Controller manager, when I want to do specific tasks, I will take the help of controller manager. But this is the main guy. These are all helping components. Again and again, I'm saying so that you should not forget. So this is created for whom? API server, because API server wants to be sure that all my sub components are healthy. This guy database should be healthy. This guy should be healthy. This guy should be healthy. So this guy will ensure how? Through this service, right? So the service discovery will do for master node thing, right? So, and who is the provider? Kubernetes itself. When you set up the cluster, this service will be created for the API server, right? Which we call service discovery. It will do the discovery of etcd, API server itself, and then scheduler and controller manager, 4 core components, right? So it will do. Why I am saying only for this, I'll tell you. Annotation, right? Not important. It is none. We'll talk little later. Annotation means some note, some description has been given to this guy. No, not needed. It is none. It is understood. Selector, I'll talk little later. Label and selector we use very frequently in Kubernetes, right? But I will talk little later, right? So don't worry. We will talk each and everything, whatever you are seeing it here, and again we will see when we have more details in hand. Currently it is not needed. It is anyhow it is set to none, so it is not needed to know. But I will very soon, probably tomorrow, I'll tell you about all these things. Type, as I said, there are various types of Kubernetes services. This is cluster IP. So let me create one slide for you guys so that you can understand. All right. So if you see here, so basically in Kubernetes, we have few things which you should remember. Something which we call kinds of Kubernetes resources. Kinds of Kubernetes ATS resources. Right? Resources sometimes also called objects of Kubernetes, right? Both are same, resources or other. What are Kubernetes resources? So pod is Kubernetes resource, right? Pod will help me to create container. It will talk to Docker, get the container created and start managing it, right? Automatically. And then what we have? Something called replica set, right? We cannot deal with just one pod. We will create replica sets, right? So replica sets. So we will create replicas so the traffic can be shared across multiple instances and it will be, so my request will be served very fast. If I have just single replica, right, then my request will go and stand in a queue and that guy will take time to process my request, might be after 5 minutes, right? Because before that, it has so many requests to serve. My request will go and stand in a queue, right? So Kubernetes will never do like that because it will introduce latency. So it will create replicas and my request will be assigned to the another replica and it will get processed immediately, right? So we'll create replica sets. What is other Kubernetes resource? Deployment, right? I'll talk about deployment. Deployment is basically application stack that will bring the whole application using the whole deployment things and all that thing. We'll talk little deeper. Don't worry about it. And then services, right? So this topic we have been talking since morning. Service, right? Services and service, which is fine, right? So essentially, you should know deeper knowledge about these things, right? These are the core Kubernetes objects or resources. You should have a detailed knowledge about these things, and that I'm going to deep dive with all these things for you. Don't worry about it, right? But essentially, I'm putting on the list so that we can understand these are the core components. There are many others, right? There is a storage, PV, there's a daemon sets, many things are there, but they are not everyday thing. But this we will be dealing with every day, right? So many other things which will onboard but not needed now. But we should know in detail about these four guys. Simultaneously, when I say service, let me divide this slide. All right. So when I say service, so there are various types of services also. So let me tell you what are the type of services. All right, and then let me change the color also. Left and right, we can make some differentiation. Types of services, right? So what are the types of services? There is a separate session on the service, and each and every service there is a separate session, right? So if you have three services, then one service will take in one session, and we'll understand all the nuances, semantics, what is the purpose of service, why I want to use this service, and in which use case I have to pick this service or that service, right? Everything I'll tell you, right? Don't worry about it. So let's understand what are the types of services. One type is called cluster IP, right? Why the name is like that? It is a cluster. This is the service which is running across the cluster, and this also always has an IP address, right? Which we just saw, right? So basically, this is a default service of Kubernetes, all right, default, and it is always internal only. It doesn't know outside thing, only internal thing. What are activities are happening inside the cluster? This guy is aware, but what are the things which are happening outside the cluster? This guy doesn't know anything. All right, so this is the default service which is always internal. There are another service which we call node port service, node port, right? So why the names are like that, which I will tell you little later, right? This is basically, it manages all external traffic, right? Whenever the traffic is coming, right, inside the cluster, this guy will help me to manage even the external, right, external things, right? And then to do the load balancing, we have one more powerful service which we call load balancer, right? This is also external. It will do traffic management outside the cluster. It will not bring the traffic inside the cluster and then do the load balancing. It would be slightly difficult, right? If the flooded of traffic is coming already inside the cluster, then what is the point to do the load balancing, right? Already chaos has been created, right? So it will do the load balancing outside, and then it will manage the communication between external internal, but mostly it will do a key role at the external, not bring the traffic and then do the thing. It will not create the chaos, right? It will avoid the chaos, right? Rather, it will avoid the chaos, right? So these three services also we need to have a detailed study, deep dive, right? So we'll deep dive with these guys and we'll deep dive with these guys. So I will create this slide, right? Normally what we call this we call Kubernetes resources or Kubernetes objects, all right? So I have already created folder for you guys, Shibu and Shivani, and this is my Kubernetes objects or resources, right? So don't get confused, right? So we'll be dealing with these guys every day, objects, all right? Now, before I move ahead with other things, right? So, okay, sorry, we are still here only. IP policy, it's a single stack. Single stack means it assigns single IP address only, right? Not multiple IP addresses, single IP. So we say single stack, right? And by default, what is the IP address format we are using? We are using IPv4. This is the IPv4, right? So IPv4, 1, 2, 3, and 4, we say IP address version 4 format. Now, what is the market recent version? Version 6, IPv6, all right? So IPv6 is something like MAC address, which is not convenient for us to read, but for machine security side, it is very hard, right? MAC address, right? So, but that IPv6 is for human readable format, it is not comfortable. So we will always stick to IPv4, but inside it supports IPv6 also. So by default, it says, okay, which format I'm displaying? I'm displaying with IPv4. All right, if you know the IP address and all that thing, slightly networking thing, I think Shivani knows about it. All right, and the port number, right? So this service has two things, right? In the services, right? Remember, service has two things. One is the IP address and one the port number. service cannot open all the port number, then it would be no security. Anybody can attack my cluster by, because all the ports are open. So services will ensure that, okay, only particular port number should be open, not all the port number. So that way it is security, it will tighten the security, right? It will harden my cluster by avoiding the unnecessary leakages, right? So it will not leakage through opening all the ports, only particular port. So it is running on 443 port number, and you can see it here, ports, which is the port 443. And by default, TCP is the default protocol of Kubernetes, right? Wherever you open the port, TCP is the default protocol, right? So it is here, right? And target port, the cluster wide port, right? Kubernetes port is with 6443, right? So this is the service port number. Target port, right? Target port means Kubernetes as a whole. The Kubernetes uses 646443 port number, right? So master node wants to talk to worker 1 or worker 2 or worker 3 or worker 4 or any node, right? This port number should be open because it's a Kubernetes cluster port. So cluster wide communication will happen through this port. But at a service level, service has its own port, right? So it is understood also, when you have multiple application, we cannot assign single port number to all the application, right? Front end will be have different port number, back end will have different port number, and that is how we tighten the security. All right. Now, if you see the endpoint, you see this is only do the all service discovery and everything only for which IP address? This IP. If whose IP address is this? This is my master node only, right? No worker node. 9474 is my worker 1 and 9230 is my worker node 2. Is the IP address mentioned here? No, only master node. So this guy is going to do service discovery for master node only, right? Only master node, no worker nodes, right? Not the remaining 5000 nodes, right? It will not do, only for master node, because master node is a single guy, active guy, leader, who is going to lead the cluster day-to-day basis. So these components, these components should be healthy. etcd, API server, schedule and control manager should be healthy. So that is how this service is telling me that, okay, I am going to, this is my endpoint. Endpoint means something, means URL or IP address, right? So this says, okay, I'm going to manage this guy only on which port number? Kubernetes default port number. So master node components will be managed. And who is the owner of this service? API server, our super boss. All right. So this guy is going to do it, right? And this is the IP address. So Kubernetes, remember, Kubernetes assigns IP address to two resources. One is at the pod level, one is at the service level. That's it, right? Only two resources in Kubernetes. Why resources? Because I'm saying these resources, right? Resources. So don't get confused. So Kubernetes assigns IP address only at a resource level. Which are the two resources? Pod and service. These guys will get IP address all the time because we want to access, right? How we will be accessing? Through the IP address and port number, right? So these two guys will have the IP address in Kubernetes across, right? I'm not saying about development cluster or a testing cluster or a production, right? Wherever, whichever environment, right? These properties, these two guys will have the IP addresses. All right. Are you guys with me, or is I'm too fast?
Yes, sir.
Okay.
We are following.
Okay. Good. Right. So I'm. That is the reason I don't want to hurry up. Right. All right. Now everything is fine. Where is my pod? Right. Without containers, what Kubernetes is going to do? Nothing. Right. So we see kubectl, right? Get pods. Right. So no pods are running. Right. As I said, I'm using get commands. Nodes. Right. I can see nodes. Right. Or if you use node, Kubernetes is very smart application. So if you use nodes or node, it will not throw any error. It's a smart application, right? So it will not throw any error. Same way, when you say pods, right? Or when you say just pod, doesn't matter, right? It's a smart application. Same way, when you say service, right? This is the service is already running, or services, right? No error, right? So it's a smart application. But where is the pod? We haven't created any pod, right? Now, before that, let me go to worker on a few things which I want to tell you, and then we'll come back. So if you see here, to join this node, what command I have used? kubeadm command I have used, not kubectl. kubeadm join command, and whom it is joining? To the master node. This IP address, whose IP address is this? Master node. So this guy will go and surrender that, hey, master node, can I be member of your family? Can I join your family? And this guy will join, right? Who? Master node. How? Through the token, right? Through the security only, through the token, right? And this is the full token key, the certificate and all that. It will do verification. So CA certificate hash key also we have provided, and this is the Kubernetes token which will verify, master node token which will verify, right? If I have not clear, I've cleared the screen, right? So this guy has joined the master node, right, using the token. So it will also do pre-flight check and all that thing, right? And then you see this node has joined the cluster. So this worker node, only worker 1 I'm talking here, not the worker 2. Worker 2 I have not yet gone, only I'm at worker node 1. So this node has joined the club, but how? Right? By satisfying two conditions. The star means these are the conditions which is this guy is satisfied. Based on these two conditions, this guy was allowed to join the cluster. Right? What are the two conditions? So it says certificate signed request was sent. That means this guy, this worker node 1 has sent the signed certificate request to whom? To API server. Who is the API server? Right? Who is the API server? If I look at my slide, who is the API server? This is the API master node. Right? In short, I can say master node. So it is sending the signed request, is sending its certificate to verify that can I join. So Kubernetes will always ask the certificate. So this guy is sending the certificate to API server. All right. And then this guy was this guy was response was received. This guy received a response back. Right? It sent the request and this guy received a response back from the API server. That means the handshake between the worker node and the master node has been done, right, based on this token. And that is the reason Kubernetes is a very secured tool. So handshake is done. So it sent the certificate. API server will verify the certificate whether it is having a valid certificate or not. If it's a valid, it will say welcome and join my family. It's not a valid certificate. It say who are you? Go to hell. All right. But in this case, the certificate was valid and he got a response back from the master node. And that's the reason when I told you that when we say kubectl get a nodes, right, kubectl get nodes, it takes some time, right? Because in the background, right, it was not ready earlier, and after a while it was ready. Why? Because in the background it takes some time to verify the certificate, right? And if the certificate is valid, then only it will allow to join the cluster. If the certificate is not valid, it will say reject. All right, so that is what has been happened here, right? Let me go to worker 1 again. Right, so that is what it has happened here. This node has joined the cluster, right, by sending the certificate request, and the response was received because the certificate was valid. And then the kubelet, who is on the worker node, right? Who is on the worker node? If you look at my slide, right? Who's on the worker node? Always kubelet, the agent of master node. So kubelet, right? So kubelet of this node, kubelet. So kubelet is basically the agent and it is the main guy of worker node. So kubelet is the most core component or the essential component or the super boss component of worker node only. Kubelet is not available on master node, right? That we already aware. All right. So kubelet, whenever I say kubelet means I'm talking about worker node. So let's go back. So the kubelet was informed, right? Which kubelet of this node, this IP address, this worker node, right? This worker node, the kubelet of that worker node was informed of new secure connection details. That means first the handshake is done, certificate is verified, and then it say, okay, welcome join my family. And additionally, it has given one more information that, hey, kubelet, right? You should use secure communication channel, right? That means secure connection details it has sent to this guy, right? Secretly, right? That is encryption, decryption they use in the background, right? So it was informed to talk through a secure connection detail. That means what I mean to say, if the Prime Minister of USA, right, Joe Biden, wants to talk to Prime Minister of India, all right, Mr. Narendra Modi, right? If these two guys wants to talk, how they will talk? Can they talk in open network? Right? Open network means the mobile network which you and me we are using. That can this guy they can talk in the open network? No. Their communication is very secured, right? It should not talk in a open communication. If anybody heard their communication, then it would be disaster because they share all the confidential information between these two countries, right? So they always talk. Their always talk is a confidential. Now, how will you ensure? By ensuring talking through the hotlines, right? They talk through the hotline, right? They have the number, they dial, and through the hotline they will talk, not through the open network, correct? Not through the open network. Same way, Kubernetes says, okay, I will talk to you. You are my worker node. You are my family member now, but I will talk to through a new secure channel, through secure communication, and the details are already shared. All right. So same thing when I go to worker node 2. Let's go to worker node 2, which is 172.31.92.30. And you see this node has also joined the cluster. I fired the command kubeadm. All right. So this guy, I'll talk about kubeadm. Don't worry about kubeadm, kubectl, how many command lines we are using. So we will talk about it, right? So this node has also joined the cluster. Which node? This node 9230 has joined the cluster, and by satisfying two conditions. So this guy also sent the certificate sign request was sent to API server. So this guy also sent a certificate request that okay, I want to join, but please verify my credentials by verifying my certificate. So this guy was also got a response. That means the certificate was verified. That means that it was holding a correct certificate, valid certificate, and it was also got a response. And then the kubelet, because it's a worker node. So who is the owner? Kubelet. So the kubelet was informed that okay, we will talk through the new secure channel. That means the hotline is laid between you and me, and we'll talk through the hotline, not the open network. Because as I said, Kubernetes is a very, very secure tool, right? So security is measured at each and every point. So when the handshake is done, we will ensure that it is tight security. Within the tight security, with the periphery of the tight security, they are holding the hands, right? And we see that okay, they are done. And now if I come here and see, they have already joined. So 230 is this guy, 9230, and 9174, 9474 is this guy, and they are in ready state, right? Earlier it was not ready, right? Because in the background they do verification validation. Understood? All right. So this is what we did. Now let's talk few more details here. Yeah.
I kind of lost. So what was the command that executed to join this worker node? Sorry.
Yeah.
Yeah, correct.
Yeah. I'm coming to it, right? So let's talk about my slide which I prepared for you. So this is the message when you initialize the cluster. This is the message we get, isn't it? Kubernetes control was initialized successfully and create this directory, then join and this, and then finally it gives you the token. But this
Yes.
token doesn't has a kubectl command. It has a kubeadm command.
Okay.
All right. Now, when to use kubeadm command and when to use kubectl command, right? When to use kubectl command and when to use kubeadm command. Let's talk about it, right? So what I've done, I've created one slide for you guys. Let me. Okay. Now here there are various types of Kubernetes command line, right? And to avoid the confusion, otherwise you will always be confused. And that's the reason to avoid the confusion, I've created this special slide for you guys. Now, here you see there are three types of command line in Kubernetes, right? And they are in different color. One is brown color, one is in red color, and one is in blue color, right? So one on the topmost, if you see, I have written kubeadm. So it is the command line used only for administrative activities. Whenever you perform administrative activities, use this kubeadm. And these scenarios are very fewer, very rare, right? Not frequently we'll be using it. All right. So this is the kubeadm command line, right, which we use only for administrative activities, right? Only for administrative, and there are very few administrative activities. For example, when you initialize, right? When you initialize, what command did I use for initialization? Let me show you again here. If you see, if you have noticed, I use kubeadm command for initialization. This is my initialization command, which I use kubeadm init command, and this is the version which I mentioned. But if you don't mention, even this command will work. So what command I use? Kubeadm. So kubeadm command we use only for administrative activities such as initialization of the cluster or joining the nodes, right? Joining the nodes means worker nodes, right? So that when I join the worker nodes, what command I use? Kubeadm command again here, and joining the nodes. So kubeadm command is used for administrative activities. When you set up the cluster during that time, which command line we use? We use kubeadm command line. All right. So initialization, joining the node, or if the token is corrupted, right? Because we join the node through the token. These are all my token. If this token is corrupted, because anything can go wrong, right? This may also get corrupted at any point of time. So if that is the failure, I can regenerate the token and all that thing, which I'll teach you later, not today. So only for administrative activities, we use kubeadm, right? Or I would say the cluster admin people, they use this utility to set up the cluster and join the node and all that thing. We use kubeadm utility, right? For day-to-day activities, we use kubectl. So if I want to give access to the developers, right? If I want to give access to developers for my Kubernetes cluster, or the testers who wants to do the testing of the functionality of the applications, right? I will give access of kubectl, not the kubeadm, right? I can even control that access also, which command line should be given, right? Kubectl is basically normally for day-to-day operations, right? Kubeadm only for administrative activities. When you set up the cluster, only during that time we use kubeadm. So kubectl is called as a default command line because every day we'll be dealing with these guys. So this has to be default. It should be available for all, right? And should be always available. So we say default command line of Kubernetes is kubectl, because I'll check my pod, kubectl get pod, kubectl describe pod, kubectl get service, kubectl describe service. Which command line we will use kubectl as our default command line, right? Where it is available only on master node. It is not available on worker node. Let me go and test it. So if I go to my cluster back, so here I can say kubectl get is already there, service, right, or nodes, right? I can use. So kubectl is a master node. Let me go to worker node and see. So if I go to this worker node 172.31, right, and if I say here kubectl get nodes, right, it will say it will refuse, right? It will refuse. So kubectl is available where? Only on master node, right? Not running here. Let me go here again, worker node 2, kubectl get pods or anything, it will say same error, refused, right? So it is not available, it is available only on master node. All right, so let's come here. So kubectl is available only on master node to perform what? Day-to-day operations, and we will always state master node only, right? Remember, in my PPT also I told you, right, our front end UI is only master node, right? If I showed you this slide, we enter only at master node. We cannot enter with the backdoor entry. Remember, I gave you this small story that if we are sitting in the, this is my front gate of my company or corporate office, and we are sitting in different tower, we cannot do a backdoor entry. We have to come with a front gate only. Let the security verify my credential, and if I'm authenticated and authorized employee, then right, even the CTO, right, a big shot, they also have to come from the main gate only, no backdoor entry. So we cannot enter from any other way. We have to enter from master node only, and we will stay here only. And from here through the API server, we can see it here, because I cannot access this guy, I cannot access this guy, I cannot access this guy, only API server. So from the API server, I can see this node. Where is the API server? Master node. So we have to be always on master node. And who will help me on master node? This guy will help me, kubectl command line. Right? It is not running here, and no point going there. Only for verification, we will go to worker node. Otherwise, master node itself will manage all the operations, and it will also manage all my worker node also. Right? We will never ever go there. All right. So this is how we are here. All right. So we are here. So here, and what is kubectl? Kubectl also called as API server command line. Right? Master node. Whose master node? The main master node is who? Right? This guy is our master node. Right? API server is our main guy, main pilot. All right, this is main. So the kubectl command line is also we call API server command line, because we are doing the operations, right? So who does the operation? API server. So API server command line. It is often referred as, if you go to some webinars, right, or some live events, right? Nowadays, many virtual events, live events, all those are happening. Many webinars are happening every day, right? If you go to any events, right, and attend webinars, the speaker, right, who is the keynote speaker of that event, right, they might refer this kubectl as kube control. The full form of CTL means control, right? So people has given the full name of kubectl. CTL means control. Kube control is command line, right? So we say command line. So if some people say kube control, don't get confused. They are referring to kubectl only. There is no kube control. It is kubectl. But for ease of convenience, they say kube control. All right. For ease of convenience, they say kube control. Some Dutch people, they say kube cuttle. Right? If you go to Germany and there, the keynote speaker from Germany, he will say kube cuttle. Right? CTL means cuttle. Right? So people pronunciate. Kubectl is not appropriate, so they take a conveniency of the words and they say kube cuttle. So kube control, kube cuttle, or some people say kubectl. They give a lot of stress on the CTL. So don't get confused. All right, so kubectl, kubectl, they are all leads to kubectl only, right? And in Linux, all commands in lowercase, so it should be in lowercase, right? So kubectl is the thing. All commands will begin with kubectl. In Kubernetes, by default, kubectl should be your main command, and the sub command could be anything. Get command, describe command, all these are sub commands. Main command will always be kubectl. That means all command will begin with kubectl, right? Now let's talk about kubelet. Kubelet is one more, right? So kubeadm, kubectl, and kubelet. So people should not get confused. That is the reason I've created this slide. Kubelet is what? Kubelet is basically an agent service which is running on the worker node, where it is available only on the worker node, right? So differentiation is very straightforward. kubectl is available on master node. Kubelet is running on worker node. It is available on worker node, so no confusion. Each worker node will have its own kubelet because it's a local component, so it should be available on each and every worker node. So it is a each worker node should have this kubelet service running. It is basically agent service, right, of master node. What it does, it takes the instruction or the specification or any task, right, to create a pod or anything, right? So it will take the specific node task from whom? Master node. So master node will assign the task to kubelet, and kubelet has to perform this task, right? It has to perform this task on the worker node and go back and update the status back to the master node, because it is the communication channel. How? The worker one will talk to master node, right, through this agent service kubelet. All right. So this guy will talk to kubelet will talk to this guy, and any work this guy want to assign, it will assign to this guy. It will create the pod. It will assign. It will create the pod and go back and update the status. Hey, I created pod 1. I created pod 2. So same way, this guy also kubelet has to, right, take the specification or task and complete the task and go back and update the status, right? So that is what the kubelet is all about, right? So it does. It also runs across the worker node to check the health of the worker node, right? If nothing is there, no task is given, it should maintain the health and tell the health status that, okay, I'm healthy. You can give me work anytime. I'm healthy, right? If it is sick, it has to go and say, hey, today I'm not well, man. I cannot work. So this guy, okay, take off, right? You are not well. You're not, take sick leave, right? And rest. Today no work for you, right? Because you are sick. So it has to go back and update the status. So that means health status also it has to update. If anything goes wrong, it will update that, okay, I'm not well. API server will look at it and see, okay, what went wrong, and it will initiate the corrective process and it will correct it. How? That I will tell you little later, right? Those are the things which we will learn over a period of time, right? So this is how the communication will happen, right? So we have 3 command line. Any confusion between kubeadm, kubectl, and kubelet? Are you guys with me?
Yes, sir. There is no confusion, sir.
Okay. So remember this slide, guys. Otherwise, you will be lost. All right. Udemy and all these guys, they will not tell you all these things. All right. So take advantage of this. I will send you this slide also and include my email. So don't worry about it. All right. Thank you.
Thank you, sir.
All right. All right. Now, before we wrap up the day, I'll take 5 more minutes, and I'm really apologize that I need to take 5 extra more minutes from you guys, right? Because I want to create one pod at least to show you the communication. All right. So let's go inside the cluster. Where is my command line? All right. So we are at the master node. This is our master node. Remember. This is my worker one. I maintain the sequence right from the beginning, so I have an habit. And I can clear the screen here, clear the screen here. Right, and clear the screen here, back to master, right? Somehow it is not getting saved, they go off, right? So it is lost, right? So this is the drawback here, all right? So that's fine, right? Left hand side is always my master node, right? Now, how would I know it's master node? If my kubectl command is working here, then this is my master node, right? So kubectl get pod, no pod is running, right? Let me go and create one pod, right? So as I said, all command will begin with kubectl command, kubectl pod, right? Sorry, kubectl run. What I want to run? I want to run the pod here, right? So kubectl run and give some name. Let's say test 123 is the name of my pod, and which image, container image, right? So you have to give container image. let's say engine X, right? And if you just give engine X, it will take by default, it will take the tag latest. It will pull the image of latest version of engine X. Whatever image is available in Docker Hub repository, it will just go and take from there, right? So you have to come here. Docker Hub repository is where all container images are there. It's a like GitHub, we have Docker Hub, right? Public repository where all the images are available, right? So I would suggest register yourself on this repository. We'll be using very frequently on daily basis. Let me put it on the chat. Chat. Right? Register yourself. This doesn't need credit card, only valid email ID. It will send activation link. That's it. No credit card, nothing. Right? So just register here, right? And then sign in. So let me sign in. It has already taken my credential from the cache, password also from the cache. Let me log in. So all container images are available here, right? So if you say any application, Nginx. By the way, have you worked on Nginx, guys? Anybody?
No, sir, I haven't worked.
Okay, I'll give you the information about Nginx maybe tomorrow, because Nginx we will be using. Nginx is something like a proxy server, or it's a web hosting server where you can host your websites, right? And it's one of the open source, very powerful open source. No money need to be paid, and you can host websites very easy, very fast, and it is something like a production environment itself. It will take care of all the resources automatically. Right? Very, very powerful. I'll talk more about tomorrow. So all the
It's
content images are there. Yeah.
Apache.
Yes, just like Apache web hosting. Yes. So if you talk about SQL Server, if you talk about Oracle, right, all the content images are available. Millions and millions of images are available here. All right. If you look for any application, all images are here from this. This is the repository where all content images are there, and whole world is using, whole world is contributing. Right. We'll talk more about tomorrow because there is no time today. That's fine. So this Nginx. So in Docker, whenever you want to explicitly mention the version, always use colon and then put the version. Let's say I don't want to use latest. I am explicitly want to use this version, 1.19 version. Right. So this will pod is created. Right. So kubectl run command is the pod. What is the name of the pod I give? Test123. So if you see pod test123 is created, right? Where it is created, masternode cannot create pod. If you look at my slide, masternode cannot create pod. Where it is created on the worker node. But which worker node? We have two worker node. Which worker node? Right? We have two worker node. kubectl get nodes. Which node? Right? This or this? Right? So let's go and find it out. So when you say kubectl get in pod, kubectl get pod, right? This pod is created, right? This is the header. Name of the pod is test123, right? Name ready, right? And start. Ready means this container 1:1. Which Nginx container is running? What is the state? It is running. Kubernetes is very particular about restart, right? If the application is not stable and it is on off, that means it is restarting, but it is not available. It is restarted automatically. But again, after a while, you see the restart is done. It is running, but after a while, it is again restart, right? So that means it is not stable. So Kubernetes is very particular about number of restarts. So if I see after a while, right? Sorry. So if you see the special character, if you see after a while, it is still running and no restart has happened. That means this pod is stable, right? This is stable, right? It should not restart. Restarting that it is right thing. Or if I want to restart myself, I can track that, okay, restart has happened or not. So it will update the counter by 1. That means the restart has happened. Tomorrow again I will restart. It will update the count with 2. That means 2 times I will restart it. So Kubernetes is very particular about restart, and we will see the importance of this guy also. So this is the header, right? It comes with a name, ready, status, restart age. But where it is created, right? So what we can do, we use describe command. That is one we have to use, right? So kubectl describe. What I want to describe pod. Which pod? My pod. This pod only. Like currently we have one, but imagine if you have 10 pods or 100 pod. Which one? Always give the name. So I'm interested in my pod test123, and let's go in. So if you see here, this is the command I fired. Describe pod test123. So let's focus here, right? So I'll just take 2 minutes only here, all right? Not more than that. So name, what is the name? Test123. Which namespace? As I said, default. Priority, not important, but Kubernetes always starts with, in the background, with array, something like 0, 1, 2, 3, 4, 5, some sequential number in the background. So this pod is created first time, so it starts with 0, then 1, 2, 3, like that maintains. But it's all internal. Don't worry about it. We won't use it, right? Where it is created on this node. This is the node host name. If you see 9230, it has gone to this worker node 2. It is created. What is the IP address? This is the IP address of this node, right? 172.31.92.30 is here. So this is created on node, means this node. It is created here. Can I go and check it on this node? Yes, why not? So let's go and check. We don't have a browser, right? So take the IP address of the pod. What is the IP address of the pod? This is the IP address of the pod, right? And it is in running condition, right? Take this thing and go here, right? Because this is the 9230 is here. So in Linux, we don't have a browser. So what should we use? We should use curl. I told you, right? Curl. So give this thing and you see this Nginx is running here, right? This is the HTML page, all right? Don't worry. So welcome to Nginx, and right, this is the header and all that style sheet and all that, which is fine. Welcome to Nginx. If you see this page, that means your Nginx web server is successfully installed and working properly, right? So this is the command we use. It is running only on this worker node only, right? Not here. If I go here and verify, I will not find this container running here, or this pod is running here, right? Container pod are same. Don't get confused. I already copied, I think. Yes. So if I come here, it will not give me any response because this pod is never deployed here. It is running here, right? Who has assigned? Because we are checking on master node, right? So this is running here. When it is running? Today's Friday, 14th April, and this is the GT, right? This is basically GMT, right? So UTC time, right? 5.5 hours behind, right? So this is the time it is running. What is the name I gave? This pod is running with the name test123, right? Label it has created automatically. I'll talk about label tomorrow, right? Don't worry about. Annotation. Who assigned this IP address? Remember the Calico network which we use, Kubernetes networking. It has assigned this IP address and it is 2 raised to the power 32. That means around 65,000 IP addresses it has maintained, and it is assigning the IP address from this range. So it will begin with from this range and 2 raised to power 32, right? If you know subnet and all this concept, that I don't want to deviate, but that is how 2 raised to 32, and it starts from this. So you see, this is the first IP address which has been assigned, right? 141.193, right? Once, right? So which is here, 141.193. All right. So it has assigned the IP address. So Kubernetes assigned IP address to two resources. One is pod, one is service, right? Remember that. So pod got IP address, and that is the reason I can access this pod through this IP address, and that is what I did it, right? I did it here, right? So I access this pod and I was able to see the response. All right. So that is what we do. Now, here you see pod is nothing but container, right? So container, what is the name of container? Test123. Who created this container? Kubernetes cannot create this container. Sorry. Kubernetes cannot create container. Who created it? Docker created it. So it is Docker who created this container, and this is the container ID. Right? This is the container ID. If you know the container, all that thing, 12-digit ID. If I come here and fire the command, let me go to worker node, this worker node, let me go here. And here, if I say Docker PS, right? You see this one of the containers is running here, Nginx container, right? Don't worry about other thing. Kubernetes runs so many things in the background, don't worry. This container is running from last 6 minutes, right? This is the header. Container ID, image, command, created, status, port, and name, right? So this is the container which is running. The name which we give, test123 is here, and Nginx image, right, which is running here. And then this is the container ID which begins with A9B17 something something with 573, right? 573 is the ID, right? If you see here, this is coming from here, A9 something 573, right? That first 12-digit ID is for us, and internally it maintains the UID with 256 character, which is fine. But this is our container which got created there automatically, right? Image, which image? I gave Nginx, but explicitly I mentioned this version, right? Explicitly I mentioned this version. If you remember here, somewhere I gave this version, right? Where run. Yeah, here, right? Nginx 1.19. This was my command, right? Don't worry, I'll send you the commands also, right? So this is the image. Who pulled this container? Again, Docker. So you see, container creation is done by whom? Docker. Okay, so we can see the information here. right? There is no direct command for Docker. Remember, in Kubernetes, it is always through the pod only, right? So only pod command you will find, no Docker command. Docker command means container command, right? So there is no command directly. It will automatically talk to these guys. Port number we haven't mentioned, so it is empty. Host number, host port also we didn't mention, so it is empty, which is fine. It is still running, and from today's date and time, right? And this is the condition, right? True means this everything assignment and everything is proper, which I will talk in a minute. Number of restart count is 0. That means this contains the stable container. All right. And then environment variable, we haven't set any environment variable, so it is empty. Many application needs environment variable and all that, right? Which I'll talk down the line, not today, right? So we'll talk about mount storage and all that is also here, which is fine. Now this condition is for etcd database. When this pod is created, a record has been created in the etcd database, and it will update the status by the under the the table which has two columns. One is type and status. So it says, is this pod initialized properly? Yes. That means true means yes. If any problem, then say false, and you have to look at the log file. Log file will not be in the etcd database. It will be in the some system drive of etcd folder, but not in the database, right? Database never put all the log file. Otherwise it will be too heavy, right? So it will just update initialized properly. Yes, status is true. Right? Is the container created and is ready? Yes, it is ready. Is the container also ready inside the pod? Yes. Is the pod scheduled properly? That means schedule means between the worker node scheduling has happened properly. It says yes. So everything true means everything went well. It updates the status in the etcd database also. Volume I will not talk today. Volume is the storage. I will not talk today. It is not needed. We'll talk sometime little later. I'm interested in the events, right? And that is the whole crux of today's session, right? Just focus it here, just 2 minutes and we are done. All right. So if you see the events, this is the header, type, region, age, from, and message, right? So just read here. So first thing is scheduling. This pod has to be scheduled. Master node cannot create it here. It has to be scheduled either on this worker node or either on this worker node. So the scheduler, who's the default scheduler? Default schedule, we already have it, right? This is my default scheduler. All right, the scheduler has, right, default scheduler means master node scheduler we call default scheduler. This scheduler that successfully assigned the pod. What is the name of the pod? Test 123, right? This is the pod I wanted to create. So it says successfully assigned this pod to whom? To this guy. Who is this guy? This is my worker node. That means the worker node, this pod has to be created on this node. This is the host name. All right, it is the host name. If you want to verify, let me go here and we will verify quickly. So let me clear the screen and say host name. What is the host name? IP, right? 172.3190.230, and exactly you would see it here, right? IP 172.3190.230. So the default scheduler has successfully assigned this pod to this node. Who assigned? The scheduler will assign. Basically, both are free. This and this both are free. So I have only one pod. So I cannot divide half. You take half and you take half. So it randomly pick out of these two. It has randomly picked the other worker node 2. Now who is the guy sitting here? Worker node is kubelet. So kubelet of which node? Only this node we are talking. This node kubelet, because kubelet is local, right? So the worker node 2 means this kubelet, not this kubelet, worker node 2. This kubelet, right, has to start working because nginx, right, image it has to pull. So it says, okay, now I'm pulling the image nginx, which you told me that start container on this image. So I'm pulling the image. Who is doing this work? Kubelet is doing the thing, right? Because I said kubelet has to take the task and perform the task and go back and update the status back to master node, and it is sending the message. We are still at the master node only, right? We are not at the worker. We are still at the master node, and who's sending? The default scheduler has assigned this task, and the kubelet is sending message that, hey, I started pulling the image nginx, right? And then kubelet is again updating the status that, hey, the image you told me to pull, successfully I pulled that image, right? Which image? Nginx 1.19. I successfully pulled this image, and this is the time I took, approximately 5 seconds, 5.0489 something millisecond, but 5.0, approximately 5 seconds it took. So it says successfully I have pulled this image nginx, and this is the time I took. And then kubelet created this container test 123. So it says now image is pulled and I started the container. So container is started test 123, and then kubelet is again coming and updating saying, hey, I started the container test 123 inside the pod, right? And that is how we are able to see this pod is running here. Are you getting me, guys? So see, the scheduler is doing the job to assign whom to assign, right? That is what I told you, isn't it? in my theoretical session, right? This will
Yes.
take the talk directly. It will never say, hey, knock, knock, open the door, I want to give you some work. Not like that. It will just, because this guy maintain the inventory, it will just go take the thing. It got the this worker node, and then the kubelet has to do all the work. So kubelet is coming and updating the status, not in yes and no, but in detail. It can say image pull, yes. Content created, yes. Not like that, right? Detail, what you are doing, how much time you have taken, is it successfully pulled, or there any error, right? Everything this guy has to tell, this guy has to say, and we can check it here, right? So this section is event section is always very, very important, and for that we use describe command, not the get command. Get command will just give you the status, right? Just the status, is it running, not running, that's it. But where it is running, we don't know, all right? So describe command will tell you. So tomorrow we will do little more deep dive. Any questions, guys, before we wrap up for the day? All these command I'll send you.
Only
Yeah.
one question I have, sir. Can we
Please.
decide on which worker node we want to deploy the pod? Or it
Port,
always be randomly? Like
no,
pod.
no. Port number you can decide. I didn't decide, so by default it takes 80. You
No,
can
sir.
decide.
No, sir. I'm asking, you
Node.
deploy pod, pod on
You
the
asking?
worker 2.
Yeah. So this
Okay.
you cannot decide. If you want to decide, no, Kubernetes will not mind. It says then you have to sit 24/7 in front of me and tell me what to do next. Right? Can you do that job?
No.
Otherwise, we have
So,
to sit in front. Traditionally, if you see in Linux, unless you fire command, Linux cannot do anything.
right. Right.
But imagine I give you one scenario. If my pod is crashed in middle of night, nobody's there in the office. What will happen? Unless I go to office next day morning, and when I go and go to my data center, look at my production server, then I have to heal the application manually. But
No,
Kubernetes cannot wait that long.
correct. Actually, I think she understand the controller and scheduler part. Master node actually takes a decision of assigning the worker. I think she hopes to get it. But what if she decide to have okay, I want my
Yes,
job
you
to
can
run
do
on
that.
this particular. Yeah, this is okay.
Right.
You
Yeah,
can
okay.
do it, but only on some scenarios that I will talk
Scenarios.
about.
Okay.
Yes, yes. Not
Because
all
we
the time.
know.
Otherwise you have to sit and tell Kubernetes, do this, do that, do this, do that.
Okay.
24 hours you have to be in front of Kubernetes. Because Linux, unless you fire the command, you give instruction, it cannot do anything.
Okay.
Right? But in scenario, if you want to control, we can do it. That is allowed. But in some special cases only, not always. Otherwise, Kubernetes say that, man, better you do the job. I will go home, I will go for vacation.
Okay.
Right? So I'm just slightly touching that part, not yet gone there, but tomorrow I'll show you the capability of Kubernetes, how it is managing on its own everything.
Okay.
Right? Today, because of the
Okay.
time, I cannot venture there, but tomorrow for sure I'll go. But to answer your question, yes, we can do that. And we have use cases. Down the line, I'll be doing that also.
Okay.
Thank you.
Right? But
Thank
why
you.
it does? Okay, since you ask questions, just take one more minute because we are already in that context. So if you see here, this pod is running where? kubectl get pod -o wide. -o wide, we can use some extra switches we can get to know. -o wide means something extra. Output wide. Output. So I'm requesting kubectl get command that, okay, give me slightly wider output. Right? O means output, or O means in Linux we can use full argument by double hyphen and then use the full hyphen. Shortcut is single hyphen and the first letter. So shortcut is single hyphen and first letter is O, but it is basically output. So you see, if I just say without this, it gives me only short output, right? Only 5 columns. How many? 1, 2, 3, 4, 5. But if I request give me slightly wider output, it gives slightly extra column. These are extra column. And if what I'm interested, IP address of the pod, where it is created on this node, right? So it is done. Next time when I create it, for example, let me quickly create it one more pod, kubectl pod, and this time I'll say test 987, right? Some number, right? And then, or let's say 100 simple, and then image, right? Give some image, right? Let's say Redis database, right? Let's say Redis database I want to create. Let him take the so this pod is created. But where it is created, kubectl get pods, right? And see the status. This is running, this is running. 100 is also running from last 8 seconds, just now created. This guy is running from last 17 minutes, test 1, 2, 3. but where it is running, so I can use that switch -o wide, right? Where it is running, if you see, it is running here on the other node. Why? Because it is doing load balancing. It
Based on
cannot say
round robin.
based on round robin, exactly,
Okay.
right? It is doing
That I
load
want.
balancing.
Hmm.
Yeah, it is doing load balancing. Load balance means it cannot say that you are my dear friend, I will not trouble you. You can always go and relax and sleep. I will trouble this guy. This is my bad friend. This is not my friend, right? So it cannot do partiality. It has to do load. This guy is already busy. Scheduler says that okay, worker 2 is already busy with some pod previously we deployed. Now this guy is available, so this will go here, and you see they did load balancing automatically. One pod has been assigned to both the worker nodes.
Okay.
All right. So Kubernetes does so many intelligent things, right? Let him do. If we have to do, then we will confuse him, and it will be right. It will go nowhere. It will be all haywire, my way or highway. Okay. So let him do his own way, and we will talk more about it. It's very interesting thing. We have just begun, right? Our journey with Kubernetes just begun today, but we will go there. We will reach there with all the use cases. Vi deployment.yaml. kubectl apply -f and deployment. All right, now I will create one more file, load balancer, right, as my service file. And the file is very simple. What we have to do, copy the previous service YAML file, any file, notepad or anything, right, and then just change the type here. So load balancer, and then for the sake of convenience, I'll change this name. Instead of NP, I will say LB. LB means load balancer service. All right. So only this type we have to change, right? Even for notepad also we did the same thing. And let me save this file. Apply this file kubectl apply -f and load balancer. So it is created. So kubectl get. Let me copy paste this guy. So type load balancer has been created. So type is really important. This has been created. All right, and then where is my Kubernetes resources? All right, so we are here. All right, so let me push this guy a bit. Okay, so let me go and create it. So it is created, right? Load balancer is created. Now let me copy this IP address of load balancer. Come to this worker node. Before that, let me verify. Curl and the service IP is this. I'm able to access the pods. Let me go to another worker node. Copy paste. So I'm able to access here also. So this worker node is 31 92.213 and 85.81, right? Also I'm able to access. And finally, right, so the service is able to access the pods. So that means kubectl get pods -o wide. So these 4 pods we were able to access, right, from this node as well as this node. Okay, so now basically what is happening here is, where is my service? Alright, so we have verified everything is working, and this is my load balancer, and we verified on this service IP it is working fine, right? But if you see here, it is also using some about 30,000 port number. That means if I describe this service kubectl describe service, and service name is LBSVC. So the name of service is LBSVC, namespace is default, labels are fine, right? As selector, both the labels are there. Annotation we'll talk later, it's not that important, right? It's just to add some description. I will show you how to add it. And then this is the IP address of the service, right? So 10.96.8.60 is the IP address, and single IP stack, so it is same only, right? And port number, all ports are running on port 80, which is fine, right? And if you see this port number, we already decided that something about 30,000 is is about node port. So basically it is talking to node port, right? Load balancer is talking to node port. Node port forward this traffic to whom? To cluster IP service, right? So if I come here, what I'm trying to say here is, we have introduced one more layer, right? And load balancer will be running on top of the other services. So this is here. So we have introduced one more service, and this service I can name it as my load balancer. So when you create this service, right, this service will automatically bring the underneath components, right? The way the deployment brings replica set and other things, this guy will bring its own components. So load balancer service. All right. So this is what the load balancer will do. Load balancer, what it does, I will talk about more about load balancer. It will just send traffic to the node. Which node? Load balancer will decide, because we have many worker nodes, right? So this guy will decide which node, and accordingly it will transfer the traffic to that particular guy. So load balancer, it knows, it maintains, the job of load balancer is to route the traffic between the multiple worker nodes. That is the only thing. Rest the job will be done by node port. Once the traffic comes to that particular node, right, then many pods are running on that node. Maybe worker 1 is running 2 pods, worker 2 also running 2 pods, and worker 3 also running 2 pods, right? So when the traffic comes to worker 1, right, then it will reach to the pod. Which one? There are 2 pods running, this or this, that cluster IP will decide, because load balance, internal load balancing will be done by cluster IP, external load balancing will be done by load balancer, and the traffic routing will be handled by node port. So it will bring all the services automatically. So if you see here, I didn't do anything, right? We have only one YAML file, right? Only one YAML file, which is my deployment for to create the pods, and load balancer. This is the only service file, right? And through which we created this LBSVC, right? When you create this LBSVC, which is of my type load balancer, it brings the node port, right? Node port on a high port number, which is 31414, right? And the cluster IP which manages the traffic, right? And you see it is already having my 4 pods IP addresses. So all the endpoints are collected by this service also, right? So the load balancer will bring all the services, because load balancer has to be outside, right? It will balance the load balancing. So what it is doing, let me draw a picture here so that you can understand. load balancer service, right? So what this guy is doing? This guy is LBSVC is what? So we already have our IP address. All right, that's it. And what else? So this load balancer, what it does, it basically it goes and it talks to this guy node port. All right, and internally this guy push traffic to cluster IP service. This guy will send traffic to node port load balancer, and then node port in turn, once the traffic comes to the node, right, the cluster IP will take over and it will start managing the traffic, right? Which one? So it will decide, right? So this is the thing. And for the whole world, you are able to see my screen, right?
Right, sir.
Sure, sure. And this guy, so the traffic we will just have this IP address and the whole world will be accessing. All right, so you, me, anybody whoever wants to access, will just give this IP address and they can access it. All right, but internally it does so many things, node port and then cluster IP and all that thing. Now, just hear me out, right? Just very simple concept here, right? So this LBSVC, what it does, so this LBSVC, the main job of load balancer, if you know the concept of load balancer, right? They will they will do the load balancing between the nodes and they will also manage the traffic. So for managing the traffic, we bring the load balancer and they are really expensive. Why they are so expensive? Because load balancer, it will always sit outside the network, right? Outside the network. That means it will filter the traffic before hitting into your infrastructure or before coming into your network, right? So they will be always outside and the whole world will be hitting the load balancer directly, right? Not your network but load balancer, and then load balancer will filter the request, take decision and route route the traffic inside the cluster. So load balancer has to be always outside Kubernetes cluster, right? And what it does, right, in the simple terms, it will just manage the list of nodes, right? We have to just provide him the list of nodes, that how many nodes are there in my worker node, right? So that it can manage the traffic between those nodes, number of nodes. So list of nodes means just provide him the IP address. So load balancer, any load balancer nowadays, even Nginx also comes as a load balancer, but you have to pay the license, right? Not the open source free version. And there are many things. HA proxy is another very popular load balancer which people are using, right? So you have to purchase. And then all these cloud vendors, AWS, Microsoft, they also have their inbuilt load balancer, right? So it is basically part of infrastructure, right? So when traffic comes into Kubernetes cluster, it should not come inside and then all the nodes are choked and then you are managing it, right? Then it will be very difficult, right? Because the flooded of traffic is already hitting your nodes, right? So we will always keep this load balancer outside. You have to purchase this thing, load balancer, and install on one of the node available outside the Kubernetes cluster, right? So one of the machine you have to install it. This node, this load balancer, they come with one file, config file, only one config file, and in that you have to update all your nodes so that these guys should be aware that okay, I have to balance the traffic between these nodes. How? By managing a matrix, right? It manages the matrix, and in the matrix, right, it will follow that okay, how much traffic is flowing on worker 1, how much traffic is on worker 2, how much traffic on worker 3. So it will automatically come to know okay, last time I forward request to worker 1, and it will look at the matrix. Okay, the utilization is already 70%, 75%. It will look at the worker node 2. Worker node 2 is only having 40%. It will look at the worker node 3. Worker node 3 is having nothing, right? Only 10%. So based on the metrics, it will see okay, who is busy, who is not busy, who is available, who is not available, and then it will start routing the traffic. How? Based on list of nodes. So this guy is only worry about the node only. So let's say, let me do the numbering here. So let's say this is my worker node 1, this is my worker node 2, this is my worker node 3, this is my worker node 4, right? We have 4 worker nodes, right? So it will list of nodes will be entered 1, 2, 3, 4 inside the config file. So all the IP address will be updated in the config. So this guy will know, okay, I have to reach out to this machine. Here's the IP address. This machine, here's the IP address. This is worker node 3, here's the IP address. Worker node 4, here's the IP address. So we are assuming these are the 4. And then once the traffic, let's say it comes to the node code. Node means particular node, right? So let's say this guy, load balancer, decides that okay, let me send traffic to node 1, right? We have just started and there is no traffic coming, only now the traffic has started coming. So it will look at the matrix, okay, all are available. So it will send traffic to this node, node 1. When the traffic comes to the node, there are some pods running here, right? Right? So pods are running here. And what happens? So let's say this node, we are running few pods. Let me do the numbering. So let's say pod 1. This is my pod 2. This is my pod 3. So load balancer is just the list of nodes. That's it. I'm not saying anything. Just the list of nodes you have to provide so that it can do the load balancing, right? And the node, right? What is running on the node here? This node blue. What is running here? So if you see here, here you have to say list of pods. So there is a difference, right? Load balancer doesn't know where is your pod and how many pods you are running. It will only take care of machines that I have to manage traffic between the machines. That's it, right? Now, once the traffic come to a particular machine, let's say the traffic is coming to node 1, right? And node 1, what is the running on the node? Always pod. Kubernetes is only about pods only. So what is, if you go to any worker 1 or worker 2, what will you find? Only pods, right? That means your application running inside the container. So only pods. So list of pods, once you come on the node, right? How many pods are running? Let's say on worker 1, this guy send traffic to node 1, right? And then node 1, once you come to the node 1, what is running? Pods. So if I come here and if I say kubectl, right, or if I say node is equal to, let's say worker 1, but this is my worker 1. Can I display directly? So how wide, and then I can say grep, right? Grep. So if I come to the node, right, this is my worker node, assuming, right? So 2 pods are running, right? So currently we are having only 2, but normally it's more, right? 10, 15 pods, because we don't run just less number of pods, we can have more pods. So assuming 2 pods are running, 1 and 2. So cluster we will decide which pod. So it will maintain a matrix here that okay, what is the traffic on pod 1? What is the traffic on pod 2? So it maintains matrix. So be looking at the matrix, okay, the no traffic on pod 1, it will start sending traffic to pod 1. till it reaches to 80%, right? And if you look at the metrics, okay, it is already reached at 80, it will start routing to pod 2, right? And when both the pods are busy, the deployment may scale up to another pods. Maybe pod 3 is also running, or pod 4 is also running on worker 1, right? Then it will start sending the traffic to this pod and this pod by looking at the metrics. So these guys, they maintain the metrics. This guy also maintains the metrics. This guy also maintains the metrics, right? Load balancer. So what this guy will do? This guy will maintain metrics of nodes, only nodes, right? List of nodes. So nodes, how much traffic is on worker 1, worker 2, worker 3, worker 4. So these are yellow tags are nothing but my workers, worker 1, worker 2, worker 3. So it feels that, okay, 1, 2, 3 are already busy because previously it sent the traffic, but worker node 4 is available. So it will send traffic to worker node 4. And once it comes to the node, what is running on the node? Only pods, list of pods, right? And the cluster will decide which pod 1, pod 2, pod 3, pod 4. Accordingly, my access will be provided. So everything is automated, and because of this, we need multiple services. Load balancer is basically the thing. Currently, I have not implemented any load balancer because they are really expensive. I cannot purchase it, right? So if you see here, my service kubectl get service. So if you see here, right, this is still in pending state. Why it is in pending? Because you have to install load balancer on one of the machine outside the cluster, right? And in that, you have to give that IP address of that machine. That's it here, right? And then this will be mapped to this service IP address automatically, right? It is something like public and private. So this is the internal actual private IP address, and external is your the IP address of the node where you have installed load balancer, right? So that will be here. So it will automatically map. It is something like public and private, right? So we don't create, right, manual, but they do the internal binding. Do you know the concept of public and private?
Yes, sir.
Yeah, so there's some external IP address, right, for the outside world, but internally it is mapped to the actual IP address, and the traffic will be automatically followed because both are binded, right? You need not to do anything. The same thing it will do it here, right? External IP, right? And then whole people, they will be accessing this thing, and internally it will be forwarding. But actual is running on node port only, node port service. So what I have to do for testing purpose, quickly go open this port number, come here, and then where is my security group? Security. This is my security group. Open this group, edit, and what is the port number we have to bring? 31414. So let me take out any previous 31414 and save it. You can add new rule or you can modify your previous port number because previous port anyhow it's not working. All right, and then go to the instance and take the IP addresses. So worker 1, select it. What is the public IP? This is my private IP. Don't take private IP. This is the actual IP. This is the dummy IP address assigned to this guy. So let's come here and host name -I to see the IP address. Curl. This is the IP address of this node :31414. I'm able to access the pod. That means it is already enabled. Why I'm not? Okay, it is running. Okay, took some time. Okay, let me share this IP address with you. So load balancer is only for basically manage the traffic between the node. That's it, right? And I've not configured it because they are really expensive. All right, so you can do testing like this. Meanwhile, let me go and take the another public IP address. This is public IP address is this, and let me go here and test it. 31414. Okay, so I'm able to access. It's basically node port the way we did it yesterday. Same way it will work. So let me paste both the IP addresses. Okay, open the browser and test it. This or this, anything is fine.
So both are accessible.
Both are accessible, right? Fantastic, right? So node port service is very fast, let me tell you. And Kubernetes, this is a favorite service, right? Everybody comes to node port service and doesn't need anything. It's just a simple YAML, that's it. It doesn't need your infrastructure, load balancer, give me this, give me that, nothing, right? And it brings other services also, right? So my Nginx is running and we are able to access, right? So this is how we can do it, right? So simple logic, but remember for load balancer, this is the only thing which we need. We want to have a load balancer where we will put all the list of nodes in the config file. There is only one config file which comes with the load balancer, right? Open it and make the entries of all your worker nodes, right? Host name and the IP address, host name, IP address, host name, IP address, like that, like that, like that, right? Update it, right? And then it will start routing the traffic to this worker node, that worker node, this worker node, that worker node automatically by maintaining a matrix. That each node, it will maintain the matrix. How much traffic is flowing on worker 1, how much traffic is flowing on worker 2, worker 3, worker 4, like that, like that, like that. Same way, this guy also, once the traffic comes to particular node, what is running? Pod. Who is doing this? This internal load balancing? Cluster IP, right? So we will be able to access the pod, right? So in the my worker one, there are two pods running, but which pod is accessing, right? I don't know, right? And it is not my concern, right? But I should get an access. So it is as good as whenever I want to do some transaction on banking application, I will just open the app. I'm least bothered whether it is coming from Google database server 1 or server 2 or server 3. I'm as long as I'm able to access the application, that's it. Internal traffic might be managed between worker 1, worker 2. Google must be using some load balancer, that's fine. So same way here also, which pod 1 or pod 2, right? Doesn't matter, right? We, as long as we are able to do it, and internally it will do all the traffic management, right? Silently without any human intervention, right? Intelligently it will do everything, right? So now today we bring this service. This service will bring all other services, right? You can understand this way, or you can understand from the other diagram this way, right? So we have introduced this load balancer service. Underneath service will be brought in by this guy itself, right? The same way the deployment was doing, right? When you create deployment, underneath components will be brought in by the deployment itself. Same way this guy is also doing. So Kubernetes follows, right? No manual intervention. It will not ask, okay, you have created load balancer, but where is my node port? You created notepad, but where is my cluster IP, right? No need to, right, do all that manual thing. It will be automatically handled by Kubernetes itself, right? And that is the power of orchestration, right? Each and every resource will be, it will exist automatically, and then they will play their own role, key role, right? So here load balancer will manage traffic between the nodes. Once traffic comes to the node, right, what is running in the node? Pod. And who will do? The cluster IP will manage the traffic. Otherwise, what will happen? This node pod will send traffic to this pod, and again 85%, 90%, 95, 96, 97, 98, 99, 100 and blow off. Then it will send, okay, this is the only pod available. Let me flood it of traffic will hit this guy, and this will all blow off. So we need internal load balancing, and who will do it? Cluster IP service, right? So cluster IP service is always internal only, but it will do all magical things, right? Outside thing, we need other services, which is node port. And if you want to do balancing of the traffic, we need load balancer, right? And YAML file, I'm using the same YAML file, only the type is important, right? Whatever type we have changed, only I'm modifying the type. If I want to click cluster IP, I will say type is cluster IP. If I want to say node port, I'll say node port. If I want to say load balancer, I'll say load balancer. All right, makes sense? So this is all about the load balancer service. So kubectl describe service LVSVC, and everything is right. I'm just following simple command, describe command, get command. So get command is here, get service name is LBSVC, and you can put one space or you can put hash, that's up to you, right? Anything is fine. If you give space, it will automatically take the name. If you give like this, it will read the name immediately after the service. So both are fine, right? Because Kubernetes gives in this way, right? So I'm using the same way, right? And then describe service. When you describe, you will get to see everything is written here: node port, cluster IP. So traffic policy, it will use cluster because it is our internal load balancer by default. right? Nothing from outside by default. And Kubernetes is always concerned about the internal, about your health of the pod. It should not send all the traffic to this guy or this guy or this guy or this guy. Otherwise, they'll start dying, right? One after another. I don't want to make them die, right? So it will always let them breathe easily. So cluster IP is needed. Node port, how to reach the traffic to particular node. This is the guy, right? And we already seen it. So same concept, whatever we have learned so far, same concept also I have repeated today also, right? But it will do traffic between the nodes, because node board I will be doing it manually, node 1 or node 2, but here it will be automated. That's it, right? And if you have your certificate installed, right, your domain registration, everything done, so no need to even give IP address. You can directly set the URL also, something like www.devops.com or anything, whichever your business portal, you can directly do it. So what I'm trying to say here, if you know this concept, all these are networking concept. So if I say ping www.google.com, right? I don't want to give IP address. But basically this URL is mapped to IP address because this is a registered domain of Google, right? If you see where it is going to this IP address, right? So it is going to this IP address. So anything, right? So it is going to this IP address, all right? So basically if I give the IP address of the service and if I have my registered domain, right? So we can have our own certificate also. So describe instead of this, let me say get. So if I have my IP address this or my external IP address, I can directly map to do a domain registration. So this IP address will be binded with my URL. This IP address will be binded with Google URL. Alright, so likewise we can also do a domain registration and then you can install that domain registration certificate and you can start using the URL instead of IP address. So normally if you see big businesses, they are running in Kubernetes, but you see always URL. So that is also achievable. We can do it further, right? It is something advanced. We can do the domain registration and we can even do this also. It's possible. All right, make sense?
Yes, sir.
Okay. So Subbu has not yet joined, right? No, he didn't. Okay, no problem. It's very simple. He can understand from the recording. Now we have time, right? So in the 10 minutes, I want to finish one more thing, daemon sets. Daemon set is also like deployment, but the concept is slightly different, right? So let me show you daemon set. Okay. So daemon set is what happened when initially when Kubernetes was introduced, right? There used to be so much garbage, right? Garbage means when you create pod and pod will be scaled down, they will be deleted. When you scale up, the new pod will come, right? And then again, whole night when the people are sleeping, nobody's accessing, it will again automatically scale down, right? Because of the auto scaler. So all that. So what happens every time the pod remains, some traces are remains always, right? Which are unwanted. We are not going to use it, but because of somebody is coming and going, coming and going, coming and going. I mean to say pod, right? When you scale up, pods are coming. When you scale down, pods are going, right? But they leave some traces. So all whenever they left, there's few traces remains. So it is garbage over a period of time. After 1 year, there will be something, right? Some temporary files here, there, something it will always have, right? Every application does like that, right? So Kubernetes was coming with an inbuilt thing to remove all this garbage. So we used to have daemon set to remove the garbage automatically, right? It's fine. It feels that okay, this is unwanted pod is not, this pod reference is already deleted, but some files are there, it will remove those things. So we call garbage collection. So if you are programming a developer, you know this concept. Every programmer, they do all these things, garbage collection and all that thing, for so that unnecessary the application should look neat and clean, right? Unnecessary unwanted traces can be removed, right? Now if you see here what is happening here, right? So Kubernetes later what they do, they also gave this feature, because this feature was amazing. But Kubernetes cannot just do only one type of role. Kubernetes always does multi-scaling. So they empower these daemon sets, right? Daemon sets Like, so it's like replica sets we call daemon set. What is daemon set? I'll talk about it, right? So don't worry about it. So daemon set is basically, it's a node concept, right? Node, Kubernetes is very, very particular about the node, health of the node. So basically daemon set is a hygiene feature to take care of the health of the node, right? Because for monitoring for my master node, we already have service discovery, which will take care of health of my etcd database, my so, uh, etcd scheduler, controller, manager, and API server, right? Four components. We already have a master node service discovery. But for worker node, nobody is there. And my pods are running on worker node. So that means whole world will be accessing my worker one, worker two, worker three. Right? So if somebody introduce virus, right? If somebody introduce virus, then everything will be, because they are interconnected. So it will start spreading the virus from one worker to another, another to another, another to another, and the whole cluster will be virus infected. And imagine if that is the case, then it would be a disaster, right? So Kubernetes is basically is very particular about the health of the node. So Kubernetes manages the health check and all that thing through the daemon set, right? So what we do, daemon set is basically just a node concept, remember, not related to pod, right? It's a node concept. So this guy, what it will do, so you can load your default software through the daemon set. For example, uh, let me give you a few examples so that you can understand in better way. So for example, I joined a new company, right? And a new organization, and let's say I'm the sales guy. I don't need to come to office every day. I will be traveling to various customers, visiting them, showcase the capability of our product, and try to sell the product in the market so that a revenue will come. And somebody needs customers, I'll collect the requirements, and we can customize the solution, and we can offer again back to customer. And that is how our revenue generating, because we are pioneering some product. All right. So I'm a sales guy. I joined the company. Now, right, I won't be coming to office every day, and so company has given me laptop, right? So I can use the company laptop and go to other customer places. But I'm traveling, so I may not be connected always to the office network. I'll be connected to some public network when I'm traveling, staying in the hotel. I'll connect the hotel Wi-Fi, that is public network, and I'll do my work. And then I again go to customer place, I'll use customer network. So that means I am hopping multiple networks, and all these are public networks, which are slightly on a on a risk side, right? Because this is nobody's protecting. Public network is not in our hand, so nobody's protecting me. So I'm connecting to public network, I'm connecting to customer network. Again, I'm going to different place, different hotel, different public network. Again, I'm traveling, I'm using different public network. Again, different city, different customer, I'm using different networks, right? So I never know if my laptop is infected or not, and there are high chances that my laptop is infected, right? Because these networks I'm using for my work, but these are public network, right? Now imagine if my laptop is infected, and if I come to office after 3 weeks, because 2 weeks I had a customer appointments, this and that, I finished it, and the third week I'm resuming back to office, right? I'm reporting to office. I come with my laptop and connect to my office network. My laptop is already virus infected, right? What I will do, the moment my laptop comes in the network, it will start spreading the virus to the whole network, right? Might be all the machine, wherever I'm connected to which network, it will spread the virus from my laptop, because it's an infected machine. And that is the job of virus. It will always, right, it will spread. So it is spreading the whole network, and imagine the situation, right? It's a pretty bad situation. It would be a disaster, that, right, because of one machine the whole network is collapsed, right? And to bring it back, it's a really hard job, very difficult job. You never know, right, what file has infected, right? Your business files, your customer files, everything, right? Your project which you want to deliver may collapse also because of this small thing. So what my company will do when I join the company, they will ensure that the laptop which is given to me, it should have default software like antivirus, right? Antivirus is not going to harm me. Whenever I start the laptop, in the background, it will automatically start and do the cleaning. If anything is infected, it will already give me warning, and I will delete it all by itself. It will kill it, right? So it will do the cleanup job. What? Antivirus. So who is protecting? Antivirus is the software which is protecting. Likewise, we have many software nowadays. For data leakage also, we have many softwares available so that no data can be hijacked from my laptop, right? So same way, in Kubernetes also, I want to ensure that antivirus is running on all the worker nodes, right? Or any other software should be running on all the nodes. So it's basically a node concept. So we can give any software. So we can load, this guy will load the default software before it is actually joined the cluster. So even the new node, when you bring into the cluster, right? So if any node, how will you ensure if that node is infected, right? Because blindly you are just connecting to your network. You are requesting to IT services, right? And IT services will, they are humans also. They missed it. They didn't do all the activities, and they assigned this node to you because you requested. And when the node is assigned, you connect to Kubernetes cluster, and that infected node will again spread the virus to all other working nodes in the Kubernetes cluster, and your cluster will collapse. So what you do, it happened with me, right? It happened with one of our customers. We really had a tough time. What happened? Let me give you the scenario. So what happened is, right? So the IT team, right? So they manage all the machines, different projects, and whoever requesting, they are allocating the project, tagging that machines, and they do billing and all that thing is separate thing. But this is the normal process, right? I'm not going to finance and billing and all that thing, right? So that is handled by our project manager and all those things. So what happens is, I took all the approval and requested to give me 2 machines, right? Because I want for our project, right? After 6 months, we realized that okay, 2 worker nodes are not sufficient. We need 2 more because more and more applications are now coming to Kubernetes cluster. So we requested for 2 machines, right? IT support guy who they assigned the 2 machines, right? And we connected the machine. One of the machine was virus infected. We never knew, and we connected, right? And started spreading the virus, and all the worker nodes were collapsed because of the small mistake. Now, from where the mistake has happened, right? So what happened is the IT guy who was working in different shift, right? That guy has already put down the paper, right? That guy resigned, and when I requested him, right? So 2 days before, right, we requested, and after 2 days, right, that guy was having a last day in the company, and he assigned me the machine because he has to do the job, right? Last day also he has to, whatever pending work is there, he has to do. So that guy came in the shift, and he saw that okay, this is the pending request, it is already approved. He allocated those machines. Now before those machines, this guy has to ensure they have their own checklist. He has to format, he has to run some software and check that there's no virus infected. All this he has to do. He didn't do it. He was busy in his own formalities, meeting friends, saying goodbye, right, and doing exit clearance, right, moving from this department, taking the sign, go to other department, this that, so that he can exit in a nice way, gracefully, right? So he was busy with his own work. He spent time in his personal work. He didn't focus on his work, that what he's doing. He just updated, he collected the machine, and he updated the inventory, that 2 machine he received from some other project. And those machines, he didn't put all the checklist, he didn't do do the proper steps, right? Scanning the machines, formatting the hard disk, then again check, right, the health hygiene of the machine. He didn't do all that thing. He just collected it, updated the inventory system, tick 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 tick, and he allocated, okay, this guy, they need the machine, and we were following up rigorously that please give us the machine, please give us this guy. He said okay, he's the only guy in that shift, and this guy, he's allocated those machines, right? And then the support engineer, he will do all the thing, right, because he has to approve. So he gave the machine this that, and then they provide machine, and we connected to the network. And this guy already left, right? When all this situation happened, this guy was already left because he had a last day, right? So humans can make mistake, we cannot rely on them. So Kubernetes has come with an special arrangement that we cannot trust human beings. So daemon set is the guy who will do all this task. What he will do, whenever you bring any new machine, right? This guy daemon set will first do the scanning, right? If you have antivirus software or anything, whichever you given to daemon set, it will run, deploy the antivirus and scan it. And if daemon set says, okay, this machine is fit, this machine is okay to be joined cluster, then only it will be allowed to join the cluster. Not just bring the junk machine or infected machine and then join the cluster and then fall into the problem and then talk to this guy. No, then it's meaningless. All right. So this is a very simple concept, right? Daemon set will install the software which are needed default, right? So I am a sales guy. Antivirus is needed by default, right? It's not going to harm me. Wherever I go to customer, it will not say, no, don't connect. It will not harm me. It will run in the background. So as soon as I start my laptop, I need not to tell antivirus that, hey, I'm going to different customer, right? You have to please be alert, right? It will do its job. The moment I start it, it will be auto start and it will start automatically. Same way, daemon set is also like that. You have to introduce daemon set in the Kubernetes cluster, assign him the application that what you want to do. You want to install some antivirus, monitoring application, or some agent software which you want to protect for your data or anything. You have to provide him the list of software. It will do automatically. And when new node comes, it will also do like that. All right. So today what I have done is right? We will do this thing. So it is basically a node concept, and it will always ensure to run the default software. Default software means again in container format only, because Kubernetes understand only container. Because why? What is Kubernetes? Container management software. All right. So I'll just quickly create it, and then we will see all the thing. I have to give you the story so that you can correlate it. Right. That is the reason. But when you create it, it will not take much time. So I'll take another 2 minutes, and then we are done. So this is my daemon set file. So type is daemon set itself, right? So type. So it's like pod, replica set, deployment, service, or now daemon set. So type is daemon set, right? And if you look at it, apps v1 is something like deployment also, right? Even the structure of this thing is also like deployment only. So Kubernetes YAML files are very straightforward. So API version, kind, metadata, and spec, 4 core properties. Metadata is nothing but the name. So I'm using fluentd. So I went to Docker Hub, but I didn't find much images, right? So hub.docker.com. But I found fluentd. Fluentd is monitoring agent, right? So if you know the monitoring application, every agent has to install on each worker node. And what these agent do, they collect the log every 5 minutes and send it to your centralized server. In our Kubernetes, like master node is our centralized server. Master node is the controlling unit who will control everything. Same way, this agent, they have the master monitoring server, and they will collect the logs and send it to the monitoring servers. Collect the log, send to monitoring server, right? So worker node will also have agent which will collect the logs every 5 minutes and send it to whom? To monitoring server. Worker node 2 also collect the logs every 5 minutes, and through the agent, this agent will collect the logs every 5 minutes and send it to whom? To monitoring server. Monitoring server nowadays comes with an analytical engine. They will automatically analyze your logs, incoming logs, right? And they will filter the unwanted files, only appropriate, right? False positive, they will filter it, and only the things which are there, they will process and put the information on dashboard with few indicators: green, yellow, and red. Green means everything is healthy, right? All the logs are coming with healthy state, right? If some worker node is having some problem, it will start sending the warning, right? Maybe yellow indicator will change from yellow. Yellow means you need attention to look at it, right? So system is sending some warnings. So yellow means you have to look at it. And if something has really gone down, the log file will say, okay, this is down, this is down, this is down. Then it will alert in a red indicator. Red indicator means something has gone down, immediate attention is needed. So monitoring tools come with a huge dashboard with indicators. You need not to always check the log files. Look at the indicator, right? We need not to review the log files every time. Otherwise, you will go mad. Log files are just right stream of lines, right? Thousands lines of code, and you will go mad, right? So you just look at the indicator, because the analytical engine, it is processing the request, and appropriate message will be displayed through indicators. So I need not to review the log. Green means all good, no need to check. Yellow means only the file on which worker node it is coming. Only that node you have to go and look the log, and only for during that time, right? 9 o'clock it was green, but now after 9:30 it is yellow. So you will just go and check the log of that time only, right? So that way it is little more quick, and you can start doing it. So I didn't find antivirus and all that thing images available on here, like McAfee and all that thing. I didn't find this image. I tried, but I didn't get the result, right? I don't know, the 4 months they have introduced something, but for monitoring I found few images, right? If you know ELK and all that thing, right? So okay, ELK, and they use Fluent, right? Fluent D. D means a daemon, right? So daemon. So Fluent application, and it is very, very popular, right? So I also use this image Fluent D, right? And from where I got this name Fluent here, right? So I'm using the Fluent D so that it is basically monitoring tool. You can give any name, but I'm just using the same name Fluent D, right? Label also I'm attaching. Okay, this is going to be my monitoring agent, so I'm using this label also Fluent D. And spec and selector are same, so I'm using same label. So selector will take the same label. Template, as I said, metadata and spec is needed. So here if you see container, right, under the container the image is Fluent D. This image I've taken Fluent D. This image Fluent D. You explore it here, you will see the image, right? This is the image Fluent D. Docker pull Fluent D. If you are on Docker, use this command. So I'm using this Fluent D here, and I'm giving the container name also same, so that I can remember this is my Fluent container, right? Container is also Fluent D. So we have created this file, very simple file. And right, what is the thumb rule? What is inside the kind? That means your get command and describe command. you can use from this guy, right? So kubectl get daemon set, kubectl describe daemon set, right? So let me go and create it. So kubectl, okay, first I have to create it. So daemon set or sets, that is fine. Singular plural is not an error in Kubernetes. Like pod or pods, we say, that's fine. So I'm creating, what is the name of this thing? Fluentd. So that's fine. Okay, so and now let me apply kubectl apply -f. So I've created this fluentd, right? So it is coming from daemon set, right? Daemon set fluentd created, right? So get command and describe command, as I said, kubectl get, what is this? Daemon set, right? So daemon set, right? Or you want to use shortcut, what is the capital letters? D is capital and S is capital. So you can use DS also, right? So let me say first daemon set, or I can use a DS because D is capital, S is capital, DS, right? So same. So what is the name of my this thing? Fluentd. Name is Fluentd. Sorry, here's the name. We are using Fluentd, right? So label also same. Name is Fluentd, and the name is also Fluentd. So this is the name. How many worker nodes? This guy is very smart. He should automatically go and figure it out how many nodes are there. So kubectl get nodes. So there are two worker nodes. Where my pods are running, these two nodes. The whole world will be accessing my worker nodes, not the master node. If we give access of master node, then anybody can corrupt my master node. So master node is always safe, right? Pods are running only worker nodes. So this you already know that there are two worker nodes. So since it's a node concept, it will go and pick up how many nodes are there. So it says, okay, you have two nodes and both of them are available, right? Both of them are available, both are in ready condition, right? So it will go and update this monitoring agent pod, right, on both the nodes, and both of the nodes are now available with this pod. Which pod? Fluentd. So Fluentd is running. So can I check this? Since it's a pod only, right, running as a monitoring agent application. So if I say kubectl get pods -o you should see this. So these four pods we are running previously, right? And this is the two pod which is created. And you see one pod is running on this node, another is running this node, right? IP address 85.81.92.213. It will automatically do it, right? If you are confused, right? So you can just go and describe it, right? So describe command, as I said, will give you the details of DS, or you can type daemon set, and what is the name? This is the name. If you see here, it's very simple, right? So Fluentd selector is name and label is fine. Annotation we'll talk little later. Not if you see desired number of nodes, right, to be scheduled, right? So it's already go and take the inventory how many worker nodes are available. So we have two desired nodes. Desired means, right, existing. Both the nodes are available. That means sometimes we do maintenance. That's one of the worker node is not available because I'm upgrading, the disk is full and I'm attaching additional disk. So we do some maintenance activity. So for that, sometimes we bring the node offline and we perform this maintenance activity, right? Only for attaching disk or anything, right? If that is the case, right? So if the current number of node, it also take, right? Two nodes, total number of nodes are two, which is fine. But are you performing any activity and because of that one of the node is not available? No. Currently number of nodes available to be scheduled for this application is also available as 2. So it will update the inventory with checking that currently desired is fine, total was this, but both of them are available. Yes, it's available. Then number of nodes scheduled with up to date pod. With up to date pod, this application Fluentd, my monitoring agent, I want to deploy. So this guy will automatically go and take the inventory that okay, I will take this number of nodes where I will schedule and update this application as a pod, right? Because Kubernetes understands only pod. So how many nodes are like that? There are two nodes and I have to deploy two pods, right? And then once it will be done, it will update the state that okay, number of nodes scheduled with available pod. That means it has scheduled this application. This application is installed and it is available as up and running, right? So it will tell you here that it has two. Is the any number of node it has misscheduled because there might be one of the node is not available and I was trying to schedule but the node is not available, so I may miss the scheduling. So it will update here. Currently this is not the case, so it will say 0 miss schedule. All right, what is this? These are nothing but pods. So how many pods it is running? Two pods because there are two worker nodes, right? Anybody waiting? No. Anybody failed first and later They got succeeded? No, that didn't happen. So they are successful. So this fluent D image which we do, it is doing, and it is created the pod here, pod 1, pod 2. And now you see this guy has its own controller. So they are not going to conflict. They are not going to disturb anybody. That here replica said, can you give me your controller, or deployment, can you give me your controller? No. This guy brings with its own controller, and it will always do the monitoring of the nodes and deploy the application. If my node is, if I want to add a new node, it will also do the job automatically. So once you introduce daemon set, it will do the always do the hygiene feature. It will scan the machines every 20 minutes, and it will automatically ensure that this application, this pod monitoring agent, I'm installing monitoring agent. If I've installed McAfee antivirus, the antivirus, it will always run 24/7 because of this guy controller. If I delete also, right, kubectl, if I delete pod, it will automatically bring. For example, let me show you that also. Kubectl delete pod. Let's say I want to delete this pod, right? I can take from here or here, both are same, right? This is here, xfqxc and gm6t7, right? Anything. So let's say I want to delete this guy, right? So it is being deleted, not yet deleted. Now it is deleted. Now if I just go and check, right, you see it will automatically bring 4 seconds automatically. I didn't do anything, right? So with a new pod name, it will bring automatically. So 2 pods will run. So one is running on this worker node, another is running on this worker. Always remember. So the power of daemon set is do monitoring. Always remember, controller, create the pod and then don't just leave it like that. That my job is done and I will go to sleep, right, and do whatever you want. It is not like that. This guy will always be awake and do the monitoring. And since I deleted it, it recreated it automatically, right? Now, since we have only 2 worker nodes, but you see there is one more worker node, but this is I have not yet added in the cluster, Kubernetes cluster. So let me go and add it. So kubectl get daemon set. Currently 2 are running, and kubectl, I'll take another 2 minutes. We are almost done. So we have 2 workers. So 81, 85, 81, 85, 81 is here. Yes, this is, and this is 92, 213, 92, 213. But this node is not yet added. 84, 94, right? 84, 94 is not yet added, right? I created this node, but I have not added this node. So how to bring the node into Kubernetes cluster? Do you know? If I want to add a new node into cluster, how can I bring it?
So just run kubectl list token, and
Yes,
that token
exactly.
will need to join on the new worker node.
Exactly. So where is my file? Okay, so I think I've copied it. So this I already made a copy. I already have this command available with me. I will come here and add this guy, right? And then I'll come here and say kubectl daemon set watch. Let's see what happens. So currently 2, but I'm bringing another, right? So daemon set should automatically first install software, do the scanning, and then if everything is fine, then only it will allow the Kubernetes node to be part of my family. Then only it will allow to join the class. Otherwise, it will reject it. So let's see. You see, in the background, I have brought another node. So it says, okay, you are bringing one node. Currently, 2 are having this agent running, right? But you are bringing new node, right? So it is not updated, but it is already come to know that you are bringing new node. Then what it will do, it will try to, right, say this node is available, it will try to update it, right? You see here it is trying to update, not yet ready, but trying to update it, right? And not yet available because it is not yet updated, it has to finish. And you see all the 3 nodes are now running. So if I bring any corrupted machine or infected machine, I need not to worry. Human set will do the job. As I told you the story, humans can make mistake, but this cannot make mistake. And if you now see 3 pods, right? One more pod has come, right? For just 47 seconds, and another node is also running. So 84, 94 is covered, 92, 213 is covered, and 85, 81 is covered. All the nodes are now running. So it's a node concept. And whatever application you give, right? So for this daemon set, so this daemon set, we gave this application, right? This container image, all right, fluent D. Same way I can create one more daemon set and I can give the name daemon set my antivirus and give the antivirus image, right? So I can bring each application by creating multiple daemon set. One daemon set is responsible for monitoring agent, another daemon set is responsible for antivirus, another for some data security, like that. Every application I can bring, and they will be running by default. Whether you are bringing the pod or not doesn't matter. If I say cubes, it will get pod, right? These pods, they are running only 85, 81, and 92. None of the pod is available on this new node. That's fine, right? It is not that you do load balancing. It is what is the mandatory condition? One pod should be running on all the machines. That is the condition. Remember, antivirus has to be available on all the machine. This is my condition, right? In a business logical sense. So it will by default ensure that one pod should be running. My application should be available on all the nodes. That is the only thing. So here it will never scale that, okay, I need 2 instances of antivirus. No, that is meaningless. One instance running on my laptop is good enough. So same way, one application should always be running. So that is the concept of daemon set. And there are 3 nodes and all of them are covered. So it's a node concept. I'll send you this slide also, don't worry. But this is just a node concept. I've written it here. Node concept, always ensure to run default software. So give default software like monitoring agent, antivirus to daemon set, and it will deploy one application. It will ensure always 24/7, 365 they are running, they are available. All right. So it is the hygiene feature of Kubernetes.
So it means this we should install in the beginning of the
Yes.
configuration.
Yes. But since our cluster is not production, so it is fine. And we want to also have a detail. We have some understanding, right? So, but it should be there in your production. So if customer has some application like banking application, they want to always have some monitoring agent, right? It's daemon set is the only guy who will help you. All right. What is the mandatory condition? Every application should be available on all the worker nodes. So it's a node concept, right? Not 2 daemon set will go to one worker node, another guys are free. No, it's not like that. You have to safeguard all the nodes. So it has to be on all the nodes.
So it will happen automatically. So it's not
Automatically.
Yeah.
Yes. But you have to first time you have to bring it, then it will be automatically. That is what I did. Right? That is why I took this use case.
Got your point, sir.
Okay then. Okay. So today what we will do? Today we'll talk about configuration management and environment variables. All right. Normally environment variables, configuration, all these developers thing. So when a developer, when he build a solution or design a product, right, they need to have some environment specific information to be captured in environment variables. For example, the executables path, right? So we have to give the path of the executable, right? Dependency files or the DLL files, we have to set the path through the environment variables. So when my application comes, it automatically set up a runtime environment, right? Where is my DLL? Where is my executable, right? All the default folder path, everything we can set it, right? So we set environment variables. So same way, Kubernetes is also an environment, all right? So whenever you want to have some environment specific runtime environment you want to set up, we can also expose through the environment variables, right? But the technique is slightly different. We don't want to put it hard code into our YAML files, because in Kubernetes, the applications are deployed through the YAML files, right? So we want to keep our YAML files as universal files. Universal file in the sense, I want to deploy this application in any environment, maybe the development environment, testing environment, pre-production environment, or a production environment, any environment, right? But if I hard code it, can I deploy in any environment? No. Then I have to create multiple copies. For development, the specific development environment variables, I have to put it in the YAML file, right? And for testing also, environment is different. So different environment variables, right? Pre-production, production, all that thing. So who will manage all these YAML files, right? So Kubernetes doesn't believe in all that thing. So what Kubernetes says, okay, we will keep the environment variables, right, out of the YAML files, so that we cannot hard code it. If you hard code, then you have to make multiple copies. For development environment, the URL will be different, right? So that is also an environment variable. The same URL I cannot use for testing environment. Same I cannot use for pre-prod and prod, because the URL of each environment will be different. All right. Then MAC address and all that thing will be different. So we use environment variables, right? So Kubernetes, we will see how to use environment variables and various other configurations, right? So we say configuration management technique. Configuration management means that the application which needs during runtime, to run the application, we need to create a runtime environment using various configurations. So here Kubernetes use configuration management. technique for various environments like development, testing, staging, production. Right. So there are basically two types of configuration management which we do in Kubernetes. One is plain text, right, which is simply plain text, right, which we say key value pair, right. For example, if you see here, this is my plain text configuration management, right. So and in this plain text, I can use various other things. For example, what is a variable? So foo is equal to bar, hello is equal to world. Likewise, I can have various and one variable. These are simple things. We will bring all the use cases also. So some variables we want to set, how we can set, we can bring it here. And it's a plain text. Whatever key, the key is foo and the value is bar. Hello is the key, value is world. So if anybody open this config file, they can see what variable I'm using and what values I'm setting. Right? So these are plain text, so anybody can read it, plain text. But if I have some username and password for my application, right? For example, database application. Database application, normally we log in through credentials like username and password, right? And each credential we have some role also. Some people log in with an admin, some people log in as a read-only user, some people log in as a read and write user, right? So that they can make changes, right? Testing environment, we give only read access, they cannot change it. So whatever we have fixed, they should use it and test the functionality of the application, right? So if I put a username here and password, right, and respective password here, if anybody open my plain text, right, he will get my credentials also, because it is exposed. Plain text means anybody can read it, right? And Kubernetes point of view, it is not safe, because if somebody can open and somebody can steal my credential through this YAML file or a text file, YAML files are again just like a text file only. If somebody can open the YAML file and read my username and password information, then it's a disaster, because he will try to use this credential and try to hack my database, right? Because he has the credentials, username and password. If he can use the username and password and log into database, and imagine if he succeeded and change the password, right? Change the password, then what will happen? Next time when you come, will you be able to log in? No, because you are using the old password. The new password you don't know, somebody has changed it, right? So we cannot put the critical information into plain text, right? For that we use some encryption decryption techniques, right? So this encryption techniques is same like this only, but the type is different. Here we say secret. Secret means I don't want to use plain text, I want to hide it, right? And those are my secret credentials. Username, password, normally we keep it as a secret. We don't expose it just like plain text that, hey, take my username, take my password, right? We don't do like that. So here, if you see username, some junk characters, password, some junk characters. If somebody open this file, because YAML files are just like text file, anybody can open it, double click and open the file. But if somebody opens it, username, he doesn't know, because for him, it appears to be junk characters. Why? Because I have encrypted it. All right. So Kubernetes, when you use a secret resource, right? When you say config map is equal to secret, that means kind is equal to secret, right? It will automatically use encryption decryption techniques. And by default, Kubernetes comes with 64-bit encryption decryption automatically, right? So I have encrypted it and then I put it. Kubernetes will automatically decrypt these values and get the actual values, right? Just by reading these key and decrypt it, it will extract what is the actual username. It will take this key and decrypt it, and it will extract the actual information, what is the password, right? So Kubernetes will do that thing, right? How we do that, we will focus it also here, right? So let's begin with the plain text, how we set the environment variables and all that thing. And it's very simple. But if you have noticed it here, right, normally we say API version, kind, metadata, and spec section are the 4 core values of YAML. Right? Anything when we capture the information in YAML template, we use these 4 core parameters, right? 4 core properties: API version, kind, metadata, and spec. But if you see here, there is no spec section. So this is the only Kubernetes resource which doesn't have the spec section at all. Instead, we have data. Why? Because this is my data. It brings data, right? Foo, bar, hello, world, or I can use something, some application URL, let's say dev URL and some URL, HTTPS and some path, right? My IBM, mydev.ibm.com or mytest.ibm.com or my preprod.ibm.com or prod.ibm.com, right? Various environment URLs will be different. So I can bring that, or path, I can set the path. We will bring those use cases, but I'm using very simple things so that we can understand how we can expose the environment variables. All right, so there are two types. One is plain text, one is encryption, right? Where username, password, or any token to connect the front end application to back end, right? All that we are my confidential information, and I cannot expose to the plain text, because otherwise anybody can log in my application or steal my token to get the access to backend from front end, right? So we want to hide those things, and those are sensitive information, and we keep all that as a secret. What is Kubernetes secret database? Which is etcd database. That means in Kubernetes inbuilt database, I can store my credentials. So you will not find anywhere. It is hidden in database because nobody have access to database, etcd database, right? So for encryption decryption, we can use Kubernetes etcd database also, right, by default. So when I say secret, right, that means I want to put this information into Kubernetes database where nobody can have access, and it's in junk characters for people because it's already encrypted. Kubernetes will automatically do decryption. How it will do that, I'll show you. All right. So again, very simple thing, but let's understand it. So we have to create config management, right? Configuration management. In short, we say config map, right? Configuration management is the full name, but we say config map. Map means we are mapping the configuration by using variables and key value parameter, right? So this is my key and the value, key and value. So we are mapping the configuration by key value parameter. So it's very simple, right? We don't do any coding here, just the key value parameter. All right. So I'm here, and if you see what I'll do, we'll take some use cases, right? So this is my use case number 1. All right, we will read the values directly into the pod, right? So for that, we have to create the config map first, right? Remember. So let me go and create config map first. So this is my config map, right? Let me go and create it. So example 1, we'll take few examples, right? So let me begin with example 1 dot config hyphen dot config map dot YAML. Okay, so this is my API version is V1. V1 is the stable version of Kubernetes resource config map. Kind is config map. Metadata name. So this is the name I can use. Example 1 config map, and no spec section data, because these are all my data. So I can use 1 variable or 2 variable or 3 variable or 4 variable or 5 variable. Anything is fine, right? So I can use multiple variables also, and then again you can use path and all that thing. So JDK 9.0 is my Java version application, and this package is Jellyfish package. Foo is Coco. I want to just test this variable by simple thing that I can display. I can store the value inside foo. The value is Coco. So wherever I call variable foo, it will pass the value Coco because it is stored inside this variable. Hello is stored with Jellyfish. Java is stored with JDK 9.0. Environment is development and purpose is internal, right? Anything, right? These are simple variables. So there are, if you see how many variables, many variables, right? Or if you are confused, right, let's begin with 2 only. So let's begin with 2 only, right? Later we will bring more. All right, so let me go and have these 2 variables. Very simple key value variables, right? So whenever your YAML file is ready, right, just first open the file so that we know what we are doing. This is my thing, and then apply this file in Kubernetes, right? So let me go and apply. So kubectl apply -f. So I've created, right? So kind is equal to config map. What is the thumb rule, right? Kubernetes command we need not to remember, right? So it's very easy. Thumb rule is whatever is there in kind, I can use kubectl get command and describe command by using this keyword. So kubectl get, what is the keyword? Config map, right? So very simple. Kubectl get config map, right? So this is my config map which I've just created by the name example1. This is my config map. How many variables are there? There are 2, 1 and 2. So you will see data. Under data there are 2 variables, foo and hello. So you will see 2. When did I create it? 22 seconds ago. Right? There's one more which Kubernetes default it uses as a config map. So internally Kubernetes uses, right, for certificate and all that thing. It uses because certificate it doesn't want to expose, so it has used this technique. So is one certificate by Kubernetes root CS cert, right, which is fine. Kubernetes uses internally, right? If I want to describe it and see, so we can use a describe command. So kubectl describe, right? What I want to describe, config map. What is the name of config map? Let's say my config map is example1 config map. So when I display, right, so you see name is same, example1 config map. Namespace is default since beginning we are using. Labels I have not used. Annotation will talk, right? If I get time today, we'll talk. It's a very small thing. I'll tell you about this annotation, right? But just remind me, not today, then tomorrow we'll do it, right? It's a small thing. Now you see data, right? So data, right? And so data is underlined, right? So this is the data and it's underlined. So data, how many data? Foo, right? Foo colon. So this is my key, and below that dash dash dash, below that is the pair. So it is stored like a pair. So foo is equal to value, right? So after colon, the dash dash dash, and you see this value. Same way, hello is my key, and the value is jellyfish, right? So this is how we do. And events, we have not used it, so it has not generated any events, right? So it is straightforward. Values it has created, and in Kubernetes it is created in type as config map, right? And that is why I'm using, right, kubectl get config map, right? So this is the config map, and we can display it here. So when you describe, same way, if you want to describe the other thing, Kubernetes thing also, we can describe. So let me go and describe config map. This config map, this config map, Kubernetes config map, which is kube root csert. If you see here, right, so this is the name, namespace default, and this is the data. Under data, the name of this config map is csert, and this is my certificate. It stores here, right? Kubernetes is a very versatile application. It stores in a proper way, right? The architecture is really amazing architecture, simplistic architecture. They have simplified in a beautiful way. All right. So if you see here, this stores my certificate. Like if I have my token and all that thing, right, I can encrypt it and bring it here, right? So all that we can do. So anyhow, we will be learning that practice also, right? So it's very simple, and I'll be using it repetitive ways because I have to capture so many other use cases. From simple for understanding, once we build the fundamentals, then I will use some advanced techniques also, right? But it's a very, very simple thing. Same way I will be using, right? So I have created the config map. So you have to create the config. So we have just created, right? Now who's the consumer? Who's going to use it? Who's going to consume it? Right? Our pod, right? So let's bring the pod. I'll send you this file. Don't worry about it, right? I'll send you all the files and everything. So let me go and use this thing. So let me create it. So VI and what I want to create, example one pod, right? So I want to create example one pod. So what I'm going to create, pod, right? Name of my pod is example one, right? Nginx container name is Nginx, and image is also Nginx. So it will take Nginx latest image, right? Or if you want to put some version, you can put some version also. So colon, let's say 1.20, anything, right? So you can do like that. Now, if you see here, up to here, we are already aware of this pod YAML file, right? API version kind metadata spec, right? And this is my simple pod YAML file. What we do under the container section, because we expose this variable for whom? For containers, right? For my application, which is running in a container format. Our application runs in Kubernetes always in containers, and Kubernetes is what? Container management tool, right? It will manage the containers, right? So under the container sections, you have to use one variable called env. Env is the short form, right? If you extract it as a full form, env means environment variable, right? Env, right? Environment variable. Now if you see, we are using two environment variable in config map already, right? So let me see, where's my config map? This is the config map we created by the name example config map, and there are two variables. One is foo and another is hello. How this pod will read, right? Under the environment variable, and I can use array. Array means I can have multiple variable. One is hello, one is foo, like that, and bring multiple variables as an array, right? Array means these values I can repeat and replace by multiple things, right? Array 0, arrow 1, arrow 2, arrow 3, arrow 4, right? Like that we can do. So here I'm using this array. So the name of variable, so foo is my environment variable, env var. This is the name I want to give so that I can remember. Oh, env var means environment variable. What is the name of this environment variable? Foo, right? And in Kubernetes, it is a good practice to use your environment variables in capital letters, right? It's basically coding standard. Whenever we use environment variable, it should be highlighted in capital letters, right? So it is a coding standard. So I'm also using this. If you keep it in lowercase, doesn't matter, right? For Kubernetes, whatever you give as a name, it will accept it, right? But as a good practice, it should be capital letters. So that is what I'm using it here. And then this value, what I'm saying, get the value from, right? This is again Kubernetes property, YAML property, right? For this variable name, foo environment variable, get the value from where? config map, right? Config map which we have already created. What I'm saying, get the value from config map and take your respective key references from there, right? From where? From config map. And that is what I'm saying, that go and get the value from config map which I've already created. That means before pod, your config map should be created. You should maintain that order. Right? Don't create first pod and then pod is looking for config map and there's nowhere config map is created. Don't do that. First create the config map and then come to the pod. So I'm saying this pod is the name of variable and take the value from config map which I've created, and your respective key reference you take it from there. So which config map? You have to give the name of config map, right? What config map we have created? Isn't it we created this config map, right? Example 1 config map. You see, this is the name of my config map. Example 1 config map, we created this config map. All right. So I'm saying you take the value from config map, right? Which config map? This is the config map. Basically, it's a file, right? So config map example 1 hyphen config map is the file in which you go and take your key. Which key? Foo key, right? So you have to just give the key. Don't put values here. It will automatically take value. So here is my key. The key is foo. So I'm reading this parameter, right? Using this name, take the value from config map key reference I am saying. So you have to give two. One is config map name and then another is the key, the reference of the key. So the name of config map is here and key is also here. All right. So name and key, I'm passing it here. All right. So I'm giving all the data which are required for this environment variable foo env var. Right. Same way I have to repeat it now, right? Because I'm using array. So now the name is what? Hello. Right? Hello env var. So hello env var is the name. Hello env var. Why hello? So that I can use pick up the second environment variable. Right? Hello. So I'm saying the full name is hello env var so that I can know this is environment variable. Right? Which variable I'm using? Hello environment variable. Right? So, and as a good practice, as a coding standard practice, the environment variable should be in capital letters. So I'm putting in capital letters here. And again, same thing I'm saying that, okay, for you, go and get the value from config map, right? And key. So here is the name of the config map, same file, example one. Go to example one hyphen config map and you will get the key. Which is the key? This time pick up the hello key. So here I am saying key is equal to foo and key is equal to hello, and these values are same, right? All these are same. Value from key, right? All these are same, right? So what we are changing? Only the key here and the variable name. So like that I can read all the variables, right? If I want to read Java, then I will use the same parameter here and I'll say Java env var value from config map key reference. This is the thing, and which key I have to give that key, right? Which key? This key Java. Same way fourth key is environment. Same way purpose. All right. So we are using array, and I'm reading one by one. Which variable I want to read? Let's say in my file, right? I have many variables, but for this particular application, I want to use only this variable and this only. So I can keep one config map file for all my application. I don't want to create multiple config map, right? You can create multiple config map also for each application, separate config map, or you can maintain one config map and put all the variable inside that, right? And in pod, whichever you want to route, you can pick and choose, right? Only these two, or maybe in the next application, I may need these three, right? So I can pick this 1, 2, 3. Right? Or if I want to use 1, 2, 3, 4 for my another application, I can use it. Or if I want to use 1, 2, 3, 4, 5, I can do that. Right? So we can do bring one after another like this, like this, like this. You want two, you want one, use this. You want 1 and 2, right? Then 1 and 2. Or if you want to use 1 and 2, then copy paste and have the third variable also, 4 variable, 5, 6, like that, like that, like that. We have a choice because I can give whatever key I will do, it will take only that. Foo and hello are the only keys which I'm picking it here. So foo and hello. All right, not a big deal, right? So if you see here, env and then bring the name of variable, value from this structure is fixed, and replace your key. Key 1, key 2, like that, we can do it, right? So let's go and use this config map which is already I have created in example 1 config map, and let's use in this pod, right? So I'm exposing it to this pod, right? So this is the technique we use, and YAML is the only thing in Kubernetes which we have to manage all the things, right? So let me go and create it. So this is my pod. Let's go and apply it. kubectl example1 pod.yaml. Right, my pod is created. What is the name of my pod? Example1 pod. Where from it is coming? From here. This is the name of my pod. I've created pod. Name of pod is example1 pod. All right. So simple example, kubectl get pods. Where it got created? Let's see by this command. Kubectl get pods -o and this pod example1 pod is up and running, and this is the IP address of the pod where it is running because it's one, right? So it will not be split on two worker node only. So which worker node? This worker node 9168 worker node. This pod is running. All right. So to go environment variable are used by this pod or not, right? This example1 pod or not. So what we use execute command, right? To go inside the pod, right? Because I have not installed the application, right? The application is running, right? If I say ls, I will not see any pod is running. Only my YAML files I will see, right? So where this pod is running, we have to use kubectl command. Kubectl. If you know the Docker command, exec command we use in Docker, right? So exec command to go inside the pod, and always use interactive terminal session (IT). Right? Interactive terminal session means I'm creating my own terminal session with this pod, right? With this pod. What is the name of this? What is the name of my pod? Example one pod, right? This pod. So name is this. So interactive terminal session with this pod, and when you go inside, always use a shell. So Kubernetes Linux come with a bash shell and sh shell, right? So sometimes old legacy application we can use sh shell or use bash shell. Bash shell is slightly advanced. All application will work on bash, but old legacy application in Linux they work on sh. Why we want to use this shell? So that I can fire some command using this command line shell. Bash is the command line shell of Linux. I can fire the command when I go inside the pod and take all the information through the command line, isn't it? So Kubernetes, right? So Kubernetes Linux platform where this is hosted, which is in our case, which Linux Ubuntu, right? So we will fire the commands, and it's a Linux thing. So if you see, I am inside the pod, right? If you see here, I was on master node IP. This is master node 172.31.86.103.1.1031. But now I went inside by using this command, and you see where I am. I am inside example1 pod, right? I'm already in this pod, right? Inside this pod. Now if I do ls, I will see the complete structure of this pod, right? The folder structure. This pod is basically nginx pod. So you can see the folder structure, right? So there are so many folders, bin folder, dev folder, right? If you don't want to display like this, so there's one more command, right? ls-l, you can see all these folders, right? So bin folder, root folder, dev folder, docker encryption.da, encryption entry point.sh, that etc, home, lib64, media, mnt, opt, proc, root, all these are here. All right. So we can just see everything. We have to be inside the pod, right? So I will not touch the folder structure and all that. We don't need to do anything. I'm still inside this pod. All right. What I will do to display the variable, this pod is created, it's up and running. To display the variable, right? There is one Linux command, env command, right? If you fire the env, basically it's a Linux command. To display the environment variable, you say env, it will list you all the environment variables. So it will display the list of all the environment variables which this pod is using or this application is using, right? If you say env, it will display, right? And as I said, environment variables should be always in capital letters. So you see all the environment variables are in capital and the values are assigned with is equal to sign. So Kubernetes service port, which is using 443, right? Kubernetes service port, right? So which uses HTTPS, which is 443, right? So HTTPS and this both variables 443. Host name, right? So host name, what is the name we have given to this pod, right? Example1 pod, right? So host name, because pod itself is a virtualized environment, right? So this pod has given the virtual name as the pod itself as a example1 pod, right? And if you see, where is my environment variable foo? So you see we created variable foo env var and something hello env var, right? These are my variables, right? What is the value? If you guys remember, what is the value we stored for foo, right? If I come here, foo is having value coco. So can you see this variable has set the value for this variable as value coco, and for hello world, right? Hello env var, what is the value? Jellyfish, right? This is the jellyfish. So if you see here, this is the value it has taken. So that means this pod, right? This pod, example one pod, all these variables are being used by this pod, and I have also added my variable. One is here and one is here. All right. So same way, you can set the path variable. You can set application version, right? What is the application version? You remember Nginx 1.20, I set it, right? So this is my Nginx, and the version of Nginx is 1.20.2, right? So we set 2, and it will take the latest, which is .2, right? So we can set. You can also set it, right? You can also set it. So whatever variables you want to set, you can set it. Host name, path, port number, right? Anything you can set. So let me take another example, and we will now since we already understood how to set the environment variable, we can do to come out of this pod. Always use exit command, right? When you say exit, you will be back to your console. You are no more inside the pod. Here you were inside the pod. Root is equal to example 1, but now I exited and I have come back to my node. Which is the node? Master node. Can you see the IP address? 172.31.86.103, right? We are here. Alright, so we are here. Now if I fire any command, kubectl get pods, anything you could see it here. Alright, so I'll take another example. BI example config map. So I'm taking another example. Right? BI example 2 hyphen config map dot 2. Alright, let's go and create one more config map, and this time I'll take a slightly interesting use case, right? So this pod I've created, I will send you all these files, right? Don't worry, as is you are gonna get this file, right? For verification, describe the pod. You can use describe command also. If you don't want to use kubectl exec command, describe pod and go inside and check and type env, right? So if you go inside by exec command, right, or you can use describe command also. Let's go, and before I come here, or let me copy paste this file and then we will describe. So I'm creating another config map, and this time slightly better example. Alright, so let's do that. Alright, so let's do that. So I will use this. So let me do this. So cat. So I've created example 2 config map. This time I'm using, right, slightly different example. So this is my variable name. I'm using directly capital letter. Last time I used lowercase, if you have noticed, right? Who and all these were in lowercase, right? So if you see here, all lowercase value. Hello, world, Java, environment, purpose, all are lowercase. Now I'm using these capital letters. Right? So capital letters, IBM JDK path, IBM application version, client path, and client base URL. So I'm taking all type of examples. So I'm using path. This is my path, var lib JDK. Application version, right, 3.2.0. Client ID is my MAC ID. So I can use this ID. And base URL, right? For this environment, what is the URL, right? So the URL HTTPS myapp.dev. This is my dev environment, development environment, dev environment, ibm.com. If it's a testing environment, I would say myapp test dot or tst.ibm.com. If it's a pre-prod, I would say myapp.preprod.ibm.com. If it's a prod, then I can say myapp.prod.ibm.com. So I'm using variables, right? And this time, as a good practice, all variables are in capital letters, right? So this is another example, and I'm going to use multiple variables like this, right? Or if I want to use all of them, I can use all of them also in one go. So this is created, right? So it is not yet applied. Let me go and apply it. I've created it. kubectl get config map. What is the name of config map? Example to config map. So this is my config map. How many data this time we have pulled in? 4, right? This is one environment variable, second environment variable, third environment variable, fourth environment. So under the data, how many are there? Total 4. You will see the number here. So data is having 4 environment variables, right? Can I describe it? Why not? So instead of get, I would say describe. 1, 2, 3, and describe. Alright, so I'm using example 2 config map data, right? So application version, right? This is my application version 3.2. It's arranged in alphabetical. So first A will come, then B will come, then C will come, and then other J and other variables will come. So it is already arranged in chronological order. Okay. IBM, I'm using a reference of IBM because let's say we are working for customers. So all the variables are suffixed with IBM, IBM, IBM. So I can know this variable I'm setting for IBM customer. If some other customer, right, I can create. So all these are naming standard practice. All right. So you can replace some by application name or your team name or your product name, right? Or maybe customer name, anything is feasible, you can do it. So app version, this is the value I'm using. Base URL, this is my URL which I'm using, right? URL is https myappdev.ibm.com. Client ID is my Mac ID something, and path, this is my path, right? So we can use all these things like this, one after another. All right, makes sense. All right, now who will use? Let's bring the pod, right? So this time it would be slightly interesting. Right, so this config map I've created. Let me bring the pod, and this is my pod, and you will start loving it, right? Because I'm using slightly interesting thing here. So let me create example 2 pod.yaml, right? And copy paste this pod. So pod example 2 pod Nginx image. This up to here we are fine. Last time I used env, this time I'm use env from. So when to use env, when to use from? Whenever you want to use the entire config map, right? Full. I don't want to, right, drop any values. I don't want to use this or this. I have no pick and choose. I want to use all. What is there in this config map, right? I want to use all. So to use all, that means I want to read the entire file, right? Entire file, right? And just set the variables, whatever there in the file, I want to use all of them and set the variables. So if that is the thing, then I use env from. Env from means file, right? Env from file. Where is the file? You can mention, right? Config map reference. So you can say config map and reference, not the key reference, but reference, full reference you take from the config map. And where is my name of config map? This is the name. So env from means from the file, and take all configuration mapping, right? References from the file. Which file? This is the file, right? So when you want to read the file, you just give and give one file. If you want to give multiple files, right, use this property, right? Same copy paste and replace with another file. Example 1 config map, example 3 config map. So you can set even from multiple files also, right? I'll show you that also, right? So this time I want to set the entire file. So you say env from. If you want to do pick and choose the way we did last time, foo, hello world, right? Only 2 out of 5, right? Then use env and bring one after another, one after another, one after another. But this time I want to read entire file. So, right, the YAML file will be less because I'm reading the entire file, not one after another entire file. So let's go and do it, right? And in Nginx, let it be latest. So I've saved it, right? And let me open this file. This is the variable, right? So pod I'm creating with the name and env from, and this is the config map which is already created. We have seen it, it is already created, right? And then let's go and create it. So I'll apply this file and create this pod. So kubectl apply -f. This pod is created. What is the name of pod? Example 2 pod, right? So let me clear the screen and list my pod. kubectl get pods -o wide. So example 1 we created last time, which is running from last 14 minutes and ago, right? And then I created this pod, example 2 pod, from 11 seconds. Just now we created, and it is doing load balancing. One is running on this node, another is on another one. So this pod got created here on this node, right? So I can just use kubectl, right? Kubectl exec command, and as I said, always create interactive terminal session IT, and which pod you want to create session? Example 2, not 1, right? And always, as a good practice, use shell. So I am inside the pod. You see the IP address has gone and I'm inside the pod, right? And if you see the folder structure, you can see it, right? Since it's Nginx, so you will see more or less same, right? I want to display the variable. So What is the Linux command? env command only. So let's use env command and see. So this time all variables, there are 4 variables begins with IBM. So IBM base URL, you see the URL https myapp.dev.ibm.com is set. IBM application version, what is the version? 3.2.0. IBM JDK path, varlib JDK, and IBM client ID. So you see all the 4 variables begins with IBM, 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 which were coming from here. IBM JDK path, you can see it here. IBM JDK path, IBM JDK path is here. You see this path, right? So varlib JDK is the value you can see here. IBM app version and the value is 3.2.0. IBM app version is here and the value is 3.2.0. And then IBM client ID, this is my MAC ID, right? So this is my MAC ID, IBM client ID, this is my IBM client ID as a MAC ID, right? And then one more base URL, right, which is here. So base URL, IBM base URL is also here, right? So entire file has, right, it has read the entire file, and whatever there in my file, all the variable has been pulled down and it is set for this pod. Which pod? Example2 pod, right? So we can read the entire file, and it's very easy. When you want to read the entire file, you have to just say env, right, from. So this value. If you want to read from multiple file, right, bring the same concept, like whatever you are using as an array, same array you can use, right, same property, and replace the value. So instead of example1, you can say example2. So let me go and add this guy also. So far so good, guys. So I want to come out of this pod, use exit command, and then you are back to here. Right, so let's say I want to use kubectl get pods -o white. What is my pod? Example2. Let me delete it. Kubectl delete pod. Pod name is example2. Name is example2 pod. Yes, I'm deleting it so that I can modify YAML file and I will reapply it. Right. So why I want to modify? Because now I want to set through 2 variables, example2 pod, right, and I will add one more. So config map, another config map, and the previous one also. Previous one is pick and choose, but whatever is there, I want to use the entire file, right, entire file, right. So let's go and use it, right. If you want to see your config map, kubectl get config map. So these two, right? These guys having 2 variables, foo and hello world, right? Foo and hello, right? Right? And this guy entire file. So both the file I want to read as an entire file, right? That is what we have done in this example2 pod. All right. So we are reading both example1 config map and thing, and I'm saying env from. So whatever is there in the file, it will read everything. So let me apply this pod. So kubectl apply -f example2. So this is applied. Let's go and see kubectl get pod. So this pod is just now created, right? Example2 pod is created. Let me go in kubectl exec command to go in. Always create interactive terminal session for this pod, for example2 pod, and use bash shell so that we can fire the commands. Now inside, because I'm already on the shell, so I can fire the command. I can say ls, right? Whatever you want to do, you can do. You want to go to any folder, right? You can go to any folder. So let's say I want to go to any folder. For example, very share, right? Let's say user or var. Right, I'm var folder, and you can see what are there inside the var, right? So like that we can do cd and everything because we already have a shell. All right, so I'm inside this pod, right? How do you know? By taking the ref. I'm inside this pod. How to display the variable env? Now if you see here, right, for my IBM variables plus that foo and hello, right? So base URL, base, these two are there, Hello is here. Hello, what is the value of hello? Right, jellyfish. Right, and foo, what is the value of foo? Cocoa. So both the variables we are reading from the previous file also. The right first, right? So foo is equal to cocoa and hello is jellyfish. So both the variables I am reading. Foo is cocoa and hello is equal to jellyfish. Not world, it is jellyfish. Right? Yes, hello is equal to jellyfish. And the IBM 4 variables. So these are the two here and two on top. So 2 plus 2 is 4. So both the files we can read it, right? And since it's a plain text, so everything is visible because there's nothing to hide. I'm okay with plain text for this kind of example because I'm not using username, password, or token, or my database connection string, right? Or my front and back end connection string. We are not using just simple thing, variable name, application version. If somebody wants to open my file and read it, right, it is not harmful, right? Because he cannot harm me. But if it is username password, then he can take credential and use it, and he can do the damage, right? So we are using very simple technique. All right, guys, are you with me? Right? So
Yes, yes, sir. Sir, just use a fire a command ls space hyphen l.
ls-l here.
Right. So the file you saved in the current working directory. That's why you
Yes,
just mentioned that name
because I'm
hyphen and
creating.
that.
Yeah, I'm using all file directly here. So all will be in default path. So what is the
Okay,
default path? In Linux we use pwd. So all are in root. I'm in root
right.
folder. So it will display directly from the path because I'm creating all the files here only.
Got it, sir.
Right, if you want to create some directory, make dir and your name, or right, or some application name, right, then it will be cd to the path and all file will be in that folder. I'm not doing, I'm straight away I'm creating it. Okay.
We can just mention hyphen slash absolute path
Yeah.
inside of the YAML file.
Yes, you can do all that thing, no problem.
Okay.
All right.
Yeah.
All right, so now only this part we have understood. All right, this part, let's go here. It's very simple, right? I will finish it very fast, but it's going to be very interesting. So my YAML file, we will do it from here. So let's go here. uh, all right, so what I will do, I'll create some secret here. So let me copy this guy, and this time I will use encryption decryption techniques. So, and now you will start loving this tool Kubernetes, right? Because by default it comes with 64-bit encryption decryption by default. So let me go and create first secret. Secret is nothing but config map, right? So secret.yaml, right? And then, so what I'm creating, secret and username, right? So I want to use, for my this secret, I want to use username and password, right? Password, right? Now, what username and password? So Kubernetes is using default encryption decryption. So what I can do here, where is, all right, so in Google, if you say base 64 encoding and decoding, right? So let's use encoding and decoding base 64. Kubernetes uses already, right? I'm using because I know it, right? For outside people who are not Kubernetes, they don't know, right? So I'm just making your life very simple. So let me use here. So let's say my user is admin, right? I don't want to put it here, admin and password test123 or test at the rate 123. I don't do it because anybody can open this file. This is a YAML file and they can steal my credentials. So what I will do, right? I will just go and this username. So I will do the encryption. I will do encoding and it will give me, it will do the encryption. Encoding means encryption, decryption means decoding means decryption. Encoding means encryption, decoding means decryption. So we are using this tool, right? Encoding and decoding tool, I'll tell you, right? So instead of actual value, I will copy this value which this guy has already encrypted for me, right? Junk characters. Same way password, let's say I want to keep some password, right? So I would say, let's say test at the rate 123 is my password. Okay, why it is coming like this? It is changed to what? Left to right. Why it is coming like this? EEST at the rate 123. Sorry guys. So my keyboard is slightly left to right and right to left mode, both the mode I'm using. So test 1, 2, 3, and I can again encryption, decryption, encode it. I would want to use encryption, so this is my encryption key, right? So we cannot do it by hand, right? So we use tools, right? So by default 64-bit, right? So it will do this thing. So now I'm safe, right? So if anybody open my file, right, he cannot get my credentials, right? So username, he'll say, oh, what this guy? And if you copy paste this user, there is no user by this name, this character, because I'm using different technique, right? So this is different username and password, so they cannot steal it. And how to do it? By using secret. Okay? If you use config map, then it's a plain text, right? So what I mean to say, if I put kindly config map, then it's a plain text. But if I say secret, you can use encryption decryption like this, right? But here, API version kind metadata and same data, but before that we use type equal to opaque, right? What do you mean by opaque, guys? These opaque words we have read in our science in our school days, right? Metals are not opaque. So opaque means something which is not visible, right? Something which is not visible, right? So I cannot see it, right? So that is what we say secret. Secret means it's hidden, right? So whenever this is not visible, opaque means something which is not visible, right? So if you say that Prashant, go and get my car keys from the room, right? And what you have done, you have switch off the lights. I cannot see it, right? So if you ask me to go and get your car keys, right, I may hit the table or bed or chair, right? I never reach out to your drawer, and which drawer where you have kept the keys, I will never get it because it's not visible, it's not transparent, I cannot see it, right? Opaque means it is completely dark room, you cannot see where the things are, right? So it is hidden, right? So just like that. So here it will be hidden, username and password. The moment you create the secret, what it does, whatever name you give here, my secret, it will be stored inside by this thing. So it will be basically, it will embed, it will store inside the database by that name only. So what I mean to say, I'll show you here. So when I say apply kubectl apply -f secret, what is the name? My secret. So everything will be embedded inside. That means when Kubernetes create the secret by this name, both these files, username and password, it create two files, and their files are inside the Kubernetes etcd database, right? So now if you see kubectl get, what is the kind is secret, so I can use get command by that secret. So keeps get secret. So what is the name of my secret? My secret. So this is the my secret, which, and we use opaque. Opaque means not visible, and there are how many data? Two. Username is one and password, right? Two variables, one is username, another is password, right? But can you see it? You are smart, right? So you say, okay, I will do it, right, by describe command, because describe command tell you everything. So if I describe this guy, the secret, right? Let me describe, not get. Right? This is Kubernetes inbuilt, right? So we'll talk this about this also, but let's focus on our part first. So if I describe this guy, right? So you see type is opaque data. So it says username and password. Can you see what is your username? Can you see what is your password? No, because it has created a file inside a etc database, and these are just the size of the file, right? So my username was admin, ADMIN, 5 letters, so 5 bytes. Right, password we use something test at the rate 123, so there are 8 characters. So only file size is very small because only very less characters we have put, right? 5 characters and few password, 8 characters. So it has stored, you will never see here what is username and password. So what this guy does, all these things are embedded inside this name. So wherever I use this name, it will pull the username password from the etc database directly. That means I am safe. If somebody wants to read my file, he will get only chunk characters. If you want to describe using Kubernetes command, describe command, it will not display because it is hidden. It is secret. Right? Secretly, I have passed username and password into Kubernetes database. Right? That is why we say secret. Right? And secret means Kubernetes secret database. So these files, username, password, where I have to store username in username file, password in password file, these two files are loaded in Kubernetes. And Kubernetes will do encryption decrypt from that database directly, right? Because when you say secret, it is Kubernetes database by default. When you say kind is equal to secret, right? API version kind is equal to secret metadata, and these two, it is, when you say secret, it is Kubernetes database. So it means these two files are stored in database, nobody can get it. right? If you do ls here, you will not see these files. Can you see any username password file here? Example1 config map, example1 pod, example2 config map, example2 pod, and this secret.yaml, right? So, and if I open the secret.yaml, you will not see anything, right? These are junk characters, right? So Kubernetes is very smart. It has put directly into the database. And how will you know? Only by reference name, right? So let's use this file, right? Let's use it and then we'll come back. So I'll create one pod. So pod secret, right? Something like this. That's just the name, right? Let me create it. And how to use, I'll show you. So I'm creating pod. Name of my pod is my pod. Container, I'm using Redis database. You can use anything. So we'll test the Redis database also here. Mount path, right? So basically what I'm doing, I am setting the path. I'm setting some storage. Mount means storage path. What is the name of my mount, right? Who will remember this path? This path is short. etc foo is very short. Sometimes very long path, right? etc inside that sub, right? Main folder, nginx, inside that the share folder, inside that the display folder, inside that the html, inside that www, inside that some html index.html file, which is my default page loaded from that default path, right? So who will remember the path? It is always good to assign the name. So this path, right? When I say foo means it will be this path. So etc foo. So mount path. So what we do, this this pod we want to attach the some storage, right? So this is my storage location. I want to attach it, and whatever files are there inside this path, nobody can modify. So I can set the permission as a read only. People can read it, right? Only they cannot modify. They can just take the read it. They can take the reference of this file for their testing purpose as a read only, not to modify it, right? So I can set some permission, and and these are nothing but volume. Volumes are storage, right? From where it will read the storage path is etc foo. So this pod will store the data or read the data from this path, right? And this is the name. Now what I'm doing, I'm using username and password, right? So I'm setting some credential on this folder that if you have a username and password, then only you will be access to this folder, because this is my data folder. I don't want to just put it just like that. My data, whoever wants to access, they should have a credential, username and password. But username and password, I cannot do. What I did, I create a secret for username and password, because that's sensitive information. I cannot display all the time, this is my username, hey, this is my password, take it, take it, take it. I cannot do that. So secret, and this is the name of secret, my secrets. So this guy, the volume with foo, which is here for this part, is having a credentials, right? What is the credential? My secret. My secret already knows, right? There are two data variables which I have stored, username and password, right? So we'll use it. So it's going to be interesting. So let's quickly use this guy, cat, right? And let's apply this file, kubectl apply -f secret. So my pod created. What is the name of my pod? You can see my pod. All right, my pod is created. kubectl get pods -o, right? My pod is also created, right, on this node, which is fine. So let's go to this pod, right? So we can use kubectl get, right? Sorry, I want to go inside. So exec, always create terminal, interactive terminal session for which pod? My pod. All right, and use bash shell, right? So I'm inside my pod, all right? And Redis has default folder data. I don't want to go into data. What is my folder path? etc foo. So let me do cd etc, and I'm in the etc folder. You can see it here, etc folder, not yet foo. But let me do ls. Can you see foo folder here? So it's a, then b, c, d, e, foo. Okay, foo folder is already here. So let me do one more time, foo. So I'm inside etc foo. All right, we are inside the path etc foo. Here, if you do, you see those files are here, username and password, because I have used the secret, so I have the access, right? So my username and password is available now, right? If you see, username and password appears to be junk characters, isn't it? For outside, it was just a junk characters, right? We use junk characters here, right? So this is my junk. Username is something, junk character, password is junk character. But if I say here, right? If I do it here, right? Let me remove everything. So it has two things. Now if I open the username, right, what was the username? Admin, isn't it? So it has done the decryption, right? What was the password? If I say password, what is the password? test@123. So it has done the decryption. It will get the actual value has been passed. Admin and password is test@123, isn't it? This is what we created, test123, right? So we encrypted it, but Kubernetes decrypted it. So do the decryption directly from the etc database and get the actual value. So if you see, actual value is admin and the password is right test@123. All right. So now we are safe. Nobody can steal my credentials. Right? I'm using same technique, environment variables, through that I'm passing username, password, but through encryption decryption, not as a plain text. All right. So let me come out of this, right? And then kubectl, delete this pod, my pod, which I've created. Let me delete it. And then what I will do, right? And then where's my secret? Vi secret, which I've created. So we have username and password here, right? If you want to change values, you can change values also, no problem, right? Or if you want to add something, right? What I want to add, right? For example, I want to add some path, my database in MongoDB and all that. Nowadays, we can access through the URL directly. All database, we can access it directly through the URL. So what I mean to say, let's say this is my database server name, right? This is the host path, right? The IP address through that we can access, and this is the port number this database is running, right? And this is the string. Normally to connect to database, we have to give username in the string itself. In this command itself, I can say username is admin123 and password is this jellyfish, right? And then you can give the port number also for this database. So it will directly do it, right? So we can pass like this also, right? So if I give like this, right? And if I just want to, but I don't want to put, if I put this URL in my YAML file here as a DB connect or DB connection string, right? This is my DB connect. I don't want to give the real username, password, URL, database, port number. I don't want to give that, right? So what I will do, I will use encoding again here, right? And it will give me a really big number, junk characters, right? That's fine. Copy and paste it here. All right. So nobody knows what this is URL, username, port number, password. Nobody knows, right? So it's all junk characters, right? And let me create the secret again, right? So cat secret, right? So this is the third parameter I've introduced, right? Let me apply. So kubectl, I'll take another 2 minutes. Kubectl apply -f and secret, right? So this secret is created. Kubectl, just quickly verify, get secret. Secret name is what? My secret. We'll take it from here. This secret is now having 3 data, right? Username, password, and DB connect. Username, password, and DB connect, right? Or if you want to describe, just to see whether describe can display these parameters, these values. So we will verify quickly here. So you see DB connect is stored in a some file. You will never see the URL or the port number or actual IP address of the server, never see, right? Now let's bring the pod, right? So kubectl apply -f, and what is that pod? Some pod secret something. All right, so I've created this pod again, right? And get pod.yaml. So here I'm using this secret. So this secret is now having three data variables, right? Now DB connect also. So let's go into this pod. So kubectl, is it created? Get pods hyphen what? Let's see if it is created. Yes, it is created. Up and running 22 seconds. So let's go into this pod and we will verify kubectl exec hyphen it interactive terminal session as a good practice. Name of the pod and always use bash shell. All right, and then go to the path. What is our path? etc foo. This is our path. So cd and etc foo. So we are inside etc foo. All right, my pod, right? We are inside my pod and this is the path. Now if you see here ls here, right? You see 3 files, or ll you do. LL is not allowed, ls-l, right? So these are the 3 paths. DB connect, data, insert data password, and all user is here, right? So we are here. Why showing like this? Okay. Data means Kubernetes secret data, right? So that is fine, right? So now if I open, because I'm already into this path, foo, right? Or I do ls here and open one by one. So username, what was the username? Admin only, right? So admin only, but it will display this thing. It is just to confuse the people. If any outsider people will see, he think that okay, this is my username, and he will get lost. Or you say root@mypod, right? So Kubernetes is a very clever application. So this is the username. So for others not to steal in a direct way, straight way, couldn't do like that. So this is my password which I set. And what about my DB connect? You see exactly it has decrypted. I gave a chunk of, right, chunk of junk characters, right, and it has exactly decrypted, right? So I have used this path, right, and now if I put it here, let me paste here, you will not see, or not here, here, right? You will not see even a dot difference. Exactly it has decrypted, right? So this connection string, we were using some junk characters, but it has exactly done the decryption, right? And I'm safe also, right? So I'm safe also, right? So we use base 64 by default, right? This is base 64 encryption decryption, right? Now you don't want to use base 64, right? For high encryption decryption, you can use any third-party tool, right? For banking application, they don't want to use open source 64-bit. Kubernetes by default it comes, right, which is fine. But banking application, they use 128-bit encryption decryption, or it's a high thing, right? So there are many, right? Blockchain tools are there where we use encryption decryption, right? So instead of 64, I can go for 128-bit encryption decryption, or maybe 256-bit encryption decryption, or maybe 512-bit encryption decryption, or maybe 1024 encryption decryption. 1024 is very, very, very rich encryption, right? Very, very high encryption it gives, right? So I can use any third-party tool which are compatible with Kubernetes engine also. What you have to do is you have to install that tool on Kubernetes cluster nodes, all the nodes. That's it. It will automatically get it from there. All right. So there are many third-party tools. So if you don't want to use, don't want to invest, by default, base 64 is already embedded inside Kubernetes. Right. This Kubernetes engine does with base 64 encryption decryption both. So I've used this open source, pass the value as a username and password and database connection. Kubernetes already did decryption for me, and I verified also. Right. Not even a dot difference it gives. Let me exit from here, and we are here. All right, guys. So this is the way we do, and we will going forward also. We'll start using these guys, right? Wherever it is needed. So plain text, whenever you want to use, there are two types. Plain text when you want to use directly. But when you want to use secret, right? So use right base 64 tool or whatever tool, and then bring those junk characters here. Decryption will be done automatically. All right. So I can always create config map and my pod YAML file and all those files, and I need not to do hard coding, right? Now, one thing which I missed it is describe command, right? If you are not comfortable with it, you can describe command. So kubectl describe pod, which pod? Let's say example one pod. When you describe it, and if you go to env environment variable, you will see here. So foo env var and hello env var, you will see. So it says set to the key foo. This is set to foo. This is set to ku. Of which of the config map? Which config map? Example one config map. Example two config map. Right? So it will tell you everything. And under the environment. Previously we were used to see none, but now since we have set it, you can see like this. Same thing you can do for example 2 also, right? Example 2, and if you go slightly up in the environment variable, you see example 2 config map, right? Entire file, and example 1 config map. All variables you are getting from here. Variables from, you can see, right? And here you cannot see it because you have applied as a full file, right? Not the direct variables, but the full file, right? So you can do, for that you can use exec command, right? kubectl exec command, right? So same way, if I use my pod, right? So right? And my pod. Now, if you just go and see where you have used, so we are using secret, right? And one variable no, but we are using secret. So if you see here, env-foo, and we are using secret, right? Or yeah, it's hidden, right? So this is how it will do all that thing like that, right? Or use the exec command which I'm using, right? Straightforward exec command. We can go inside and get all the details and do verification, right? In Docker, we use Docker exec. In Kubernetes, we use kubectl exec command, all right? And we can use. So this way, Kubernetes gives a lot of flexibility in terms when you have a sensitive information like username and password, you use this. Or for plain thing, you can use directly. All right. So whatever we did, I will send you everything along with the files. Okay. So what we will do today? We will talk about RBAC. RBAC is basically nothing but a role-based access control. All right. So in Kubernetes, if you want to control the day-to-day operations at a people's level, right? So let's say developer, I want to give access, not the full-fledged access, and we cannot share the root access with everyone. All right. Otherwise, it would be disaster. People can do whatever they want. They can delete node, they can delete my deployments, and they can remove so many things. So we have to control it. So how we can define based on their role. If it's a developer, what we want, he can deploy the pods, he can create secrets, config map, and whatever related to his application, he should be able to do. Right. Other things he should not be able to do, like adding the node, storage, all that thing. We will not provide him the access. All right. So that is what we are going to do, right, using RBAC access, right? So RBAC access, if you see the developer admin, right, admin, we have so many things: configuring storage, adding the nodes to the cluster, or generating some tokens, installations, backup, right? All that we can do as an admin, right? But we cannot provide the admin access or the root access to everyone, right? For example, developer, what developer needs, right, he should be able to create the pods. He should, once the pod is created, he should be able to view the pods, right, in terms of checking the log file. If anything went wrong, he can go ahead and he can check it, right? Or deploy any application through deployment. Or if he wants to delete, he has performed the testing and he wants to delete it, and then he modify the code and again he wants to deploy, he can come and he can do the testing by deploying the updated code or updated application, right? So that is what we want to do. So we can control based on the operation. These are all operation pod, right? Operation means Kubernetes resources, right? I can give access at a pod level. I can give him access at a deployment level. I can give him access at a config map level, secret level, right? He can create or he can delete or he can view, right? All these are the common permission which we can set. So we can give him. Now in the background, RBAC, basically there are so many APIs. Each API is linked to each resource, right? So whenever you control RBAC, basically API will enable or disable the access for him. How, that I'll show you, right? So this is how what we want to control the further day-to-day operation based on the people's role, people's access, right? How we want to provide the access. So that way everything will be controlled, everything will be streamlined. If you share the root access, right, it would be very difficult to track because everybody has the root access, right? The root access means their name will be hidden. Only root access means the admin user, that we want to do that we want to avoid that, right? So that is what we will talk about RBAC, right? So let's go and talk about RBAC. So if I talk about the APIs which are inbuilt, Kubernetes has many APIs. So kubectl API resources, if you type resources, right, you will see huge list of APIs. All right, so let me go on top. Kubernetes API resources. So if you see here, these are the name of Kubernetes resources, right? These are the name. This is the short form, right? No need to type full name, right? We can use shortcuts also. So you will see all the shortcuts over here. And then what is the version, right? V1 is stable, or is anybody using, right, some alpha beta also? You see V1 here, V1 here, everywhere it is V1. But somewhere you will see something else also, like here, beta, right? Beta 1, V1 beta, like that. Now, do we have alpha also? No. All right. So there are alpha beta also, right? So alpha beta means the feature is available as a beta level, not yet as a production level, right? It is released and they are still fixing few issues, right? But to some extent we can start using this feature, we can start exploring this feature, right? So all these are there, the API version, because every API they have a version. As I mentioned initially, API version is basically the production version release, right? And it is denoted by V1. All right, so that is what. And namespace, right? Namespace means is it control is it controlled by namespaces, right? We already know the namespaces, right? To onboard multiple teams on the same shared cluster, right? Creating the namespace. Can we use this at namespace level? So you will see true and false. True means yes, it is applicable at a namespace level. False means no, it is applicable across the cluster. You cannot have specific to namespace. All right, but if you want to control at a namespace level, just come here and check it, right? And then kind, we have two properties, right? API version, kind, metadata, and spec. So kind means whenever you want to use this resource, what would be the kind? So in Kubernetes, every resource is categorized on a kind, right? Pod level, right? If you see the pod level, we have a pod level here, right? Persistent volume here, we were talking yesterday, right? Persistent volume claim here, node level, right? Space level, right? All these things are here, right? Config map, all that thing. All these are Kubernetes resources. So each resource has its own type, right? Which we call kind of Kubernetes resources or objects. All right, so the list is really huge, right? If I go one by one, so what I will do, we can filter this list. So API, and I would say grep pod. So when I say pod, so what we are using pod level, we are using V1, right? If you see the API version, this is the API version and kind is pod, right? And we can use at a namespace level also. So I can enable at a namespace level also, that what the dev namespace, how they will have this pod created or deleted or remove or view the logs. I can enable, disable, right? All that we can do, right? If you see something here, this pod security policies, right? Policies will always be enforced at a cluster level. You cannot have a policies defined at a namespace level. So it is false, right? So we have precisely, it is automatically categorized. You need not to worry about it. Just come here, check the table, and that's it. All right, so what we did yesterday, right? So let me say persistent volume, right? Persistent, right? I just put here, you will see there are two things which we saw yesterday. One is persistent volume itself, which we call PV in shortcut, right? And this is V1. Persistent volume you cannot control at a, basically it's a shared, right? You cannot define each storage. They are very expensive. I cannot give one space as a dev namespace, another testing level, another pre-sales or prod, right? It has to be uniform, right? So we can have the resources here, and inside that I can enable disable folder, right? So MNT data, inside I can create one folder for dev, one for TST, one for pre-prod, one for prod. That level I can do, but not at a namespace because it is a shared. Otherwise, it will be very expensive, right? I have to purchase multiple storage for each namespace. Might be for development, testing, pre-prod, prod, right? Which we don't want to do it, right? Volume claims, yes, we can use at a namespace level, right? This PVC, right, I can use for dev separately, for testing, for pre-prod, prod, that we can do it, right? So we have many things like here, right? So same way, you can come here and check, right? Secret or config map, right? We have secrets, right? Which we already seen. Same thing like config map, right? Config maps is also here, right? And likewise, many things are there. You can check all the things which we did. Replica set, few things Kubernetes uses internally, right? So don't expect that everything is we will control it. Kubernetes also does many things like monitoring. It has its own controller, and controller is doing all this through these APIs, right? So Kubernetes is basically a microservice architecture, and it is controlled through these APIs. All right, so we have a huge list. Whatever we did, it is also covered here, and we can verify, right? I was verifying with secret, config map, pod, replica set, deployment, services, everything is defined over here. All right, so if you see deployment, what is my API version? Apps v1. For replica set, apps v1, right? For config map v1, 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 right? Which we already know, right? So it's v1. All right, so likewise, there are many things in Kubernetes, and everything is controlled through APIs, and that makes our life very, very easy. Right? Many times we feel that Kubernetes performs all the operation in the background as an automated thing, but actually it is handled through these APIs. Each API talks to another API and get the work done. All right, so that is basically we call microservice-based architecture. right? So today we will see how we can enable or disable the access at a pod level, right? Using the RBAC, I cannot give the full access as an admin. I want to give a developer access, maybe a tester access, maybe a support level access, right? So network support people, what level they can do, right? And all that thing we can enable, disable, right? And it's going to be very, very interesting. So let's jump onto it and then we'll explore it. Okay, so if you want to see, as I said, this is the official documentation. I always use official documentation, right? So this is the link which is for reference purpose. Let me put it here, right? You can read it here, right? Role-based access, RBAC means role-based access, and authorization we can enable, disable, right? So based on the Kubernetes objects, right? So all these API which I just talked about it, right? So here we can have two roles. One is the role at a particular resource level, another is cluster role. Who is the cluster role? Admin, right? Who can perform cluster level activities, which is admin, right? That is what I divided this slide into two, right? One is the role. Role may be as a developer level, tester level, or a support level, or a support engineer level, and another is at a cluster level, which we call admin, right, or a root user, right? So that is what we have two categories only here, right? And which we will do it, right? So I will explain about all this thing, how to enable, disable this role, right? So if I come here, I missed one thing, right? API resource grab RBAC, right? So let's say RBAC. So here we have roles, then we do role binding. Role binding is nothing but mapping. So we have roles and cluster role, and basically these two are mappings, right? This role, whom we want to map, whom we want to assign. So assignment we do through bindings. So once you create the role and then bind it to developer team or testing team or individual or a group of people, right? We can do the binding. Binding is nothing but assigning the role. First you have to create the role and then you have to assign this role. Right? Creation means what all things you want to control, that is creation of the role, and then assign this role to whom? To development team, testing team, or any individual, right? Project lead or anything you want to give, you can do that at a user level or at a group level. There are two things, right? So we can do these things, right? But if you see, API version is RBAC authorization, then Kubernetes.io is default, right? So this is what you have to use for this roles, right? So this is our API version. So we will use this thing here. So what I will do, I think I already created one file. So we will see it here. So admin basically who can add node, storage, deleting. So this permission not needed for everyone. Normally for a developer, if you see what we can see, he can view it, right? He can view it, but he should not be able to add or delete. He can just check and see whether how many nodes are there, storage there, not there, all that he can do, right? And then he can change he cannot change the config, but he can only view, right? So I want to control him, right? So I will give different role. So RBAC is essentially used for defining the role based on Kubernetes resources such as pod, deployment, service level. Each resource level I can define. He can create the pod, he can view the pod, or even I can enable delete permission so that he should not worry about, because he will be doing testing, right, with many versions of application which he has built, right? He would be doing testing. So I can use, right, I can give him creation, view, or delete also, right? Or I can give only create or view, create and view, right? So we can define at a pod level or at a service level, right, to control Kubernetes operations at people's level, right? Whoever wants to use my Kubernetes cluster, that is people, and I want to control their operations at a resource level, right? These are Kubernetes resources, right? So RBAC is all about that, role-based access control. So role based on Kubernetes resource, and we will access, we can control their access based on creation, removing, view, delete, all that thing we can do, right? For developer, what all we want to give, essentially he can view the pods, right? Or he can create the pods if he wants to. So I can enable a creation of pods so that he can deploy the application, and then he can look at it and he can figure out, right, whether whatever the solution has been built is correct or not. So he can perform his activities related to his application. Then I can enable delete also, right? So he can delete the pods also so that he can fix the issue and bring the pod again, right? So he should not be dependent again and again on me. I can give him the access, right? Or to certain access, even for config map, if you want to set some environment variables, config map is nothing but environment variables. He can even do that because it's part of the pod creation. Pod means application. So I can enable like this. So what all we need? So API version, kind, metadata, and there is no spec section. We have rules, right? Role based access means we have to use Kubernetes rule-based book, right? Kubernetes has used role-based things which is controlled through rules. Rules is nothing but enable, disable. What permission you want to give, create, delete, view, all these are nothing but a rule. So you have to define a rule based on Kubernetes resources, and that is what we have to use this YAML template in the form of API version, kind, metadata, and there's no spec section, we have rules, right? And it's very straightforward, right? So we will go and we will do it, right? So I'll just come here and, or let me explain it to you. So API version, as I said, RBAC authorization Kubernetes, which is coming from here, right? This is version, API version, right? It is coming from here, right? So, all right. So this is coming directly from ABI, RBAC authorization Kubernetes.io and V1. So it is also V1, but we have to give the full API name and then the version. All right. Kind. What I want to create a role. That, as I said, there are two roles. One is role, simple role, which is a developer level or a group level or individual level. Another cluster role, which is basically admin. Right? If I want to make multiple people admin, because there will be multiple people come in multiple shifts. Right? We are on 24/7 support. Right? And people will come in multiple shifts. So few people come, 2-3 people come in morning, 2-3 people come in afternoon, 2-3 people come in evening. So we have to give cluster role to those people. But for rest of the people, we have to give only role defined based on Kubernetes resource. So I am going to create a role, and I'm just giving the name that this is going to be a developer role. You can give any name. You can give support engineer role. It is just a name, right? How your teams are organized, how you call your teams in your organization. That way you can say developer role, testing role, support role, engineer role, or project based role like .NET development team or Java based Java application team or Python application team, whatever you want, you can give it, right? And rules, right? So this is very simple, right? I'll explain this block, and then rest is all repetition, right? So this is very simple. API groups, right? All these are API, right? There are groups of API in Kubernetes, right? Huge list, right? So if you just say, okay, tilde character. So all these are group of APIs, right? Many things are there. So if you want to include all, what you have to say, right? In the square bracket, just say empty. Don't list anything. If you explicitly mention the name of API that you want RBAC or storage or replica set or deployment or a pod, right? That means the only that API will work. I say API groups and I want to include all. All means don't mention anything. Just keep it empty, right? So it will select, right? It will not explicitly pick any random API, but it will pick everyone because it's empty. Empty means all, right? I have not identified that, okay, only select this API from the group. I'm not saying that. What I'm saying API group select all. So empty, I'm not mentioning the name. That means it will select everything, right? So this is the thing. Now, as I said, RBAC, right? These rules will work on Kubernetes resources, right? So here I say, okay, I want to give access on pod level, right? Pod level. Verb is nothing but permissions in Kubernetes. Alright, resources are Kubernetes resources like pod, deployment, secret, config map, all these are resources, right? But verb is permission. So what I want to do, I say, okay, include all APIs, but for which resource only at a pod level, right? So at a pod level, and verb means permission. So he can list the pod, yes, he can view the pod by kubectl get, and he can list the pod, or he can use get command, right, on the pod directly, right? So pod and list, they are same, right? And then he can create the pod, yes, I'm enabling the permission that he can create the pod also. Then he can update the pod also, right? If he wants to change something in the pod, he can update the pod also, and then he can delete also. So basically what I'm giving, get means view, he can create, he can update, and he can delete. So these 4 permissions I'm giving only at pod level. So that means he cannot do anything other than this permission. What is the permission at pod level? He can list the pod, get the pod, create the pod, and update or delete the pod, right? Even deletion permission. Sometimes we don't give delete, we only give this thing, right? But we know that this team is matured enough and they are already trained on Kubernetes. We can have some faith on these guys that they can delete their application and they can recreate it, or they want to update, they can update it, right? So I can do, right? Same way, if you want to give multiple permission, we can use array, right? Array is denoted by this thing. So I'm using array, repeat all these things, only the values will change. So API group, yes, he can use all the APIs, not explicitly one or two, right? So empty means all. resources. This time I am giving access on config map. What he can do on config map? He can only create, that's it. He cannot view, right, other people, or he cannot delete it, but he can create it, because for his application he wants to set few environment parameters. So he can only create it, but he cannot delete it, because I have not given him access. Right? Later if I want to give access, right, just say comma and put the permission in the bracket, comma and put the permission in bracket. But here I have given only create. But if you want to add few more, right, so you can do like this. Right, we can do like this, but I don't want to give him, so only create. Anything else, so you can use secret also he can create. So likewise I can use array at a pod level, config map level, or secret level. I can add few more like deployment level, replica set level, all that thing I can add just by repetition of this thing. Right, so the structure is API version, kind, metadata, and there's no spec section, there's a rules. And how do you define rules? Just like this. This is the block you have to remember. Right, API groups, resources, and verb. Resources, Kubernetes resource, verb means permissions, and API group means RBAC is controlled through APIs. Right, so RBAC group and mention all. Right, and if you see, I'm using square brackets, so everything will be inside the bracket. Right, because we have multiple things, so we can have like this. Right, don't use comma and here say okay deployment. Right, don't do that. It is always good to explicitly define it. Right, don't take shortcuts. Right, it may work, it may not work, but don't use shortcut. It is always good to use in this array format. All right, you can do that, but this is the thing. Right, any questions? Right, are you with me? So we have created this thing. Let's go and apply kubectl apply -f and a role. So we are defining the role. It has created. Right, what is the name we have used? Developer role. Right, as I said, Kubernetes some rule for remembering the commands. Right, whatever there is in the kind, that means I can use get command and disguise command. So kubectl get role. Right, so what we have created? Developers role we have created. What is the time? This is today's date and time, 7th May. Right, and this is the time, this is UTC time. Right, so 5.5 hours you have to minus, and this is the time we are using. Alright, so this is what it is. Right, so kubectl get role. Right, if you want to describe the role, right, you can describe the role also. So kubectl so here you will see, right, so we have created the rules on resources. What are the resources? Config map, secret, and pod. They are arranged in chronological order. So C will come first, right, and then S and then P. Right, so here create, but here we have given list, get, create, update, and delete. Pod level we have given multiple points, but at this level we have given only this thing. How to verify? It's very simple. Whether these policies are enforced or not, it is very simple to go and verify. How to verify? We use one command, right, and that command is kubectl auth command, right, because it is part of authorization. All right, so now I have created this role, right, but I haven't assigned this role to anyone. Only create. Right, I can use multiple role for multiple teams, but which team I have to assign this role. Right, so assignment in Kubernetes we call binding. We have to bind this role. Right, if you have seen yesterday, we were PVC and PV has to be binded each other. Right, and we have to always verify the state as a bound, because there has to be binding. That means both are assigned to each other and handshake is done. Same way here also we have to assign the role, and assigning we call by binding. All right, so I have to create a binding. Right, so role binding. So we created the role. Right, we created the role, and let's say in the step 2 we'll do binding. Right, so this is my step 2. Right, group or user, individual user. Right, at both level we can assign. So we will do this binding. All right, so and here what we did, right? So here, all right, so we created the role. And then next step is we should bind the role with the user role bind. Bind means assigning. Right? So that is what we have to do. So we did it here and then we can verify, right? So next step, binding the role and check. So basically next step is verification step. So step 3. Right? So this is already we did. Alright, so I'll just go and verify. How we will verify? Let me first bind this role. So we will use this role binding. Is Shubhu joined? Not yet. So here, what we are doing, we are using same RBAC authorization is my API version, kind, and right, kind is what? Role binding. Alright, kind is our role binding. Alright, so we can use role binding. Right, means assigning. Whom we are assigning? Let's say development user, right? Dev user, right? And this is I'm using dev user for developers team, and I'm using binding, right? Slightly big name just for because I want to use for which team we are doing. So for dev user, right? We are assigning to one user. So kind is user. Right? There are two kind. One is user, another is group, and basically three. We can assign this role binding to at a user level and mention the user, dev user or a test user or a support user. You can define, or you can define at a group level and you can mention, you can give the name, right? Maybe .NET team or a Java team, Python team, support team, testing team, right? Any team you can define. So we can use group or user. So we are assigning at a user level. API group, this is the API group which we are defining, right? So here we are using only this API, right, for assigning, right, explicitly, right? Not all the API, only this API for role assignment. And then if you see here, API version kind metadata, last time where for the role it was, right, rules. But when you assign, it is subject. Subject means this role is subject to whom. That is why we use one property of YAML called subject. So this role I am binding and it is subject to whom? It is subject to a user. That which user? Maybe a development user, right? So I say dev user, right? And who is controlling? The RBAC authorization will control. This API will control the access when you assign it, right? Not all the APIs, only this particular API. And then you give the reference. Okay, you're assigning this role to a user. Your username is dev user, and it will be through automatically through the RBAC authorization API, right? But you have to give reference, right? To which reference? Role. Because what you're assigning, role you're assigning. So you have to give the reference of your role that you want to assign. So that is why we have a property role reference, because I want to assign this role. So you have to give that, okay, I'm creating this binding. Binding is nothing but assignment of the role. For which role, right? So you have to give the reference of the role, right? So here I am assigning to a role which we already created, right? And what is the name of the role which you created? We created developer role, right? Isn't it? So if I just go and check my previous YAML file, we created role. Yes. What is the name of the role? Developer role, right? So the name of role is developer role, right? And who is controlling API group? So we are using this role. So if you see, it's a repetition of property only, right? So this is subject to whom? This is subject to this user and with reference to role. Which role? This role. So this role has to be created. So it is something like PB has to be created first and then PBC. So assignment means you have to first create the role, then only I can assign, right? Logically, I cannot assign without creation a role. role has to be there. So that is why we are taking the reference of role which we are assigning, right? So give the role name, and this API group, right? So if you see the property, these properties are very less. So this role is subject to whom? This role is subject to user. So we are not assigning at a group, but at a user, right? And then we can just go and we can assign it. Get, this is the role, kubectl get role. We already created developer role, right? And here this developer role we are assigning, right? So kind is what is this developer role? It's a role. So kind is role, name is this, and we are assigning to this dev user. All right. What is the binding name? You can give any name. So I've given with the reference of dev user. I've given this user because we are assigning this role to this guy. And who is this guy? This comes under developers category. And what I'm doing binding means assigning. All right. So that is how I have taken the name like this. Right. Let's go and apply. Right. And use this YAML file. All right. And then just say get role binding, right? So what is my kind? I can use for my kubectl get command and display command. So it is role binding. I put it in lowercase. This is the role binding which we created. Slightly bigger name, right? Because I wanted to point to this dev user, and this dev user belongs to developer and binding, right? So this is the binding we did. And we assign to whom? We assign to role, right? If you see the display of this command, right, only 3 columns. So this is the name of role binding, right? By the suffix binding I've used. So this is my binding name, and this binding is assigned for whom? For the role developer role, right? And this developer role we created, right? Somewhere I displayed, right? Get a role. So which role? Developer role. So that is how you have to do assigning. So you have to create 2 things. One is define the role based on which resource, what permission. Those are the only things we do in role. And then assign role binding to whom. So you can assign at a 3 parts, right? One is at service account. Service account means you want to give higher permission, not as a normal, right, list view or update, but you want to give some kind of admin permission only for application specific, right? Some users, they want admin, local admin for their application testing, right? So maybe Jenkins level, .NET level, Visual Studio level, or Python level, we can use service account only, right? But we don't give service account permission to everyone. Service account is something like local admin, right? And then normal user, we use user. If you want to applicable, this role is applicable to group of people, then use group, right? So only type will change, rest all will be same. Name you can assign any group, right? .NET group, Python group, right? So you can define, right? Instead of user is dev user, or you can use group, right? So that way we have these 3. Everything will remain same as is, right? But whom it is applicable to, a user or a group or a service account in special cases, right? We do that. So this role has been assigned as a developer name, right? Now to verify, right? Verify, right? So if I say describe role, this is my describe role, describe role, developer role. So what permission we have given at a pod level, he can list, get, create, update, and delete, right? At a secret level, he can only create, configure, only create, nothing else. So how to do that, right? We have command, kubectl auth command, right? Kubectl auth command, and we have can I, right? We can check in Kubernetes. So this is an argument, right? So it's Kubernetes commands are talkative commands. So this command is slightly funny command. So kubectl auth and say can I, right? What can I do? Can I create pod, right? I think I already have the commands here. Yeah, can I create pod as a dev user, right? So otherwise it will take root user. If you say can I create pod, right? It says yes, right? Type error create, right? It says yes, right? If I say can I delete pod, it say yes, because I'm a root user, so I can do all the things, but I want to say hyphen as dev user, right? So as what is our user? Dev user, right? Name is dev user. So as dev user, it is 2 argument, not 1. As, right, dev user, all right? So I'm saying that At this level, he can delete the pod, yes, because we have enabled this permission for him, right? Can he list the pod? Yes. Can he update the pods? Yes, right? And he can create also, right, as a dev user, because we create for a dev user, right? So can he create pod? Yes, right? So same way, let me go and check. Can he create config map, right? Config map. So yes, he can create, right? Config map he can create, but can he delete it? Let's check, right? It says no, because I have not given him permission to delete it, only create. If you see here, config map is only create. So he can create, but he cannot delete it. Can he update? Right? No, because I have restricted him. So no update, no deletion, but he can create. Yes. So when you say create config map, right, he can create config map. Same way, if I change the type of a resource instead of config map, if I just say him a secret, so he cannot delete secret. But if I say create, because I've given him the permission of create, right? So he cannot create. So if you see, right, why create is no. Create secret, secret spelling. What about me? I can create, it says yes, which is fine. But what about dev user? He cannot create secret. So did I made a mistake? Secret, let me see. Secret is at a cluster role, then we cannot use it. I think it's a cluster role. kubectl API versions, API resources, not versions, resources. Okay, and let me check secret. So grep secret. So it is a cluster level, right? No, not at namespace. It's a namespace level. Secrets. Okay, secrets. Okay. Okay, I made a mistake. Let's go back. So he says no. That means we made a typo error. So let me go and correct it. VI role binding. So it should be not role binding, role. So it should be pods, plural, config maps, and secrets. I think last time I didn't modify this file. That is a lot of things are still showing old.
The code.
Sorry.
View your file once again. Yeah, the code.
Yeah. Today is Sunday and I need to be relaxed, not working like a hard worker. So I will not work hard. Okay.
Yes, sir. Actually, Sunday. Yes, and
Yeah.
I think it's for your side. It's all day working. Like Monday to Friday, you working in the company, and Saturday.
Very hectic schedule. QCTL delete. What I want to delete? Role binding first. So role binding. No
I have a
problem.
question here.
Yeah, sure.
The question is here, like we just assign the role, the user, and to the group, but how we are using it, like because we have the root privilege when we sign in. So if we are used, so I will not like how we will use the dev user account. I'm using here my root account.
So this Kubernetes cluster is only for you. We have created, or for multiple people. Many people will come, right, and use Kubernetes
Right,
cluster.
right.
Will you give root access to everyone?
No.
Right? If you
So
give root access to everyone, then it will be a problem. So when
right.
you onboard multiple people or you enable the access to multiple people, that time you will use RBAC.
Okay, so
Right?
how
Let's say
they will use the command?
sorry.
Like how the dev user should be my account name on that case.
No. See, if you know the application access, how we give application access, we have some active directory. We created few groups,
Right,
right? And those groups are basically how the whole organization is structured in any organization. We create groups at active directory level, right? Python developer group, .NET developer group, right? Tester group. And when new people comes in and we join the team, we just add a particular group.
right.
Somebody is leaving the company, we'll disable the access, removing that user from that group. So people who are
Oh,
in the particular group of Kubernetes, they will have Kubernetes access. People who are in group of some Jenkins or CI/CD CD pipeline, they have the access. Some people SharePoint access, I've created SharePoint group, and I will add him in that group. So he will have the access to SharePoint application. So every application we are controlling at a user level. Who will need access, who don't need access. Based on that, we'll do the placement or removal from the groups. Which groups? Application groups. Right? So for Kubernetes also, I have added some people in the Kubernetes. Let's say there are 3 developers who have joined the team, right? And 1 tester,
um,
4 people joined the team, right? So I have already enabled the access of Kubernetes. But what all they do in Kubernetes, I can define in RBAC. They can create pod, they can delete pod, I can define.
got it, sir.
So when they come to Kubernetes, I cannot say, oh, you have the root access, do whatever you want. No. I say, okay, you are part of Kubernetes cluster, you have the access. They say, yes, I'm able to access, I am able to see. But what all he will do, I will control him through RBAC. So RBAC is controlling at a resource level. So all my day-to-day operation should be controlled. Whatever role I will define, right? Config map, pod, secret, 3 things we have identified. And in config map and secret, I have given only create access, no deletion. They cannot delete. But at pod level, I have enabled few extra access, right? They can create, they can view, they can update, they can delete.
Okay, sir. I thought we
So
will create user in Kubernetes and then we will log in with that. That's why I was confused.
it would be very difficult otherwise. If you don't create
Right.
group and just users you are creating, you will never know Prashant is having access to how many applications in the organization. We always maintain groups, which is very easy. SharePoint access he needs, okay, put him in the SharePoint group. He has left the organization, I'll check how many group access he has given, I will remove from each group.
Right, sir.
If user, remember 10,000 users are there, or maybe more than that. Wipro people, there are millions people, right? More than 1 lakh people working in India only, right? Or TCS or Infosys, right? It will be very difficult for that guy because there are so many Prashant, which one to remove user, right? So he will just see and check the groups that I'm part of this so and so group, and he will tuck, remove from the group. That's it. New people join, add him in the group. Otherwise, he has to do so many configurations.
Right, sir.
Okay. So kubectl get a role. So developer role. So there was a typo error in my file which I've created. Let me create it now quickly. So kubectl two files. So kubectl -f kubectl - role binding. Now check kubectl get a role. Developer role is created. kubectl get a role binding. Role binding is also there. Alright. So now let me do the same thing. Right. So I can define or describe the role. By the way, that question was good. I missed that portion when I was describing the things. Right. And this you do only one time, right? At team level, not every day's job again. That's fine. kubectl auth command can I create secrets, right? As a what? As a dev user, right? So where's my role binding? Still it says no. So what is the binding? It is done kubectl. Describe role binding. And what is my role binding name? So with the dev user, okay, dev hyphen user. Now it is correct. Okay, so I was giving some different group and which it doesn't there, so it was denying me because it is not activated for any other, only for dev user. Alright, so I can do that. Can I delete the secrets? Because my permission at secret level is what? Only create, right? No deletion. So can I delete it? Secret, it says yes. So we corrected it because there was a typo error only. So I cannot delete it because there is no permission given to me for deletion, but I can create as a dev user. All right. So it's very simple. Let me refresh it so that you should not forget it. It's very important. All right. Normally it will be done by admins, but that's fine. Right. So why I started eating worse. Am I really hungry? I'm waiting for a very decent breakfast morning. Let's see what my wife is going to offer. Okay, so here, if you see rules I have defined, so pods, so we have the pods created this level, right? So just remember, role you have to define, API version is fine, RBAC authorization, kind is a role, we have to define the role, metadata give any name, developer role or anything, test role, support role, it's up to you, right? And then rules, three properties, right? One is API group, right? Use all the APIs because there are so many resources. Which resources? We cannot explicitly mention here. Resource is group and verb is permission, right? Always use plural, right? So API groups, resources, verbs, right? And here also use the resource as a plural, right? So it is not applicable to single pod, multiple pods. Maybe this pod, that pod, front end pod, back end pod, database pod, middle tier pod, any application. So always use plural. Verbs, I can give single permission or multiple permission based on my criteria. It's very simple, right? One permission, comma, another, comma, another, comma, another, comma, it should be in square brackets. So it will take the bundle of permission or group of permission directly. Then same API groups, resources at config level, Same way API group resources at secret level. What you want to give? See, one permission only, use create. Multiple permission, right? Use comma. And it should always be in lowercase, right? So it should be, this was the error, I use only secret, it should be secrets, right? So we verified everything is working fine, right? And once you create the role, you have to bind it, right? Your binding is nothing but assigning, role binding. So here the type will, from kind equal to role, it will change to binding, right? Metadata give any name, right? In my case, I've given slightly bigger because we follow who's the user, which group he belongs to, is he developer, is he tester, right? So we categorically specifically assign this is a developer, and what is this? This is binding, right? So I always use prefix suffix somewhere so that I should not be confused. And here we define the rules for role level, right? These are the rules, and then subject to whom, assigning subject to whom, subject to user or a group, then give the name of that user or group, or a service account, then give the name of that service account. You can give service account is application group name, so you can say Visual Studio SS service account or Jenkins or any other application. So that way, right, we are not using anything but just a normal user as a dev user, right, and give the reference of your role because you want to assign. So this role I'm assigning to a user, the name of user, dev user, and with reference to whom. So I've already created this role, developer role. So developer role, this role binding will be assigned to this 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 role which we already created here, right? And this role is having what all permissions are there. So all the permissions are applicable to this user, dev user, right? So we have assigned them, right? So that is how we have to use two YAML file. One is role binding, right? First you have to create the role, define what permission you want to do, right? And then subject to whom. So for that you have to create role binding, right? And then say subject, this is applicable to this user, right? If you want to use multiple, use this array and put it here, right? So you can use a test user, same permission, right? Or supporting the same permission, then you can take the reference of this role and you can assign it. So role binding is just an assigning. All right, YAML files are not much challenging, but only few changes, rules. It works only on rule based, right? What permission, all permission we say rules, right? But a specific permission is defined as a verb in Kubernetes, right? So Kubernetes resources, verbs are nothing permission. And here instead of rules, you have to remember in role binding, we don't use rules, we use subject because it is subject to whom. The way we talk, even the YAML file commands are also like that, right? And that is the reason this command was a little funny command, right? kubectl auth command, can I delete secret? But if you see logically, the way if I want to ask someone that, hey, support engineer, what role you have given? Can I create secret? Can I create pod? Can I view the pod? Can I update my pod? Can I delete my pod? Right? Commands are also like that.
Right.
All right. So everything is part of the single file which I've already created. This is the file I will share, right? For Kubernetes RBAC and some explanation here and there. And then first you have to define role and then role binding, right? If you want to give cluster role, it will be same structure. It will be replaced by cluster role, right? Only thin line difference. Don't get confused. Cluster role normally we don't prefer to give everyone. Normally you will be playing with roles only. But if you see the difference between cluster role and role, only thin difference, right? So I'll show you. It's mentioned somewhere. Yeah, here. Right? What is different between role? What is different between cluster role? Right? So RBAC basically works on two, role or cluster, which contains basically rules. Right? Rules are nothing but you want to deny or you want to give some permission, or we want to say set of permissions. Right? So it's purely based on permission. What all permission he can do for Kubernetes resources. Right? So role is always set within particular namespace. Right, in particular namespace we do. Cluster role is across the cluster. It's a bigger role than this I can control at a developer level testing because we have multiple namespace. One is dev namespace, testing namespace, support namespace, pre-prod namespace, or a prod namespace, right? So we can control at a namespace level. So this is very well go with the namespace level, right? That is why where we can define this user from this namespace or this group of people from this namespace we can define. But cluster role goes across, right, all the namespaces. So it is non-namespace. That means I cannot specifically assign a particular namespace, right? Non-namespace means it is applicable to not only one but all, right? And resources has
Right.
different names, role and cluster role. What is the difference here? Here is the difference. Cluster role have several uses, right? You can use cluster role for what? To define a permission on namespace resources and be grant access within the individual namespace. That means if you have a cluster role, you can assign the permission at a specific namespace level. So I am a cluster role. Root user is a cluster role, right? I can do cluster-wide operations. So I can control at a namespace level by defining the roles specific to that namespace, right? What else we can do? So he can define permission across all the namespace, right? He can grant the access within the namespace to individual level by defining user or a group. I want to give in developer, I want to give only permission to one developer. I can give that also individual or the set of people I want to assign right? I can also do that, right? So, and then cluster role, what do you do cluster role? Basically at a node level, right? You want to control at a node level because the role will not have a node, right? It is only at a pod level of Kubernetes resource. But here I want to do even the infrastructure activities, and for that I really need a cluster role, right? Because node will be used by multiple teams, multiple people, multiple application, multiple pods will come to that node. So it should be part of cluster role, not at a role. So node and some non-specific like health and all that thing which we do for our internal health check of Kubernetes, that is also part of Kubernetes cluster role. Nobody else can go and check the system logs or health of the other Kubernetes thing. You need that thing, right? And other thing also like pod and all that thing, anyhow we can do it. So here we do few extra things which that is why we have two categories. One is role, another is thing. And if you check my YAML file, it is same. So you already saw the role which we created, now the cluster role. So API version, kind, metadata, and rules, right? Include all the APIs, so API group, and then what you want under resources, secrets, right? And secret, what I can enable, he can get watch list, right? He cannot create, he cannot delete, but he can only see. So any existing secrets are there, he can just go and he can see and he can do, but he cannot create a new secret or he cannot delete the existing secrets. No.
Right, sir.
All right. So exactly same, right? No difference at all. Right. So we can define even that also. If you want to assign at the namespace level, right? So namespace will be omitted in this thing. Here you cannot use namespace, but in for cluster role you can define. In the role you can use namespace also. So it will be applicable only to that namespace. Just add one line here. Namespace, which namespace? Dev namespace. By default we have default namespace, so it will be default. And is giving at a pod level. He cannot create pod, he cannot delete, but he can see, watch the existing. Normally for testing people, we give only this access. Testing people don't need to create pods. Testing people don't need to delete anything. They will just, whatever has been deployed, they'll just go and check the environment and check the functionality. That's it. Their main target is check the functionality of the application. Not how the application is built, how the application is deployed, how the application is running. No, that is not their headache. Right? So here I will mention the namespace, that's it. And here no namespace, right? It will be omitted. Alright, and then binding, role binding for roles, and for cluster role, don't use the same binding. We have a different binding we call cluster role binding. Only slightly names are different, but rest all things are same. Right? So role binding, and here it will be cluster role binding. That's the only difference. Same thing, subject, kind. Here we are using group. Right? Manager group. If you have created this group, this is the group, and then define. So you will define your role. So wherever you have role binding, use role binding. Wherever you have cluster role, use cluster role binding. So Kubernetes will never contradict with each other. Every resources, it has a specific category. Use only those kind categories, right? Which will be part of kind.